an abhar. A very warm welcome for the second day of this Watershed Integrating Science, Sustainability and Society Conference. Hope you must have enjoyed a lot last night. It was really heartbreaking events actually we had. Hello, 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 hello. Harvard.
If there was an emergency, they had to leave. Or is it same party is coming? NG party.
Dr. P.L. Patil. So, today's technical session will be chaired by Dr. N.G. Patil, Director, NBSS, Nagpur, followed by the great speakers here. The keynote address on innovations for resilient dryland agriculture by Dr. Stanford Blade, DDG, ICRISAT, Hyderabad. Integrated digital soil sensing and soil mapping for information-driven soil management by Dr. Asim Biswas, Professor, University of Guelph, Canada. Advances in thermal infrared remote sensing for evapotranspiration and soil water stress monitoring by Dr. Gilles Bollet, Senior Researcher, Toulouse University, France. And Geospatial Technologies for Sustainable and Land Resource Mapping Management. That is by Dr. G.P. Obi Reddy, Principal Scientist, NBSS and LUP, Nagpur. I'll just announce the technical session 4 to here. That is the panel discussion. Role of private sector on data-driven watershed and agricultural transformations. This session will be chaired by Shri Nitin Khade, IAS, Joint Secretary, DOLR, New Delhi. The panelists will be Dr. A.V. Bhavani Shankar, Chief General Manager, NABARD, Shri Prabhakar L., Executive Vice President, ITC, Kolkata, Shri Amit Vatsayan, Sector Lead for Agriculture and Social Sector Advisory, E&Y, and Shri Abhishek Sharma, Deputy Vice President, Research, Sambodi Research and Communications Private Limited. So this will be followed by the lunch break and the technical session 5, impact assessment and community. Challenges in scaling agricultural technologies and determinants of adoption in smallholder systems in Africa by Dr. McWinint Melis, Senior Scientist, ICRISAT, Nairobi. Lessons learned from project on climate resilience in agriculture, Pokhara, by Shri Sagar Bharat Khatkale, DBT Specialist, Pokhara, Mumbai. And lastly, scaling up LRI at national level and its challenges by Dr. N.G. Patil, Director, NBSS and LUP, Nagpur. That will be followed by our valedictory session and way forward. Thank you. Thank you so much. We'll start another 5 minutes time because actually we are expecting the delegates who are staying outside this premises. Thank you. Thank you, one and all.
technologies to deliver watershed treatment faster, more accurately, cost-effectively, and with greater sustainability. Sujala 1 project trailblazed using remote sensing and GIS technologies to support community-led planning, implementation, also monitoring and evaluation of watershed interventions. Sujala 3 moved up the technology ladder by combining remote sensing and GIS with land resource inventory, or LRI. This technology completely disrupts how soil and site-specific data is collected, stored in a digital portal, and interpreted using decision support systems to automate generation of plot-level actionable soil and water conservation, crop selection, and nutrient management plans. All key components in a DPR for watershed management in less than a third of the time is taken through net planning, and at a fraction of the cost. The reward program currently being implemented in Karnataka and Odisha has leapfrogged on the technology ladder by adding advanced hydrological data collection and modeling to LRI and remote sensing and GIS technologies, which provides precise selection, siting and sizing of water conservation and harvesting structures, estimation of water balance, and crop.
We are going to start technical session 3 on technological advances in soil mapping, hydrology, and land use for resilient watersheds. It's my privilege to invite Dr. N.G. Patil, Director, National Bureau of Soil Survey and Land Use Planning, Nagpur. I request to kindly come on the dais, sir, please, and share this technical session 3. The first presentation will be on keynote address on innovations for resilient dryland agriculture by Dr. Stanford Blade, DDG, ICRISAT, Hyderabad. I'll just give brief note on. Dr. Lingadeva Roy, DC, Lingadevaru, DC, Kesrak, Bengaluru. Kindly come on the stage, sir, please. Yeah, thank you. And Dr. Mamata, Associate Professor, Department of Soil Science and Agriculture Chemistry, University of Agricultural Sciences, Bangalore, is present here. A warm welcome to you, sir. Now I just give brief note about our Honorable Deputy Director General, ICRISAT, Hyderabad, Dr. Stanford Blade. Dr. Stanford Blade, the Deputy Director General of International Crop Research Institute for Semi-Arid Tropics, ICRISAT, Hyderabad, with a distinguished career spanning academia and international agricultural research. Dr. Blade most recently served as Dean of the Faculty of Agriculture, Life and Environmental Sciences at the University of Alberta, Canada. He holds a PhD in plant breeding cropping system research from McGill University in Montreal. Recognized internationally, Dr. Blade is an international fellow of Royal Swedish Academy of Agriculture and Forestry and was awarded the Queen Elizabeth II Platinum Jubilee Medal in Canada for his contributions to agricultural science and development. At ICRISAT, Dr. Blade leads efforts in crop improvement, innovation systems, and technology-led solutions aimed at improving livelihoods across semi-arid tropics. Please join me, sir. I welcome you wholeheartedly. Dr. Stanford Blade on the stage, sir, please. Expect big round of applause. And also for the chairperson and rapporteurs too.
You're too kind. Thank you very much.
Thank you, sir.
Just remind me about the slide. My bill? It's possible? I appreciate your help. Thank you very much.
Well, good morning, everyone. It's a great pleasure to be here. Before I start my keynote address, I don't want to be too presumptuous to speak on behalf of all of the delegates, but given the remarkable cultural festivities last night and the cultural arrangements, I think a round of applause for the organizers would be very much in order. This is always the gift to participate in these kind of conferences, to see so many of the rich cultural pieces and heritage, not only of particular states, but last night, of course, to have such an adventure across all of the country was indeed a great privilege. So the organizers have been very kind to give me just a little bit of license to step back a little bit, not only from talking about resilient watersheds, but to think about those innovations of resilience that are going to be so important in the agricultural systems that we deal with here in India, but across the world as well. And the framing to provide this kind of oversight, I'm going to use the three areas, the equation that we use within ICRISAT, where we call it GEM. So genotypes, environment, and management. And you'll recall yesterday in the inaugural session, I spoke about the work that we do in ICRISAT, where we connect agriculture to food, to nutrition, to human health, but we do that on a base of work on soils and biodiversity and using tools like socioeconomics and all of the other areas. But of course, one of those key areas is water. So we'll walk through genotypes, environment, and management systems with the emphasis, of course, on the work that ICRISAT has done with so many partners here in India around revitalizing watersheds and thinking about the landscape. And then to talk a little bit about where those partnerships might go based on our experiences here in India, but also in Africa as well. So the first part of that formula, that equation of genotype by environment by management, are the crops with which we work, but of course, which we all work with, that farmers depend upon across the entire country. So in the case of ICRISAT, we have a focus on those crops that are so important for dryland areas. So we do work on the millets. I'm thinking specifically of pearl millet. I just had a note last night from our colleagues in Zimbabwe, where we have released with our national partners 2 biofortified pearl millet lines that have dramatically increased iron and zinc content, biofortified, bioavailable, to make this available to the people that use those particular lines. But of course, we also do work with all of the other millets, and you will recall that in 2023, so many of us in this room were involved with the Year of Millets declared by the United Nations, and that was so ably led by the government of India and so many of the states, along with ICRISAT and several other international partners. So we really see the millets taking off, and I think specifically of the small millets. When I was coming through the airport in Hyderabad, there was a banner in front of one of the shops, and they were selling these beautifully packaged snacks and other products made from proso millet, from barnyard millet, from so many of the other crops that are there. So we see a real revitalization of where things are going. ICRISAT also does work on sorghum. So thinking about where sorghum is a fit in cropping systems here in India as well as in Africa. So a lot of the activity around cereals, but we also do a lot of work on pulse crops. So doing the work on chickpea, where now we are producing lines using the speed breeding techniques that you may be aware of, where in the old days we could maybe get 1 or 2 generations a year in our breeding programs. Using this rapid generation technique or speed breeding, we can now do up to 5, 6, or even 7 cycles a year. So as you know, when you're trying to fix genetics, when you're trying to enhance the opportunities within that plant breeder's equation, this gives us a great deal of power. We also do work on pigeon pea. And you may have seen in the press recently where an ICRISAT line is ready to be released in so many states here in India that has remarkable heat tolerance capability. It can tolerate up to 45 degrees C, and that means that not only are we working in the case of pigeon pea to increase the yield, the productivity within those areas where pigeon pea currently grows, but of course this kind of heat tolerance gives an opportunity for that crop to also expand its acreage. And for colleagues here, you will know the national mission, the Pulse mission to enhance pulse crops. These are the kinds of breakthroughs on the genetic side, around cultivars, around new varieties, that will really enhance the possibility of really making progress. And the last crop that we work on is groundnut, and some of the recent work over years has been around high oleic groundnut, making the crop very much more nutritious, that it's more effective in so many areas of not only use of the crop as a food, but of course for other kinds of processing opportunities. So when we think of all of these crops, focused on the drylands, working on using the newest technology to enhance that genotype, this is what we need to do. And of course, we also know that the Ministry of Agriculture and Farmers Welfare, and I think even the Honorable Prime Minister, has made comments with respect to diversifying the cropping systems within India. There's actually a stated policy now of the government of India to reduce the amount of rice, of paddy rice, by between 5 and 7 million hectares. So what will replace that particular cropping portion of the cropping system? We believe that there's a real possibility for these kind of crops that I'm speaking about to actually diversify the cropping systems, to enhance the nutritional density, the opportunities for smallholder farmers that are producing these crops. So that whole area, not only of the Pulse mission, but of course the vegetable oil mission of the national government, we feel that our work is very much aligned. So that's that first piece around the genetics of the work that we do. But the second portion is around environment. I told you yesterday that the dryland areas of the world are critical when it comes to arable land, and indeed these dryland areas make up a significant portion of the land that is being used productively across the world. But I think you can see in this slide that we also face significant challenges within these dryland areas. And one of the key issues that comes here is that so much of this dryland area is being used, is being held by smallholder farmers. So the kind of implications for volatility, for the other activities of farmers that do not have a way necessarily to have a financial safety net or others, we need to make sure that the interventions that we speak about really make sense and that are really in the best interests of these smallholder farmers. And of course, we know in addition that there are these challenges. I've made the point with respect to who is active in these dryland areas, but the bigger issue here is around the volatility that's likely to come in the future. And the specific point that I would make in the area of environment in our G by E by M equation is around the implications of climate change. So when we look across the world, we know that these dryland areas are going to be particularly vulnerable to the way that the climate is likely to change. But I want to make a very specific comment, and I would welcome climate modelers and others that are in the crowd. The literature that we've been seeing over the past number of months, over the last 18 months, shows that in India there will be a range of possible outcomes using those most sophisticated models that are being used here within India, but across the world. The implications are that yes, some of the drier areas will get drier, but it's very possible that some other portions of India will actually become more productive based on enhanced precipitation or by reducing the amount of evapotranspiration. But I think it's not just off in the future that we're dealing with this. I was in Zimbabwe a few months ago, and we were speaking to the Honorable Minister of Agriculture there, and if you know the agricultural systems of Southern Africa, it is a maize-based rural system. Maize is growing on a significant majority of the land within Zimbabwe. But it was the observation of the Honorable Minister that based on the crop failures that are happening 1 in 3 years, sometimes 1 in 2 years, Zimbabwe as a government is starting to think about what are those other options. You may also know about fall armyworm and other issues that are facing the maize crop. And the government, and we have a research station in southern Zimbabwe just outside of Bulawayo, we're working very closely together to think about what is the role of the cereals where we work in, of course, in sorghum and in the millets. Where might they fit in this changing environment that we are dealing with? So I appreciate your patience, but I wanted to lay that groundwork that the discussion that we're having around resilient watersheds is really linked to the genetics, to the environment. But now let's talk about management and the way that ICRISAT is partnering with so many groups across India and Africa to make progress in this area of an enhanced way of using water more effectively. You saw this slide yesterday. Dr. Afarisifa used this in the context of policy and other areas. I would just use it to remind us that there really are levers here for us to utilize when it comes to thinking about how we can work within the systems that currently exist and the issues that we also need to be able to face. And I feel this is very redundant, but I think some things it's good to repeat because I enjoyed so many of the talks yesterday of the work going on here in Karnataka and the work going on in other parts of the world, that really this is our playbook. These are the tools that we have within our toolbox to start thinking about how we really do generate those resilient landscapes that take advantage of the water that's made available, but to do things in ways that are innovative, that are inventive. And the ICRISAT model has been very much thinking about how you tie together traditional water handling systems that have been used for centuries in many parts of India, but what are those integrated approaches? What can we do differently so that the water that is available is used as effectively as possible? And I put this slide in to remind myself, so many of you, I know that the representative of the World Bank, a number of the World Bank officials spoke about this, as did the Honorable Minister yesterday, the role of communities. So the next portion of this talk is around the work that we do in UP, specifically in the Bundelkhand region and especially in the district of Jhansi, where we started from a pilot scale activity around rejuvenating water supplies to now this almost 30,000 hectare role. And we see a tremendous expansion. We were just having discussions with the Secretary of Agriculture and Farmers Welfare. So how we can spread this even beyond the work that we're doing in Orissa or doing work in Bihar. So in this case, it was very much that first bullet of the previous slide. We have a good knowledge of the catchment areas, but of course we were losing a significant amount of that water. There were things that we needed to do to make the system work. And I'll go through a series of slides, but I'll just tell you what I'm going to tell you. We started with thinking about how to capture some of those waters out of those catchment areas, and in this case, it was the establishment of this core wall. This core wall that started to hold up some of that water, and then the next steps were connecting that to the traditional systems that you're all aware of the Haveli ponds, of the farm ponds, of the existing stream networks, the canals that existed to make those more viable. And by some very intentional and strategic bunding, all of a sudden, all of this water was now not just being lost or being either by quick runoff or by evapotranspiration, but it was able to start to change landscapes. And of course, the proof is always in what you see. And in this particular case, we're looking at one of the villages within this area where capturing water from a specific watershed, you see the kind of capacity that was being brought together, and you can imagine the wealth, the richness of that water as you start to think about how we might use this more effectively. So I've made the case already for genotypes, varieties, cultivars. I've made the case for how we respond within our various environments. But now, even within the management system, and even the management system specifically about water, it's these kind of infrastructure changes, like the ones that you were doing through Reward, that's starting to open up a whole array of other management opportunities as well. So starting to think about these surface runoffs, to think differently, an integrated approach using traditional systems, but also new innovations as well, so that we can maximize storage, retention, recharge. All of these things start to fit together. And you can see this is the kind of impact that we've started to observe over a period of years within this work, within the Bundelkhand region. So thinking about how we capture this water, how we move this water effectively, so that at every stage as it moves through the various systems that I've described, right from that original capture through all of the other ways that we can start to use that water, that farmers can use that water more effectively, and again, starting to see the impact in the villages that are in place. So what does that actually look like? I think there was some discussion of this yesterday, but just a little bit of the data to give you a sense. Once you start working on the water table, it's no surprise that things like the kinds of wells that are rejuvenated are dramatically enhanced. Can you imagine when you're farming in an area when a well is in the state that you can see in that upper image, and then through some integrated interventions of traditional and new ideas, you start to see water table changes of the sort that you can see here, where the numbers of wells that are being rejuvenated and even the just the volume of water that's starting to be made available to the communities, to the individuals in these particular areas. It's a dramatic, life-changing kind of thing. And of course, now that I've talked about genotypes and environment and management, we start to see the kind of productivity that occurs. There's a lot of opportunity now, not only in the management of the water, but the kind of selection of crops. I've already made the case that a number of these dryland crops are ones that we should be thinking about where water is limited. And if there's an opportunity to start moving away from some of those crops that are excessive water users to ones that are more water efficient, that have an enhanced water use efficiency, you can see the kinds of productivity gains that we are achieving. Now, I had a fascinating conversation just before the session this morning. These are still early days. In some of these areas, we've been working 4, 5, 6 years. But I think we have to be very careful about thinking, are these long-lasting? Are these sustainable changes? From what I can report, from what we have seen so far in the Bundelkhand region, it looks very promising. It looks very optimistic. But again, you'll just see the kind of opportunities that are there, not surprisingly, once that water becomes available. And Dr. Victor talked about this slide yesterday, and he made a particular case for the number of families that were coming back into this region because of this availability of water. But I would draw your attention, there's a reason why people are migrating back into this. I love that phrase of reverse migration. You can see the kinds of net income in the various cropping seasons, the enhancement because of the interventions that we've been doing. And I need to be very clear, we do this work in ICRISAT in close collaboration, of course, with the government of Andhra Pradesh, with the ministry, with so many of the other groups, in addition to the union government. So this is truly a partnership of the work that we do, but there's no surprise that you see those data before you, and you even see now the inclusion of livestock as fodder and other opportunities come. When I was speaking about genotypes, I was focusing mostly on, of course, the grain, but there are so many areas here in India when I talk to people, whether it's in Rajasthan, whether it's in Kashmir, producers are also thinking about how can they produce enough fodder for their crops. And here, in these very difficult environments, in these very challenging environments, these kinds of interventions are also giving new options for producers in that management section, not only around crops, but also to make these more of an agropastoral kind of opportunity as well.
Stanford, can you hurry up?
Good.
Please.
I will take 3 more minutes. Again, seeing is believing. 2017 to 2020, you can see at the same time of the year that overall greening of the location, again, due to the availability of water. We're doing similar work in Orisha, and I would be happy to speak about that after the meeting. But the key area, takeaway from this slide is the amount of fallow, where people were trying to build up the amount of moisture within their soil to grow a crop. With these kind of interventions, the fallow numbers were going down, and the productivity of the overall land area was going up. And of course, we heard yesterday as well, when you start to have these options around availability of precipitation and moisture, you can do other interesting things to increase value for the people in the community. And I will just maybe just pass over this. Happy to talk about other ways in which we're using that water in a way to effectively produce a number of interesting crops. But I'll just also make a comment in addition to the work that we do in Maharashtra, is in the work of Africa. And I would say here, if the comment was made yesterday about South-South cooperation. Through the leadership of our Director General, through Dr. Pathak, ICRISAT is just the facilitator and convener, but has started an international center of excellence in South-South cooperation in agriculture. Have a look at the website. You can go to the ICRISAT website, or you can just look up ISSCA. Many governments here in India are participating. Many governments across Africa are also participating. And there's a real opportunity for the things that we are learning here in India to also be applied in various parts of Africa. We certainly are doing work in Ethiopia. We heard a great presentation from Dr. Millionaire yesterday, so I won't go excessively over this, but certainly thinking about reducing the volatility, slowing down flood water, using it more effectively. And I spoke earlier about Zimbabwe, where just using the simplest tools to be able to take the biggest opportunity to control water and to use it as effectively as we possibly can. In my last slide, I will just point out that ICRISAT, amongst many partners, received the UNDP Mahatma Award for this regeneration work that's been going on in Bundelkhand and other areas. And the last concept I will say is this idea of vapor shift. So in these regions that I've described, we were losing water through just pure evaporation, and now we're actually running that water through crops, through plants, to produce a whole array of economic outcomes for producers and for communities in that region. And that's a very exciting start to how we can work together to really create watershed resilience. Thank you very much. Thank you.
Thank you, Stanford. We'll take only 2 questions, if there are any.
I see one in the middle.
Yeah.
Yeah, good morning. I just want you to elaborate on disaster risk reduction, because one of your slides is mentioning about DRR. And how do you think climate change can affect North African countries, even the Indian scenario? Can you just, because the Act is amended now, Disaster Risk Reduction, Disaster Management Act 2025 has come into force, wherein the urban local authority and the district authorities are responsible for any environmental degradation. On DRR aspect, can you just elaborate on how they can be able to manage it? Thank you.
Yeah, thank you for the question, and I'm not sure I got all of the elements, but certainly I made those observations about those broader issues around climate change, but I think it really is working together with the local authorities, with state authorities and others. This is the way that we need to be able to respond to these kind of areas. And I was, in the interest of time, maybe if you wouldn't mind just putting my deck up, I'll just, maybe for the last question, I'll also just put, the Honorable Prime Minister made a comment specifically. I'd just like to get to that last image in my slide deck, which I should have pulled up. But even the Prime Minister is thinking about how we need to be more effective in capturing water and doing the work that we are doing, involved with so many partners in Jhansi and Bundelkhand. So I think there really are some opportunities that we need to follow up, and so thank you very much for the question. If the slide doesn't come up, I would just say that the Honorable Prime Minister tweeted about the work that's going on in Jhansi, and he made the statement about the importance of water and the critical nature of having communities involved, so maybe we can circulate that sometime as well. Thank you very much for your time. Thank you.
Thank you.
Thank you so much, Mr. Stanford Blade, sir, for your analytical depth, clarity of thoughts have set a high standard for future perspectives on watershed management and the genetical approach for the cropping systems, and with beautiful illustrations. Thank you. So now I call upon Dr. Asim Biswas, Professor, University of Guelph, Canada, to present a lecture on integrated digital soil sensing and soil mapping for information-driven soil management. Just to give a brief note about Dr. Asim Biswas. Dr. Asim Biswas, an internationally acclaimed soil scientist and professor at the University of Guelph, Canada. Dr. Biswas leads cutting-edge research in digital and precision agriculture, focusing on sensor-based soil characterizations, digital soil mapping, proximal sensing, and sustainable soil management. He is a fellow of Soil Science Society of America and Canadian Society of Soil Science, fellow American Society of Agronomy, and fellow Indian National Science Academy. I wholeheartedly welcome you on this stage, sir. Please.
Good morning, everyone. I know yesterday hangover we were all coming out, but I see it's already full. Thank you very much for the organizer. Thank you, Chairman. Thank you, Deputy Chair, and thank you all the delegates for having me here. I will take you through a little bit journey for next 20 minutes. I will not talk about watershed, but what I will talk about the elements we need to provide services at that watershed management. So as the session was put together, the technological advancement and innovation. So I am going to show you some of those technological innovation and advancement that could help us in creating watershed management. So before I go, I just want to ask you a question. So when you go to a doctor, what do? You directly see a doctor, or there is a nurse who takes your data, like for example, weights, height, ratio, blood pressure, anything like that. So generally, the nurse collects data, put it into a folder, then hand over to the doctor. Even if sometime doctor is not happy about that, then ask you to, okay, go, you get a blood test, X-ray, MRI, CT, whatever it is. So think about the same way. I'm going to talk about not human health, but the soil health, and soil, which is an integral part of all this talking we have been doing since yesterday. So I'm going to talk about soil and why should we do the same thing, why shouldn't we do the same thing for soil? If for a human health, we can actually get the data, develop a management strategy. So that means I just don't want to swallow any medicine I want, very specific medicine I want. Why not we manage our soil with that specific information? So we need to have that data. If doctor writes a prescription based on a data, why not we manage our soil based on that data? And the other thing, like earlier, if you need to understand, okay, if I have a blood sugar level high, I need to send the blood, get the data, it takes time. And by the time probably I have developed something, I ate something and it changed. But now we don't have to wait for that long. We just, with a pinch of our finger, we can get the data and see what is the status, then I can decide whether I'm going to take an insulin or not. So that means the managing my blood sugar level is instant. Why can't we do it same for the soil? Why you have to take the soil sample back to the lab, wait for a week, 2 week, 3 week time and getting it there? Why not we take some approaches that can generate data for the soil? Just wanted to give a background. This is not about science, but now I'm going to talk about how do we generate the data and how do we take that data and information in managing our soil better at a field scale, at a watershed scale, at a regional scale. So in this case, two different things I'm going to talk about, sensing and mapping. Sensing is just like the way you are sensing, is almost like our sixth sense. How do we measure that? How do we test it? And the map, so we are creating that spatially interpolated, spatially aggregated, spatially disaggregated information that could help us the managing. So the first thing I always say, if you can't measure it, you can't manage it. So that means when you go to a doctor, needs the data. So that data, the better measurement can only help you to do a better management. Think about how this management is actually taking us to the future. So we say we need to manage our soil for today because we need to stay in the business. We need to produce enough crop to feed our family, to feed everybody. But also not destroying our environment, helping our environment to grow better for tomorrow. So how do you actually manage that? So we need the data. We try to bring back soil sample in the lab, but if you really want to do that, often it happens like harsh chemicals, time, cost, and other things that restrict your information. So we shifted to a sensor-based measurement. And again, I'm not saying this is new, or last 40, 50 years we have been doing soil sensor measurement. Sometime you can put a sensor in the field, get certain sort of data over time in a high resolution, or you can put some sensors on a moving vehicle and get the data in a much larger area in a much shorter time. That means in a spatial data set you are talking about. So based on that, what we are following in our research, again, as I said, I want to talk about innovation, and a lot of research is coming from our research group, and that how this is supporting the decision making and watershed management. I will give a watershed example at the end, but we follow a 5M principle. The 5M principle we are talking about, the sensor I mentioned. The sensors will always give you that indirect data. So we can put a sensor on different platforms, on a moving vehicle, on a drone, on a satellite, on an airplane. We can get the data based on the scale we want. So that's we call it as a measurement. We measure some of the indirect characteristics or responses of soil. It could be optical, electrochemical, electrical, ion selective electrode. So anything you talk about, those are different principles we can get the data, but these are indirect measurement. What you need to do, you need to connect back to the soil property. That's what we call it as a modeling. So that means we want to develop the relationship, what the sensor response is, what is the lab result. We still need to do lab analysis to establish those sensors. Once we model that, those are the point data set. Unless those data sets are spatially extrapolated and spatially like showcasing an information on a map, and we are developing an LRI, so a lot of cases that specially disaggregated information we want to showcase and make a decision in that local scale. So that's why we call it as a mapping, but again, pretty map doesn't help to the farmer. Yesterday the question are there, how LRI is going to help the farmer is again, is a lot of information on the LRI card until we put it into a management and talk about how they are implementing on the ground. That's what I call it as a management. But we don't want to stop. We want to see how it is improving. Even Stanford was talking about, he would like to see how it's developed. That means we want to continue monitoring that, so that if it is doing better or worse over time, that we need to understand it. So this is why my title of the presentation came in, Integrated Digital Soil Sensing, Modeling and Mapping for Soil Management, for informed soil management. So I'm going to talk you through a little bit about some examples. One of these things, measurement across scales we often do. If we really want to look for that point scale sample analysis versus profile along the depth or at a field scale or at a landscape scale, how we are going through that analysis. So at a point scale, we often develop sensors and technologies that could give you a very high resolution measurement at that particular sample. It could be a microscopy scale, that one of this measurement we have done, that's patented technology to get very high resolution soil image. Digital image, we convert that digital image into soil information, we take it to the field, we use a handheld soil pH meter or an EC meter, we take it out to the field, on the spot measure, watch the probe, go into the next point. We develop some spectrometer so that it could go up to a depth and get the measurement. We get a profile measurement, we collect profile data, we scan with the different sensors including spectroscopy, I will talk about that, or imaging. So we are almost like a profile scan we are doing to get the data along the profile. So we are not talking about the surface 2 dimension, we are going with the depth to get a solid 3-dimensional information. At a field scale, we put a sensor on a moving vehicle like an off-road vehicle or a truck or even a tractor when the operation is continuously collecting the data, and on almost like a real time, it could help us understand the variability of that field. Putting the sensor on a drone could be another one. But we don't often stop there and try to correlate back to a regional scale. Whatever the local observation is there, we try to develop a predictive relationship and expand that over a larger area. So this is two of the example. Bottom, I know yesterday we looked at some of the China Yangtze River. So this is the Yangtze River, Yellow River area, not the Yangtze River, on the groundwater sustainability and how the locals are really thinking about the groundwater management. That's a little bit of different. This is a large scale soil salinity map we're talking. I'll bring the example, but a little bit of more detail. That point based image analysis, the one sensor technology we're talking about, we can get a very high resolution image like that. Then we process with the ML and AI technology or image processing, just the way everybody, you are opening up your phone, is checking your face and actually analyzing that. So we are taking some of those examples for like a self-driven car to facial recognition to fingerprint recognition and bringing up those things into soil science. How do we identify some of the soil properties? Of course, many of those things we require to do at lab testing at the beginning to develop that predictive relationship. Some cases we are actually putting deep learning technique is rather than extracting the images, we are trying to train the images to attach it as it is. So deep learning technique could help, but again, all these complex techniques doesn't help as a grower until we actually put it into a tool that is accessible and affordable. So we put those things into a soil different apps, whether it's iOS platform or Google or Android platform. So this is an app developed. You can see, okay, this coding done. You can capture an image. It first identifies it is a soil image or not. If it is not soil image, it's asked for another image to collect. You collect the image, it is a soil image, then it does all the processing, extract different kind of a parameter from the processes, and all the background trained relationship is actually help you to predict soil organic matter or some of the other properties like that. So this is soil organic matter. Soil texture is another one. We often know that based on a different lighting condition, how we are taking an image, it determines the quality of this image as well. So we are trying to create a very small handheld box so you can actually carry, put a soil sample in the box and put a phone there. You know, you are confident that the lighting condition is controlled. You can control those light and tell me consistently getting the data. Again, first thing I should tell that many of these sensors, almost all these sensors are not 100% accurate. And I do not need 100% accurate data. I need a precision measurement so that consistently I make that informed decision. I'm happy with 90% accuracy, 10% wrong, 20% wrong, I'm fine, as long it gives me that quick data and consistent data in my and help me my decision making. So I should tell that one. Many of these you cannot say, again, we are comparing this one with the lab analysis. We are thinking lab analysis is 100% accuracy, but of course we know what happens to the lab analysis. If I send 3 samples to 3 different lab, I'll get 9 different data. So that you can think about. So many times, sometimes we do not have the internet connection when you go to the field. It can actually take the data set, it store the data. When it is on the internet connectivity, it uploads the data and shoots a message back through the server processing. Your sample is being analyzed and this is the data set, a text message like that. So this is one. We are also integrating, like we're taking this sample to the outside condition. This is a very recent work, almost unpublished. So what we're working on, the impact of lighting condition and moisture condition, because if you go to the field, different level of soil moisture is there. So what we are developing this project, I hope it works. No. Can I just click on the video? Just video should work. Okay, it's working. So this app, what it helps you, you open up an account because of the data privacy and other information are there. So it needs to have an account. When you go in there, it looks for that illumination control. So it looks at when you actually open up the app, it accesses your cell phone's camera, looks at the illumination, it says, okay, we have a 16 lux at the beginning. Once it fixes up your lighting condition, then your camera is ready to take a picture. You can generate a project. Then you can actually either pick an image or take a snapshot of your soil image. It analyzes that, it gives you a prediction. You can do as many images as possible from your database, or you can take it out to the field. Once you get a series of soil moisture measurement, all this processing and prediction done you can see at the beginning. Then when you say, okay, give me a map of that area for that particular property, generate map at the last, it gives you that interpolated map from there. So the way we are trying to think about, like, these things are multilingual processing capacity. Even with the AI, we are doing it almost like a voice interaction. Many times I don't want to type it, because if I'm walking around and take an image, I can talk to the phone. And that's what we're trying to work on, that we are trying to reduce that language barrier or technological barrier in this way. So not only the soil organic carbon texture we're doing, many nutrient analysis, many times we take the soil sample, extract analysis and get some of the extracted sample with a flame photometer, the color combination. Rather than that flame photometer with a particular nanometer band, we are actually utilizing our cell phone to get some of the color images, and once we get that image, we process. We have this background calibration relationship that we develop with a different ppm or different level of concentration, so that the same image, we take it from an unknown sample and from a known calibration curve, it can help you to get an estimate. Again, these are probably 80%, 90% right. I am okay with 5.47 versus 5.73 pH. A farmer won't care. Farmer will care, okay, do I need to add a lime? How much a lime I have to do? Or for a nitrogen and phosphorus, how much I can add there. But the information, the instant and quick information with the technology on your hand, and probably one of the major development happened last week was a meeting in Chris at DG. So he picked up his phone from his pocket and he said, you know, all the solutions are here. So Pathak said he started his talk with a cell phone and what it can do. So again, this is one. Another one, we're doing a soil spectroscopy for multi characteristics. The way it happened, we shoot a light, some light being absorbed, some light being extracted or reflected. We analyze that light condition, and based on different characteristics, chemicals present in the soil, it gives you a different nanometer band. So this one almost work like a fingerprint, and then we can also get the different intensity for the different concentration of that particular element. So we take that relationship in an unknown spectra, we predict with some soil sample from the lab, and in fact we create a very nice digital soil map, which is in a much higher resolution compared to what you can do with a lab analysis soil samples. We do it in the lab, we do it in the field, and even in fact we are working on something on a handheld spectrometer that you can control from your cell phone. Again, this is an AI driven, so that some of those language, technical and technological barrier we are trying to overcome with some easy access, voice recognition and other approaches is there. Once we get the data, the mapping approach, I have been talking about that, but how we develop the relationship is here. So if we have the soil observation, those point scale, we want to take on the environmental covariate that almost with the satellite data and digital soil mapping. So when we are working on that, we take a modeling relationship between the observed point and the unobserved point and try to create a map spatially distributed for any different property if I have the measured property. That helps us to develop a management decision and policies. This map is actually being utilized in our Ontario government to develop our investment strategy, to prepare the investment strategy, where should we focus in the next investment of soil mapping expansion in the province. We can do it in a 1D, 2D, 3D, 4D, and what is 4D? I will tell you a little bit more on that. We are taking the time component in it. So that not only that sample mapping we are doing in the three-dimensional width depth, we actually take on a multiple time, then we can see how the soil process being evolved. So this particular cases, you do an irrigation at the beginning in a very highly arid environment, salt, then we flash the salt, start developing crop, the salt started coming in, depositing, we are looking at that evolution. You can have that three-dimensional map with the time component, it almost like a four-dimensional understanding the soil process. That definitely helps in terms of managing that field, but if we develop a relationship at a field, it doesn't help for the other field. What we take on some of this easily available soil info or data set like Sentinel-2 image and other properties, then we want to develop the relationship annually or monthly over a larger scale. So that in terms of a decision making which crop to grow based on the salinity level, we can decide should we go for this crop or cotton or something else. So this is what we are trying to do, that over a larger scale. This is what doing this mapping we are doing at a different scale. This is a very small watershed. You can scale about 5 kilometers over there. We do it in a whole county. You can see the scale difference is about 30 kilometers, and we worked on for the whole province. That's about 300, 400 kilometer scale for the same range. So our idea is that how take that field scale information and take it to a larger scale. It helps me decision making. Again, this is a provincial scale for the policy information. For the watershed scale, we are talking about that field scale measurement. This is the map we actually produced and give it to FAO for the GSOC, Global Soil Carbon Map, again integrating the data together. Two quick example of how these things are helping in a field farm scale and a field scale measurement. This is a field we scanned with all these different sensors, including EM38, including dual EM. So it's an electromagnetic sensor, another one is a gamma radiometric. So what we are trying to do, we map that, we almost create a 10 meter by 10 meter grid, and then we are trying to understand the CSA is a critical source area for certain management, or it could be this particular ones done for the phosphorus loss. Because in Canadian Lake Erie, we are suffering from a lot of phosphorus issue, the downstream water quality. We wanted to see what are the potential for a particular field to lose that phosphorus and contribute to the ground later. So we looked at hydrologic soil group distribution map, and then the uncertainty, and then we're really looking at the potential erosion or erosion potential of that particular field, and getting back to taking on the soil P distribution. When you're looking at erosion, what is the potential amount of P loss to the field? Ultimately, we are really looking at the P loss potential from the field. identify whether it's a critical source area or not. Similar way, we have expanded that one to a watershed scale. We really looked at that field by field observation. Now we are looking at a larger watershed. Then we each field. So within a field, we are looking at proximal soil sensing technology, digital soil mapping. Now we take it on to a next level. We calculated all the different soil p-test, predicted based on the soil property and managing. Then we are trying to come up with a potential, that critical source area. What are the fields are highest contributor of P loss to the water quality? So that's being said, like I know it's a flash through a lot of different technology that we are working on, a lot of different data analytics technique. Yes, these sensors show opportunity to deliver large amount of soil data at a range of scales, space and time. They can open the opportunity to study soil and infer about underlying process, their variability in space and time again. Understanding soil process in space and time can help develop management strategy, which really we want to do. And research needed, again, as I said, I'm not going to talk about like from a farm manager point of view, but what is the technological innovation that can support that decision making. So with this work is done by many different funding agencies over the years, and it's a snapshot of different projects I have been working on. With this, I would like to thank everybody and happy to answer any questions.
Thank you, Dr. Asim. I think during your introduction, what was not told was you are a bureau product.
Yes, I did my master's at University of Agricultural Sciences, but my research project and my supervisor is from NBSS, where Dr. Patil Saab is the head.
So, any questions?
Yes.
Yeah, I know there will be too many. Yeah, please.
Thank you for the informative presentation. My question is, what spatial resolution and scale of geospatial data are required for accurate soil, land cover, land use mapping, and as well as for planning and visualizing of watershed assets?
I would take this one, address this one in a reverse way, because I often take a look, okay, what is my application side of it? Yeah. For example, on a precision ag farm level in Canada, when we are doing, we know that my combine is a 30-feet combine, so 10-meter resolution is a good. My Sentinel data is a free software, is a 10-meter resolution, we work on it. But when you are really looking at a regional scale, the provincial scale we worked on for the decision making and the investment opportunity for the province, we have done a 250-meter scale. Again, we can go to 30 centimeter. I purchased some of the satellite data from Airbus and Apollo's, but 30 centimeter, 60 centimeter data is extremely expensive, and at the end of the day, I do not see the value of it. But for a research purposes, we try to take a look, okay, 30 centimeter data versus free 10 meter Sentinel-2 data, how do you actually integrate that? And how do you create on the ground data to fill the gap or help us to scaling up? So that means at the end, like if I'm looking at a larger scale watershed, what will be my management? Is a field-based management could be implementable versus is a very 10 meter, 2 meter or 5 meter resolution that I can manage. Then probably I will develop the, I'll look for the information to develop it, because it's dressed for the job I want, not the job I have. That's what I believe. So how I'm going to address, deliver what I need.
It was an excellent presentation, but we are worried how long we have to wait to find out the sensor or methodology for finding out non-destructive soil profile parameters. Yeah. Or at least up to 30 to 45 centimeter, which is effective root zone depth for majority of our cash crops, let us say.
So the one we're doing up to a 1 meter depth, again, is a very expensive sensor. The major problem is that non-destructive way we're inserting a soil spectrometer, we need that hydraulic to actually push it through. And some of the cases, Canadian soil are actually developed from deglaciation. So that means we have a lot of rocks. It's a mix, it's not a flat. Sometimes it's an alluvial plain, it's not like that smooth. We have a lot of rocks and others. If you want to push the soil probe up to a meter depth, we have a lot of challenge. So even we are trying a non-destructive techniques, spectroscopy and imaging, in situ up to a meter depth, we need that specialized equipment which will require the cost. So even if we are closer enough to actually get some real-time on-site data, but sometimes the cost involved in there probably will not help us to justify that. So this is a major development need to come in, though the technology or fundamental principles are getting stronger and more mature, but I think the tools to make it to collect robust data in situ, in field, require the specialized equipment which require investment. Sometimes it's not very old to actually talk about this is perfect that we can do it.
Actually, in our country, in many places where you will find maybe homogeneous porous soil up to a depth of 1.5 meter, maybe in Rajasthan desert or maybe in coastal areas, maybe in Indo-Gangetic plains. So I think that should be also little easier than.
That would be much easier.
Yeah. So if anything is in mind or maybe coming in the future, please describe.
Yeah, the spectrometer we have done, we have reworked that to actually deal with a different kind of a pressure. The other thing we're trying to do, the spectrometer that we're building also as goes down, it actually measures the compactness of the soil, because how much of we have a load cell on it. So as it pushes through there, load cell tells you how the compaction, that means as you go through the soil profile, we can also see based on the compaction, the load cell information, we can see if there is a certain kind of barrier within the soil profile as well. So the technology I think is a lot more suitable when you have a uniform soil, and particularly some portion of Karnataka, because when I study soil here, I know some profiles are pretty deep in a vertically soil. We have a pretty uniform, not many rocks and others. So this kind of spectrometer with an in situ capability to push it through could help. But I think still we need to walk a little bit path to get this one affordable. So accessible probably okay, but the affordability we still need to work on. I don't think we are 100% ready to get a tool to a farm manager or a watershed manager that you can walk around and get the data. I don't think we are ready completely yet.
One last question. Like you showed, we are able to say know the organic carbon of the surface.
Yeah.
Can we have some equation like you do for pedo transfer function and something like, so that it will speak me about say below 30 centimeter what is the organic carbon, or 45 centimeter, 60 centimeter, maybe not for the all places, but places suitable where I can have some equations.
Yeah, this is one of the toughest questions, because during my PhD 20 years ago, I also dealt with the exactly same. I was looking at the soil water, can we monitor on the top and try to understand in the bottom layer. Soil carbon, some information being developed. If you think about Tom Bishop's paper that they always were doing that equal area spline and try to understand how this different. In 2016, 17, 18, I tried quite a bit of soil property using an OSIS database, World Soil Information System database, almost 200,000 data points or profile data. We tried to find out if mathematically we can create a more generalizable equation that can actually does that. But many cases, like unless we have the local pedological knowledge of that, is very difficult. The soil developed here versus soil developed in Bengal versus soil developed in Canada is completely different. That determine how the profile and like horizonation happen, and based on the horizonation, how the distribution of soil carbon or organic carbon happen. So I cannot answer you, is there any tool? Probably not, I don't know. We try to do a lot of, like again, 200,000 data point, 200,000 sample point, we try to see with the machine learning technique if there is a trend that we can build a general equation, but not everything. Some soil pH we got, some general information we created, some other property, but carbon wise, I know we are always exponential decay or equal area spline. A lot of different techniques are there, but unless we have a local pedological knowledge, I think this is what I always say, me being a soil scientist, that's the best part. I do a lot of work with technology, but until my soil science knowledge say, oh, it makes sense, I say it doesn't. Because that local pedological knowledge absolutely will be necessary to develop that relationship.
Sir, data protection, can you tell something on that? You have you mentioned about data privacy, right? In Canada, how it's you are able to do the data protection sharing and knowledge? Because now in India, DPDP Act has come into force now. So, but in Canada, how do you maintain this data and how that privacy and sharing is done? Interdepartmental or inter-institutional?
So this is the elephant in the room. So we have been working on, I created last couple years, about 4-5 years, we have been trying to develop a new dimension of soil research. It's called the soil data stewardship. I started with the Nature Reviews, one of the paper, we talked about soil data sharing. When Ethiopia was developing that Ethiosis soil system, $70 million from World Bank with a $50 million agricultural investment, $10 million was spent to collect soil data and develop soil nutrient status. And the Kenya, when they got it, government of Kenya, they are not spending money in soil. So we're trying to propose a share and reward based model. So how the Ethiopian government could share the data, because when generally they don't want to share the data because it's their money they spend. Kenyan government, they have the money. Now we're saying, how do you actually redirect investment so that you can share? Again, some cases we not the sharing data, but almost you're sharing the model. So you're still preserving the uniqueness of your data point, but the trained model could be shared and easily transferable. In Canada, soil carbon market is a very, very difficult one. We are talking about each of the farmer using a blockchain technology, the piece of the land they're cultivating with the satellite data. It's almost like a, that police monitoring with the satellite data pass through, and we're trying to work through. But the moment we come back in the privacy issue, Canada is becoming stricter and stricter, like European Union. So we have seen in Germany, we have seen in a lot of FAO, like some of the project in European country, the privacy becomes so strong. So one example, like I can tell you how we often take a way around. For the city of Guelph, we had 22 different community garden. I looked at all the heavy metal concentration on there. Then I was about to publish, and then I was talking to one of my friends. They say, here's a real estate agent. He said, if you want to present this contamination map of a city, it could actually badly affect the real estate market. Somebody want to say, oh, I don't want to buy a house there because that particular area is arsenic contaminated. So rather than doing an arsenic map, what we said, okay, in this area of the city, what sort of crops are more suitable? What sort of crops are allowable for that particular community? So that means if you think about a heavy metal that could actually deposit on a foliar portion rather than a vegetative part of a vegetable. So we say do not grow lettuce and others, but if you grow cauliflower, then you are actually consuming the floral part and not the vegetative part. So that's sometime way around we try to do, keeping the privacy of those information so that we are not impacting other. This in Ontario, we have been working on this, particularly the land valuation and others. We don't want to impact with some of the soil data, soil degradation data. We don't want to say that, oh, your land is already been degraded, so your valuation is less. So you need to think about, and this is what we often take a little bit of way around, bypass around, preserving the original data for the scientific and decision making, but what we see in the open space is that aggregated and more converted data.
Sir, can I ask?
Last.
Okay.
Sir, for developing the soil nutrient estimation model,
Yes.
so how many samples you have collected and which kind of ML methods you have utilized for training the models?
First part, the number of samples. Second part?
Which kind of ML methods you have used? Machine learning?
Machine learning model.
Yeah.
Okay. So particularly the flame photometry one, we had about 200 samples over there, but spectroscopy level, the one we're doing, I have already developed 14,000 soil, the 14 to 15,000 soil sample analyzed and developed the database. By 2028, we are hoping to get 100,000 sample point across Canada.
Okay.
So 1 lakh data point. Okay. And for machine learning model, at the very beginning, we test with a series of model, even going up to an ensemble model, try to come up with, okay, what is the best solution is giving. But if you want to be consistent, majority of the cases we find either a random forest coming up on the top, or maybe at the end we say, okay, we run 5 top model, take an ensemble approach and get the final output based on ensembling approach.
Okay, thank you, sir.
Okay, thank you, Dr. Sim. Yeah.
Thank you very much.
Thank you so much, Dr. Asim Biswas, Professor of University of Guelph, Canada. Your articulate delivery thoughtful insights were truly commendable, sir. So now may I request our Honorable Commissioner, Watershed Development Department, Shri Upendra Pratap Singh, sir, to present a token of appreciations to Biswaji, sir. Thank you, sir. Ladies and gentlemen, our next presentation will be on advances in thermal infrared remote sensing for evapotranspiration and soil water stress monitoring. This is by Dr. Gilles Boulay, Senior Researcher, Toulouse University, France. Sir, please. Distinguished guests, it's my pleasure to introduce Dr. Gilles Boulay, Senior Research Scientist at Centre d'Études Spéciales de la Biosphere, that is CESBio in Toulouse, France, affiliated with Institut de Recherche pour le Développement IRD, Centre National de la Recherche Scientifique CNRS, and partnering institutions. Dr. Boulay is a distinguished expert in hydrology, remote sensing, and land surface energy and water exchanges. His research focuses on quantifying evapotranspiration, soil vegetation, atmosphere interactions, and water resource dynamic across diverse landscapes, from irrigated agricultural fields to semi-arid catchments. Through a combination of in-situ measurement campaigns, modeling, and multi-scale remote sensing analysis, Dr. Boulay has helped advance the science of how water and energy flows operate and climate and land use change. Dr. Boulay Gilles, sir, please.
Thanks a lot for this very nice introduction. So I am actually, I will be presenting a bit about the Trishna satellite mission. So I am actually, it's an Indo-French satellite project, and I'm actually leading on the French side the ecosystem stress group, but I am also a neighbor because I am actually deputed here at the Indo-French Cell for Water Science in Indian Institute of Science. So I will give you some overview of what are the latest advances in thermal infrared data application for evapotranspiration and water stress monitoring. Actually, we had a big workshop last week in Toulouse on this particular subject, so I will present some slides that are actually taken from this conference, so it's really latest results. So why measuring from remote sensing evapotranspiration? So there are some very important challenges for water management or for drought monitoring. So for rain-fed ecosystems or ecosystems such as forest, we want to monitor drought, we want to evaluate its impact on primary production, and we also want to evaluate fire risk in forests, for instance. For irrigated agriculture, of course, we want to infer irrigation volumes, we want to have a dynamic mapping of irrigation area, and we want to help with irrigation scheduling. So all that involves actually evapotranspiration as a key variable. Why? Because if you look at the water budget equation, the change of soil moisture storage equals precipitation, irrigation, and the losses, evapotranspiration and drainage. If you want to integrate that over 1 year, usually the main component are precipitation and evapotranspiration. And ET drives both crop water requirements and actual crop water use. And below water requirements, of course, that means that we have water stress, and we want to monitor that at the plot scale and the watershed scales. So the other way also, the other interesting part is that ET is actually a component of two important budgets for any surface, the water budget, but also the energy budget. So potentially, and I will show, we have two ways to actually determine evapotranspiration at any kind of scales. And of course, ET is very often used for irrigation retrieval. So what are the driving variables of ET, of course, and how remote sensing can help? So of course, to compute ET, you need information on soil water, which can be derived from water budget, but also from satellite in the microwave or thermal infrared wavelengths. You need some information on the vegetation development. So this can be derived from reflectance data from a wide range of satellites, crop fraction, and of course climate. For that, we have less information from the satellites, and we mostly rely on models and reanalysis data or analysis data. So, of course, at the watershed scale, we have different kind of users, different kind of needs, and therefore different kind of methods to use evapotranspiration. So, if you look at for the farmer, for instance, typically the farmer is going to look at daily time scale and make some decision. Typically, we were speaking at Space Application Center last year. We had a workshop. They were saying, okay, we need information before breakfast. Okay. The small farmer, of course, knows his plot, so usually he has a lot of information locally. Managers, so at the watershed scale or for perimeter scale irrigation scheduling, for instance, we need for information during the season, and that each day during the season. And of course, people are also doing some planning. So at state level, for instance, to have a multi-annual scenario, for example, pre-allocation before season, thing like that. Remote sensing is going to provide a major input, mostly at this intermediate scale, which is the perimeter scale or the landscape or the watershed. So the farmer knows his plot. The planners, usually they have a lot of data to do planning. And this is intermediate scale is the one where actually remote sensing can be the most useful. What is remote sensing providing? So thermal infrared data is providing information on evaporation and transpiration, therefore on vegetation water stress. In the visible near infrared, we have information on the vegetation development, on microwave, especially active microwave, so radar data. We have information on both vegetation development and surface soil moisture. So when you want to compute evapotranspiration from remote sensing data, what is the classical way is usually you took optical data from optical satellites like Sentinel-2, which we have been speaking just at the previous talk. So it provides data at roughly 10-meter resolution every 5 days. You compute the development of the vegetation from that. On that, you compute some maximal evapotranspiration rate or potential evapotranspiration rate. If you want to have the actual evapotranspiration, so the actual crop water use, you need to perform some kind of water budget to see if your crop is actually evapotranspiring at a good level or not at below requirement. And for that, of course, you have to know if there is irrigation or not. And that is very tricky. You have a lot of unknown parameters. There are a lot of soil scientists here. You know that hydraulic properties are very, very tricky to retrieve, especially. And of course, irrigation at the plot level is usually unknown. However, in the thermal infrared, you also have data, which is land surface temperature. At the moment, we have Landsat, which provides data every 8 days, roughly at 100-meter resolution. We have EcoStress, which is on board the International Space Station, but it's very irregular in terms of orbit, but very high resolution. And you have a bunch of low-resolution satellites, which provides daily information, but at 500 to 1 kilometer resolution. What they provide land surface temperature, which is exactly a very good signature to water stress. And the very nice thing about that is that if you use this land surface temperature into energy budget model, you can directly retrieve actual evapotranspiration. The problem with that, there are two problems. One is that, of course, it's an optical satellite, so you don't have data when under cloud conditions. And the second problem is that land surface temperature is prone to directionality and turbulence effects. So what does it do, in fact? If you see the surface energy budget, you have energy coming in the form of radiation, mostly solar radiation, and it is dissipated in three fluxes. It is dissipated in heating the atmosphere, sensible heat, heating the ground, soil heat, and of course evapotranspiration through the latent heat. So this is what we are going to do through these satellites. And why land surface temperature is important? Because land surface temperature is a constraint on each of these fluxes. On how we retrieve actually evapotranspiration is just using a residual component of the surface energy budget, available energy from net radiations minus sensible heat minus soil heat. So that's how we do. To do that, we have two families of methods, and that's very important for a product. Agencies are delivering products, they have to use methods with very minimum, routinely available, globally available data. So we have, on the one hand, single pixel models. They solve the energy budget for each pixel. The problem is that they use a lot of information on climate. Specifically, you need to have at 100 meter resolution air temperature and relative humidity. This is almost impossible to get from a model. On the other hand, you have contextual model. The contextual models, the advantage is that they are using some very easily available inputs like solar radiation. It's much less variable at 100 meter resolution. What are they doing, this kind of model, is that they are saying that we are working at the image scale, and we are going to look at the area in the image which are the hottest, and the ones that are the dry, the coolest being the wettest, and the hottest being the driest. And you just do a ratio between your given land surface temperature of a given pixel to these extreme cases. That's how we do. So the problem with this contextual model is that you need to have a very diverse landscape so that all the conditions are actually present in a given image. So what do we have in terms of available evapotranspiration at plot scale? I'm not going to talk about the 1 kilometer scale because you're dealing here with plot scale information, okay? So the first that has been actually made available to a lot of people is OpenET. OpenET is done mostly for the western United States, so the driest part of the United States, as well as Brazil. It is based mostly on Landsat data. So the problem is that Landsat data, it's every 8 days. So you actually deliver something that is aggregated over 1 month. So it's a monthly output. And you have a bunch of models which are falling in the two categories I've been speaking about. And this is some kind of illustration of the outputs for several years. So it's starting in 2020. They have derived also some app, of course, to be able to take this output for the plot scale, and that is an illustration of it. It is also used in Brazil, so you can see here some kind of precision level you can have at the daily scale. You are between like 1 and 1.5 millimeter a day. Another way to compute from routinely available, globally available satellite data is SEN-ET. So this is this time based on Copernicus data and Landsat. So Copernicus data is Sentinel-3 and Sentinel-2. Sentinel-2 is the image on the left. Sentinel-3 is giving land surface temperature at a kilometer scale, so very coarse scale. And what the SEN-ET framework is doing is just sharpening the Sentinel-3 image into the scale of the Sentinel-2 image by saying that vegetation is likely not to be stressed, and you distribute the stress based on previous information on vegetation information at 100 meter or less, or 30 meter resolution. So this is exactly the framework. So a colleague of mine said that you have to have at least one very complex slide so that you look like an expert. So this was presented last week, so I will present very quickly two current application of this SEN-ET outputs. This is for irrigation event detection. This colleague has actually taken a French paper which is looking at radar data. You look at the pixel. If the pixel is getting wetter, even by increased soil moisture from radar data or increased level from the ratio between actual evapotranspiration and potential maximum evapotranspiration, it's likely that it has been irrigated, okay? So that's the basis of this irrigation mapping on irrigation retrieval. And this colleague has been retrieving this irrigation for field in Spain. He has also been using it in a cumulative way for irrigation quantification. So this is an application in tomato. And you can see that actually the cumulative values are fairly good when you summarize over the entire season. So now, what do we have now and in the future? Of course, all this information at high resolution has to be combined. It's very hard to use one particular satellite. Before, a lot of space agencies were actually dealing with satellites as like a Swiss Army knife, doing everything. Now we are moving to really multi-mission outputs. So we have actually at the moment the radar data from NISAR. NISAR has been launched in July. We have SWOT for streamflow. And in the future, in the thermal infrared, we will have a bunch of satellites. So Trishna will be launched in 2027, and Copernicus will launch a very similar mission in 2030. So what does that mean is that we will have some evapotranspiration products available at almost a daily time scale and at very, very high resolution. So what is Trishna? Trishna, as I said, is a project between the French and the Indian space agencies, with PIs in my lab in France and Space Application Center in Ahmedabad. It will have a 2 to 3 days revisit. It has a specific orbit with a 2 to 3 days revisit and a resolution of 57 to 100 meters. So at that resolution, we will provide two kinds of products. We will provide products, so land surface temperature, of course, which is the basis of our computation, daily evapotranspiration, and the water stress, which is computed from a potential evapotranspiration. We will provide two kinds of products, what we call level 2B, which is evapotranspiration when there is a clear sky acquisition. It's an optical satellite, so we will have AT only when there are no clouds present. And then a level 3 product, which will be gap filled, so that we have something every day. So every day, evapotranspiration in millimeter per day. We have several groups working because there are applications also in coastal areas, in cryosphere, on urban heat island monitoring, and of course ecosystem stress. I've seen below, I don't know if you can see it, if you combine all the data from Trishna and LSTM, this is an example in Italy, you have almost a daily revisit. So what are the applications? So of course, early warnings of water scarcity, fire risk assessment. So that can be done by doing change detection or real-time analysis. Optimization of irrigation, especially when there is drought. You can do also a better assumption of water consumption for food security. You can also assess the impact of water stress on food production, on gross primary production. And you can also help also map some better assessment of soil water availability. So there are applications in mapping soils, and also mapping microclimates. So these are both mapping facilities that can be provided by these kind of missions. So in Trishna, we are going to select one model for the family of the single pixel model and one family with a contextual model. So we'll deliver two products. Why? Because for irrigated areas, for instance, you know that you will have a very heterogeneous landscape. So the contextual model is going to work well. If you have like a landscape that is completely rain-fed, for instance, you will have probably more homogeneous hydric conditions. So the single pixel model is probably going to work well. And of course, if you have a lot of local data, we will also provide toolboxes so that people can actually use more complex models with their local information, local soil maps, local vegetation information on specifically for evapotranspiration, local meteorological stations. This actually is important because you have for Trishna a wide range of acquisition angles. So sometimes the satellite is going to see a bit more vegetation, sometimes it's going to see a bit more soil, bare soil. So these methods are a bit more complex and can deal with that. So this is roughly the way we are going to deliver. So in India, it's going to be delivered by a National Remote Sensing Center in Hyderabad. So we will have level 2A products are about biophysical variables, albedo, vegetation fraction cover, things like that. Level 2B, as I said, we will have 2 products, one ET from the single pixel, one ET from the contextual model, which will be delivered when there is a clear sky acquisition. And then the level 3 is the interpolated one. Of course, we are doing some calibration validation. So we have a joint calibration validation site, which is in the Kabini River catchment. It's also a reward watershed, actually, of course. And in that watershed, we have been instrumenting a bit heavily the agricultural plane, and we have performed some UAV acquisition last year with the Northeastern Space Application Center and Space Application Center. So this is a CalVal site that is going to be running even after the launch. So the problem actually in India for evapotranspiration retrieval is of course that during Kharif season you have a very high cloud conditions. So this is an example actually in the Berambadi with our local flux stations. In blue you have every day where you have a clear sky acquisition where you can actually use land surface temperature to derive evapotranspiration. In green, you have a very simple water budget model, which is not accounting for irrigation, and that you can run during the entire season. And you can see that when you're actually combining both, you go towards a precision on evapotranspiration that is below 1 millimeter a day. So this is an example in India. This is an example in irrigated areas. This is in Morocco. Of course, if you are running a product, you don't know irrigation. So you will combine ET from your surface energy budget and ET from your water budget, but you won't know if there is irrigation. By combining both, you can actually see that the blue dots are in very high evapotranspiration level during irrigation, while your soil water budget without irrigation is actually very low. By combining that, again, you can correct evapotranspiration estimate and go below 1 millimeter a day. So for a product, we are going to do data fusion. Of course, if you want to do something more complex, you can do some more complex analysis, do some data assimilation, for instance, and readjust the soil moisture level of your root zone to actually say that it has been irrigated. So from now on, we will have high soil moisture, so a bit higher evapotranspiration from our water budget model. So we have also done some trials for irrigated area mapping. So this is an example in Spain, where we have a Spanish national system of land cover mapping, and we have been doing some similar work as my Spanish colleague has been showing in the previous slide. What we do is we run a water budget model without irrigation. We run the energy budget model forced by land surface temperature from Landsat, and we see the discrepancies. Okay, if there is irrigation, you will have a high evapotranspiration from the energy budget and a low evapotranspiration from the water budget. And again, the discrepancy will indicate you that this pixel is irrigated. So this is actually the performance level if you do that for Spain. In white, you have the true positive detection of irrigation. In black, the true negative, so there is no irrigation. On the phase negative and phase positive, this method is actually performing much better than if you're just looking at NDVI data, for instance, where you say high NDVI is irrigated and low NDVI is not irrigated. So if you do NDVI, you will have a F-score of something like 75, and if you do this work with land surface temperature, you will have a F-score of roughly detection of 0.86. So take-home message, so potential applications for the topics here, the watershed resilience. With this evapotranspiration and water stress product, you can identify drought-prone or low water use efficiency areas to focus intervention. And you can also assess the impact of such interventions for like watershed developments in a watershed development perspective. So as I said, actually at the moment, methods relying on high resolution, that is 100 meter or low resolution 1 kilometer data are lacking revisit or performance. So we usually integrate over 10 to 30 days. But Trishna is going to be launched in 2027, LSTM in 2030. So in the next few years, you will have LST data almost every day, and then evapotranspiration potentially every day. So Trishna, we are going to deliver ET product. Copernicus, they've chosen not to deliver ET products, just LST. So there is room for people to transform LST into ET. And of course, we will have to work in the next few years for CARIF, because CARIF, that's the moment where we have no optical image, so very little information to do the interpolation. There will be also some toolboxes which can retrieve ET from land surface temperature and ancillary data. So there is also room for startups, because startups are actually going to use this globally available, free of cost data to provide their own outputs for farmers, co-ops, whatever. Thanks a lot.
Thanks for keeping the time. Yeah, we'll take some questions. Yeah, please.
Hello, good morning. Dr. Zil, I am Premanand from GKVK. I met you in ISC along with my student. I have one specific question. You have calibrated and validated these remote sense data products in Barambadi watersheds, and we have more than 20 pilot micro watersheds wherein we are measuring net meter data, and we are estimating ET using modified permanent Montet method. Why can't we use this data for calibrating and validating your products using this ground data?
Yes. So Barambadi, we will have a lot of devices to measure evapotranspiration. But of course, in all the micro watershed of the reward project, there are some towers, some Bowen ratio towers. So of course, we will use that data also to assess the quality of the product at some point. Yes. Especially, I was speaking about the level 3 product. The level 3 product involves a lot of interpolation, extrapolation. So these long-term data sets are very useful to do calibration validation for Karnataka, actually. And of course, ISRO has its own calibration validation site. So I'm not only speaking about the one that is jointly operated by French and Indian teams, but there are a lot of other CalVal sites all over India. But of course, yes, the micro watersheds in the reward project are going to be very useful for CalVal, especially for the level 3 year. Thanks.
Thank you for the insightful presentation. My question is, although many foreign countries are developed nation, so what are the technological challenges do they still face to monitor the impacts of watersheds using geospatial tools and techniques?
Using what, sorry?
What are the technological challenges do they still face to monitor watershed using geospatial tools and techniques?
So I'm not a specialist of watershed management.
Okay.
So For the moment, indeed, it widely depends on the area. Okay, I've been working in several parts of the world, so each part has its own. I've been working in North Mexico as a North American monsoon. Actually, it's very easy because you have data very easy available during the growth season, and you know exactly what is your dam level at the beginning of the season. So it's much easier. In Morocco, you have different issues, but you know that we will have a lot of optical data during the growing season. Okay. The problem is in India is that you have Kharif, and Kharif it's a major growing season and you have very little optical data. So that's, I would say that's a major local technical challenge for this kind of applications. So that's why we have to rely on other sources of data, and that's why I've mentioned in my talk, even if it would deserve another talk, what we can do with radar data. Okay, because radar data is actually accessible during monsoon.
And how NISAR data will support the monitoring of soil moisture?
So NISAR is going to provide information on what is missing during the Kharif, so vegetation development on surface soil moisture. So what we can do is to actually assimilate also NISAR data in the water budget tool that we are using for interpolation, extrapolation. So that's this kind of development we are thinking. But that's, as you say, it's a current challenge, and we have Professor Shekhar and I have a PhD student on that topic actually.
Okay, thank you.
Yeah, thanks, Dr. Bullet.
There is a question there.
Still question?
So it's not a question, but we were also exploring the use of IMDA data, like Indian monsoon data assimilation and analysis. They also provide at 11 kilometer resolution the the latent heat flux and all. So do you think that has a potential, like an eddy tower data we can use to validate or simulate ET?
So you're speaking about geostationary and model output at 11 kilometers. So very large scale, very low resolution. They are very useful for a lot of things. They are going to be used as an input to our chains for radiation, for instance. They are very useful these are instantaneous acquisition daily. So you need to extrapolate to the daily values. For that you need solar incoming radiation over the day. They will be used, of course, for days without acquisition. There are a lot of applications for which this kind of data is very, very important. Yes.
Okay. Thank you.
These are the two I'm thinking more importantly. Yes.
Thank you, sir. Thank you for your valuable contribution to this conference. Your insights will certainly guide future research and field applications in evapotranspiration modeling and soil moisture monitoring. Thank you once again. Now I request Dr. Mohammad Parvez Bandhanal sir to felicitate Dr. Gilles Bolle, Senior Researcher, Toulouse University, France. Once again, we extend our sincere gratitude for your insightful and enriching presentation, sir. Thank you. Thank you, Bandhanal sir, for honoring our esteemed speaker. Ladies and gentlemen, it's my honor to introduce now another speaker, Dr. G.P. O.P. Reddy sir, a principal scientist at the ICR National Bureau of Soil Survey and Land Use Planning. Dr. O.P. Reddy is widely recognized as one of the India's leading experts in digital soil mapping, pedology, land resource inventory, geospatial characterization and soil landscape modeling. He has played a key role in developing Bhoomi Geoportal, a geospatial gateway for disseminating soil and land use information. He is Fellow of National Academy of Agriculture Sciences and Indian Society of Soil Survey and Land Use Planning. He has around 125 research papers and 50 book chapters. Sir, I welcome you for next presentation.
Good morning, Chair, and the rapporteurs and distinguished participants of this very important conference. First of all, I would like to thank the organizers for giving this opportunity to share some of our experiences in this very important conference. I am basically speaking on some of the recent initiatives at National Bureau of Soil Survey and Land Use Planning, which is a premier organization under Indian Council of Agriculture Research, particularly on geospatial initiatives in the light of recent National Geospatial Policy and other mandated activities of the National Bureau of Soil Survey and Land Use Planning. If you know, actually in the year 2022, the Government of India issued a Gazette notification wherein actually Gazette notification for geospatial policy, wherein actually there are 14 thematic areas for identified for the fundamental databases for the national building and overall national building activities, especially in the field of agriculture and other allied activities. So wherein actually the soil is one among the important thematic area, and this was assigned to the Department of Agriculture Research and Education there under Ministry of Agriculture, and subsequently it was assigned to National Bureau of Soil Survey and Land Use Planning to look after the entire gamut of the soil and soil resource database of the country. So keeping this in view, actually we have initiated some of the recent initiatives, so those things also I will cover. If you look at the overall gamut of the geospatial application in land resource management or soil resource management, if you look at last 20-25 years, there are so many initiatives and a lot of applications are coming across the country by using the geospatial information. And nowadays, actually, this is geospatial information on land resources is very important for all level of applications, right from local to the national level. And in recent years, especially geospatial technologies are emerging as a powerful tools for both characterization as well as monitoring and management of the land resources. So the potential of geospatial applications to be leveraged effectively in the recent years because we are exploring these possible applications, particularly in the land resource inventory, monitoring and management, to provide the evidence-based or location-specific solutions in the field of agriculture. If you look at some of the recent initiatives, actually under the National Geospatial Policy, we have initiated the development of the content standard for the soils, which is a prime objective of this policy. First of all, actually, we should have a national standards for right from the survey and database management and even for dissemination. So we have actually compiled these content standards on soil, and this was reviewed extensively and with all the stakeholders, and it was submitted to the BIS for its approval, and it is very soon it is coming from BIS, Bureau of Indian Standards, as a first generation standards in the Indian soils. If you look at some of other initiatives, actually we took at the National Bureau of Soil Survey Land Use Planning. We have actually surveying the soils last 30-40 years. Based on these experiences and experiences from all the other stakeholders across the country, we have actually developed these the standards, what you can say like SOP, standard operating procedures for conducting the soil survey, then analysis, then resource management. We brought out this publication in the year 2022, and this was actually we are using extensively in our land resource inventory, especially at various levels. Here actually what we proposed, actually if you look at the traditional way of looking to develop the base information and as well as the landform information, which is fundamental for any soil resource inventory. If your base is strong, naturally your mapping quality and mapping accuracy also is definitely will be high. So keeping that in view, actually we have developed some automation method by using the geospatial technology, taking all environmental covariants or terrain variables to build a database of terrain and come out with the unified or say like what you can say like the homogeneous units, what we call actually terrain mapping units. These units are extensively using for our soil resource inventory, so that we can minimize the soil collection of the soil samples across the terrain, and these data sets are using. Recently actually we have completed for this entire terrain mapping units at a very high resolution, say like 30 meter to even 10 meter, and this entire state actually we have prepared, and we have come out with say around 165 homogeneous units across the states, because in Maharashtra actually we are extensively using these units for soil resource collection or soil data collection or conducting the soil survey at a district level, even at a watershed level. So this database is forming as a base information, so that we need not worry every time whenever you go about any particular district or any particular region, so we can simply carve out that areas and take out that units for soil resource inventory. So if you look at the regional scale, you see the how detailed it is coming. If you zoom at any particular location, how the terrain is matching with the local conditions, how the units are matching with the local conditions. These units actually we are using for collection of the samples unit wise. And of course, ultimately we are making it as a the soil mapping units. And you can see some of the locations actually we have tested in some of the locations how it works in different terrain conditions. These are some of the snapshots of the terrain, how the terrain looks and how the land soils are occurring on that particular location based on the units which we have generated. So this is fairly matching with the ground conditions of the soil, because ultimately the soil genesis and soil processor will depends upon the terrain, local terrain conditions. So once we capture the terrain processes or terrain conditions, so fairly we are matching the soil conditions. So this way actually we are building the legend for the entire the units, right from the top physiographic units to the local level of soil mapping unit, so that every soil unit is hierarchically linked with the terrain mapping units, or say like physiographic units of that particular region, so that we are actually what you can say like capturing the entire heterogeneity of that particular region through your legend, so that this can be utilized for many applications at the grassroots level. So similarly we did for different states also under this approach. So this is the one district in Andhra Pradesh, and this is another district in Karnataka. This is actually Raichur district in Karnataka. So these are the terrain mapping units which we are using for soil resource data collection in this area. And of course across India actually now more than 135 districts we have already completed. So still around 20-30 districts we are adding. So around 150 districts already we have completed by using this technique, and it is extensively helping us to fasten the process in land resource inventory in the country. And of course the other approach actually we have initiated in last 3 to 4 years back. We are actually, because keeping the time and resources in view, how to fasten the soil resource inventory by using some innovative and fast approaching techniques. So we are using this digital soil mapping techniques, and this technique actually extensively we are using all the available high resolution satellite data and high resolution digital elevation models to derive different environmental covariance, and we are putting in a model, and by using the AML model we are actually identifying the precise locations of the soil samples, and we are going to that location and collect the samples, and ultimately we are predicting the different soil properties. This is the entire process actually we are following in predicting the soil properties, and of course validation definitely will be there, and we are going for even error matrix and while finalizing the DSM products. So we have covered different regions now. Right now, so we have 3 regions in Maharashtra, and almost 80% of the Maharashtra we have already covered. And we have covered in Bundelkhand region, then we have covered in Bikini region in Rajasthan. Of course, it's not listed here, but some of the northeastern states. So region by region we are going, and we are building this digital soil mapping units, products also in a portal. So this way actually we are taking the different environmental covariance while compiling these DSM products. This is some of the outputs of that Vidarbha region, how we are actually predicting the different properties. This is property based approach. And recently actually we have compiled this entire national soil depth map, which was released in the last international conference at New Delhi. This was actually at 90 meter resolution, and we have used more than 25,000 soil samples across the country. Now we are going for other products like texture and soil organic carbon, and soil acidity, soil pH map also just it is about to complete within 15 days. By end of this year actually we are coming out with a new product by using the same digital soil mapping technique. And of course, this is the entire national soil depth map. And earlier actually we have compiled this soil organic carbon in collaboration with Indian Institute of Soil Science, Bhopal. Now this map also actually we are planning to come out with a high resolution soil organic carbon map, which is having a immense applications in various applications like soil organic carbon sequestration and many other applications. And of course, we have actually many, all the ICR organizations of NRM institutes. In 2010, it was compiled and harmonized this land degradation map of India, because recently ICR has initiated this activity to revise this map with high resolution information. We are working on this with all the sister organizations. NBSS is coordinating this activity with all the other ICR organizations, particularly NRM institutes, by developing the components, first individual components. So we are working on the soil erosion latest by using the latest data sets, and we are also working on acid soils, then wind erosion is already completed, salt affected soils by CSRI canal, then different components of the land degradation. We are actually, NBSS has given a task to compile it and integrate and come out with the latest land degradation map of the country. We are actually targeting by 26 March, actually we are planning to come out with this latest land degradation map of India by combining all the thematic information by using all the latest satellite data and other geospatial techniques. We also worked at different regions to see the land degradation vulnerability by using the geospatial approaches. This is another approach actually how we can use this vulnerability mapping by using the different variables, of course including soil information. We can identify the different prone areas for the land degradation vulnerability, so that accordingly we can have measures to minimize the soil erosion. And we also recently worked with NESM Baramati Abiotic Stress Institute to come out with a protocol how we can map the abiotic stress mapping across India. We have taken the pilot study in Maharashtra, and we have come out with this SOP to come out a soil abiotic stress map of India. This was tested in Maharashtra, and this map was actually is finalized now. We are actually upscaling this what you can say like methodology for other regions once we get the soil information to come out with the abiotic stress map of India. Again, this is having a huge applications to minimize the abiotic stress on crop and other natural resources. Another initiative actually recently we took on agroecological zone mapping, because NBSS and LUP has developed the agroecological regions and sub-regions in the last 1992. We are now using all the latest climatic data information of IMD and other sources like Copernicus data sets. We are actually coming with the latest AEZ map, agroecological zone map, in another 6 months period. All the information is already compiled, or different thematic maps already finalized. The uniqueness of this approach is that output is that we are coming with the 15 days LGP, length of growing period. Earlier we have a 60 days LGP. Now we are coming with 15 days LGP, so that we can see the intra-district variability also while going for any crop planning or even agrotechnology transfer, particularly when you are looking at the micro level climatic information. You see some of the products. See, this is like Karnataka. You can see how 15 days LGP looks like this actually at micro level. We have come out with the draft of agroecological zones. This is actually now we are finalizing. Even within the district also we can see our agroclimatic conditions are varying, and this agroclimatic variability will be immensely useful for your crop planning within at regional and sub-district level when we go for the crop planning by using these units. So this is also coming very shortly, which is almost in the final stage of entire India. And of course, we are also using extensively available data sets of soil resources and other climatic information to come out with crop suitability for different crops by using the latest multi-criteria models. Earlier actually we used to follow FAO method. Now we have further refined it, and by adding more elements and more input parameters, we have completed now like oil palm, which is already submitted to the Minister of Agriculture, the report in collaboration with the Indian Institute of Oil Palm Research of Andhra Pradesh, and this is also completed for pomegranate suitability for almost all the states, and this is a report also in the final stage. We are coming with the suitability for different crops by using, sorry. Similarly, actually, we have completed the suitability for soybean, Indian Institute of Soybean Research Indoor. This is a report also is in the final stage. This month, next month, we are planning to release this report. for all the states, and this was validated by that respective institute, and they are very happy with the output of the how actually it is matching with their ground information. And of course, actually we have based on our experience, we have also developed the mobile app to collect the samples when we go field across the India by different regional centers and headquarters. We have developed the mobile app, and this mobile app is now we are using and tested in all the regions. It is effectively helpful to collect the samples instantly from the field. Whenever the when we are collecting the samples, so we can directly feed the information, and that information, basic information, will come to the server, and at the end of the day we can see actually how many samples we collected and which part of the country, which village we have collected all the samples by using this mobile app. That was actually linked with our portal. And we have also developed one data acquisition system for under the National Geospatial Policy for all the partner institutes to directly support this acquisition data collection system by using these advanced tools. And we have of course developed the grid based information, as I told you, all the DSM products we are combining as a national soil grid. So these are the region by region. So any user want to see any information of particular information what we have generated, that can be seen at a different depth level again. Say soil organic carbon, they can see at a different depth level. And of course, we also actually this National Soil Spectral Library, which was inaugurated by the Honorable Minister of Agriculture, Government of India in the last year. And so far actually we have compiled around 35,000 soil samples, and we have developed generated this spectra, and this spectra is now is available with NBSS. So we are actually putting all the information in our spectra, and all the database what we are generating the spectra, that database is automatically going to the National Soil Archives, where actually all the archives are barcoded. If any user want to see by using the barcode, they can get the full analytical data of that particular samples, which part of it is we collected, and what is the soil physical chemical properties of that particular property. So this way actually we are preserving all the soils across the India for important soil samples. So far we have collected around 35,000, and we are targeting say around 50,000 by end of this year. We are approaching now. And of course, this is the spectral library, as you mentioned. We have a spectral radiometer, and we have built around 40,000 samples now in collaboration with other ICR organizations. And this is of course it's a building now. Once we reach a robust level, say around 1 lakh or so, we can go for the prediction of the soil properties of different chemical properties with a minimum sampling on the ground. And this is the protocol actually we have developed. So anybody want to support these activities, so we have a strict protocol. So it will go to that protocol, and ultimately it will go to the national database of the spectral library. And of course, any students or any researcher want to use that information, of course it is welcome. And these are the models actually we are using. Of course, it goes to the spectral library. Then of course we are using the AML model and even deep learning models to predict the soil properties, and ultimately it is going to the online spectroscopy. So even by using the online models, one can test the prediction of any particular properties in a spatial domain. So this is the current status of the National Spectral Library, and distribution you can see how, but still we have to go a long way. We have a lot of gaps to fill. Yeah, this is how we are predicting on online. And we also worked with some of the startups. Actually, they have developed some handheld devices to quickly predict the soil properties in the field by using these hyperspectral models. And this also we are working to validate their devices. Ultimately, actually, all the product which I discussed, all the outputs which are going to the ultimately to the portal. So this is the workflow, or we can say like protocol, how we are working and how the ultimately it is going to the portal. And this portal actually now it is actively available for any users to see and get the required information. We have a different components on the portal, and one can select the component and see the more detail about this portal. And this was evaluated under National Geospatial Policy, and it was the team or the higher ups of the National Geospatial Policy is highly appreciated these initiatives, and the data sets available and the organization of the data. And the different products we can see under this portal. So I am not going in detail of each product. So I will quickly show some of the products. See, like soil health information or soil fertility information for some of the states, like you can see the Jharkhand and West Bengal, we have a detailed information. One can see even at block level what is the distribution and how, where actually we have a deficit and where we have a surplus of that particular product. Even this is useful for the even fertilizer companies to push their fertilizer for a particular region where it is highly required. And we also developed a micro level soil fertility information for the state of Goa. Even one can see at parcel level what type of soil fertility is available and which crops are suitable. Accordingly, what type of fertilizer requirement is required for that particular crop. All those things one can see for this particular state. And of course, for LRI, of course, Bureau also is working since last 5 to 10 years on LRI. We have developed a lot of LRI products, and we put exclusively on a sub portal for LRI products, and one can select the state and district and block and see the products of LRI which are available from the Bureau side. So that's on the sub component. And we also built actually the national state level portal within the Bhumi portal. Even if anybody is interested to see for their respective state, they can go to the particular respective state portal and see the more detail of the products available of that particular state. And of course, national level suitability, crop suitability information is available for about 18 to 19 crops which are available at national level, as well as one can see even at state level, even one can see at the district level also how this information is useful for their crop planning in this way. So like state and even district level also they can see. And of course, we also tested actually the policy is encouraging for interoperable of these data sets. We have tested interoperable with the Indian Institute of Science. There is one organization, Indian Institute of Science in Bangalore, and we have some portals at Delhi. We have linked with their portals and access this information online and integrated with that information with the Bhumi portal. And that mechanism also is very well working. But the only thing is that all the portals should be the same frequency and same length and same content. Then we can effectively use that information. Any user can use that information sitting somewhere else and get that information and build his own applications and come out with his own products by using this information. And we also actually working with other organizations, like recently we have completed this FAO assignments to build this soil atlas of Asia. We have contributed to this FAO assignment to the soils of India, and that was released in the last year actually, this soil atlas of Asia. So we have contributed from Indian side this Indian soil of these initiatives. And of course, actually we also initiated now developing the Unified National Soil Information System under the National Geospatial Policy. We are working more than 40 partners now, ICAR institutes and state agriculture universities. Some of the nodal officers are sitting here also. So we are already have some initiatives, and how this major objective of this initiative is that how to compile the available or scattered soil information across India and across organizations in one place, and bring into the standard format and provide to the users with a standard data set. So that is actually effort which we have initiated, and we are working on this. And of course, we are also developed one data dissemination system, because nowadays we are getting every day 3 to 4 requisitions for different soil information. So we are actually making it is online now. This is now testing now. We are actually planning to make it operational very shortly, so that any user, any particular any specific user want to give want to require any information, so that if that information is available, we will provide that information to the users.
Hurry up.
Of course, with the final approval. Some of these initiatives we have taken. So we have developed this developed this National Soil Data Center, and of course central servers which is operating very recently, and of course we have Spectral Library and this GeoSmart Center of Excellence also we have received approval. We are actually building that Center of Excellence for all advanced applications. So I am coming to end of this presentation. So of course we are also working to sensitize the participants on different aspects, so on different geospatial applications. And recently actually there was a committee which was asked what is the requirement of space technology or geospatial applications in the coming 2047, means Viksit Bharat. So that a committee we had a lot of deliberations and submitted this report, the requirement of the space applications in natural resource management, and this was submitted to the ISRO for further approval. So at the end, actually, when we look at these activities in the recent years, so we are coming up across different challenges. Just I thought that to put this out before house, these some of the challenges. One is like the acquisition methods. Actually, we have a different data acquisition method by different organizations. Where actually we need a sort of a standardization depend upon the local scale and resolutions. Of course, another is the mapping scale and resolutions, which type of map or which type of scale we have to use at what level and what objectives and what resolution, what input data sets we have to use that resolution. So some of these standards also required. Then we have to have a assimilation system. That's what we build that one portal. And another important is data quality and uncertainty. Whenever we are receiving that data from different sources, there are issues of data quality and some of the uncertainties we are facing these issues. This needs to be minimized. And the reliability and of course the scalability issues which are always there in any data compilation and data building. And of course content standard which we addressed and brought out that document. Another is the harmonization which we are working in land degradation and other aspects which is again very important aspects. And of course the interoperability which is the order of the day, and in the future actually we have to go in this way so that users can get the information from different portals by using this interoperability mechanism to build their own applications. Of course the data security is always is issue. So here also we have taken some measures how to protect the national data sets with the good care and protocols of whatever the global standards which we are following. So with this, I will stop it here, and if any queries and questions. So thank you, one and all.
Any questions? Yeah, please. Yeah. Quick.
Thank you, sir. Actually, I would like to congratulate head of National Bureau of Soil Survey and Land Use Planning for a period of 50 years. I think they are entering into the Golden Jubilee celebration this year. I am also thanking to you, sir. I have as a request to you, let us upgrade this LRI to LWRI. You have already worked in silo for 50 years. Now let it be land water resource inventory system. Otherwise, as Reddy sir showed, areas suitable for pomegranate through Mars is 64 million hectare. This has been purely made without consideration of whether water is available to irrigate my pomegranate plant or not. Otherwise, 64 million hectare is a big value for having the areas under pomegranate. Same thing when the head of NBS LUP Bangalore Center had projected for Odisha area under maize. So it was very high figure. It is only because he could not consider the areas where waterlogging is prevalent, where maize cannot grow. So sir, now my sincere request, because you have done wonderful contribution for the growth of all the soil information of the country, and it is getting upgraded every now and then. And if you go to the literature which has been published by Central Water Commission in the year 2023-24, that water body census with a satellite product of 2019, you will find none of the millions of small ponds which has been developed through NRGS or millions of wells which has been constructed by different watershed program are not appearing in those census. That can be only done by the people who are really worried for the development of agriculture. So this is what I will request the head of the family, Dr. Patil sir, to kindly consider. Thank you very much.
Yeah, Dr. Jena, to be honest, we have already done some pilot scale studies integrating water data as well. It's not that we are not aware of the problem. Land resource inventory by definition itself covers everything on the land including water. But the problem is we have shortage of manpower, that is skilled manpower, and then the data sets are not so easily accessible. With the Government of India's recent policy of democratizing the data, we have approached CGWB and we are getting some data from them, CGWB as well as federal agencies. So very soon I think we will start national level work on this aspect as well. Thank you.
Even some of the suitability like oil palm, we have already considered the groundwater component in that. Yeah.
Yeah, please.
Can you use the mic, please?
Pollution.
Hello? Yeah. In cities, all this polluted water is flowing into the rural districts. So maybe the treatment is a problem, or all these STPs have to be upgraded because it is flowing outside Bangalore city. Example, Bangalore, you have a lot of tons and tons of water flowing into other districts where they use it for vegetable cultivation, and that comes back to the city and this one. Maybe that we are able to do something on that, sir.
No,
Treatment is not to that effect, and all this carcinogenic, all this water pollution and chemicals what they use, no? Including sewage, industrial waste, all that is flowing into the rural districts of Bangalore, where they use it conveniently to cultivate vegetables, and early in the morning in the 3 o'clock it will come back to the city and people consume it in the city. It is mostly carcinogenic. I think so you have to do mapping on that also. Maybe that provision has to be made, because now Disaster Management Act has been scaled down to Urban Disaster Management Authority. So they have a power to penalize anybody. So that is there. That is amended, as you know that. That's the reason I just wanted to submit on that.
This is common almost all the major cities. Yeah, one can attempt at peri-urban agriculture aspects. How actually it is affecting the the vegetable cultivation in the local area. So we have to work out locally, city-wise, how much area is there and how much water is consuming for that and other details.
Yeah, thank you, Dr. Reddy.
Okay. Thank you, Nodal. Yeah.
You have some question? Yeah, please.
Yeah.
Just a minute, Dr. Reddy.
Yeah.
That's one question.
Sir, as you mentioned, you have collected 35,000 soil sample spectra. So, are you going to use these spectral signatures for prediction of soil properties on a large scale using satellite data?
Yeah, definitely. Actually, this is the base. Actually, we have to do lot of things. First, actually, whatever the samples we are aggregating, we want to pool them, or we want to segregate first to soil wise. Because I cannot, take the block soil and predict something in red soil. First, we are trying to pool it in a soil type wise. So, like block soil, sample set different, red soil sample different, alluvial soil different. Then we are also trying to pool them, group them in agroecological region wise. So after doing that, we can go for the prediction, and we have tested already, it is working well. But if a large scale spatial prediction, particularly what you are asking, definitely we have to link with the environmental covariance with the satellite, high resolution satellite data like Sentinel-2 and other thing. Definitely that is our major. Actually, we are going point to image spectroscopy. That's what exactly your question. That we are moving in that direction. So ultimately, we want to go for the image spectroscopy in the very in 1 or 2 years, so that we can go for the regional level prediction of the soil properties by using this information.
Yeah. Okay. Thank you, sir.
Okay. Thank you.
Yeah. Okay.
Thank you very much, Dr. G.P. Obireddy, sir. Soil analytical methods using geospatial techniques by collecting, integrating, mapping spatial data to understand soil variability in physical, chemical and biological properties. Thank you very much for evaluating this platform. Your expertise and thoughtful, the narration is commendable, sir. So now once again I request our Honorable Commissioner, Watershed Development Department, Sri Upendra Pratap Singh, sir, to give a token of appreciation to Dr. G.P. Obireddy, sir. This is for kind information about rapporteurs. I've been asked to announce this announcement here. Request to submit the reports before lunch, and also the reporters afternoon, the post-lunch reporters should submit their report before 6 p.m. today. invite our Watershed Development Department Director, Parvez Bantral sir, to present a token of appreciation to the chairperson, NG Patil sir, Director, NBSS and LUP, Nagpur. I request Commissioner Watershed Development Department to join the hands, sir, please. Session 3. Now we break for short coffee break. Probably we'll reassemble here by 12:30 sharp so that actually we can begin our next session on time. Thank you. Thank you so much.
रिवार्ड योजना के तहत भूमि संसाधन संवेक्षण के बाद LRI कार्ड देकर किसानों की भूमि के लिए उपयुक्त फसलें और उर्वरक परिमाण की जानकारी भी दिया जाता है। समय समय पर मोबाइल फोन से उचित फसल प्रबंधन संबंधी सुझाव भी भेजते हैं। इसमें यह भी जानकारी दी जाती है कि मौसम बदलने पर क्या सावधानियां बरतनी चाहिए। यदि हमें कोई संदेह है तो वरुण मित्र सहायवाणी 9243345433 पर कॉल करने से हमें सुझाव मिलता है। इस व्यवस्था द्वारा हमें अपनी फसलों की अच्छी पैदावार मिल रही है।
Earlier, it was taking 2 years to prepare the draft DPR for the watershed development. Visit to individual farmer fields were essential to understand status of natural resources. Now in reward program, decision support system has been developed and used. In just 6 months, land resource inventory will be conducted and draft DPR will be prepared. It will be finalized after discussing with the concerned farmers. There are 3 types of benefits from LRI-based watershed development planning. Firstly, within 6 months, DPR preparation and getting approval for it. Secondly, implementing the specific conservation measures. And lastly, suggesting appropriate crops and fertilizers requirement as per soil conditions. Rainwater can be stored in the trench cum bund implemented as per land resource inventory under the reward program. It helps to retain moisture in the soil for longer time to increase the crop yields. Similarly, the construction of nala bunds, check dams and gokatte stores excess rainwater. Drinking water will be made available for the livestock. Further, rise in groundwater level lead to increased borewell yields, helpful to increase crop yields and farmers' income. After conducting a land resource inventory under the reward program, each farmer will be given LRI card. Awareness is created on appropriate crop selection based on this information. This helps farmers to select profitable crops according to the characteristics of their land. I was growing finger millet and I am advised to grow vegetable crop according to the LRI card. Now I am growing vegetables and I am getting more income. Under the reward program, land resource inventory has been conducted and LRI cards are given to every farmer. This will give us an idea about nutrients level available in our land, such as nitrogen, phosphorus and potash. In the LRI card, if the level of any nutrients marked in red, it is very low. Then one should provide 67% more nutrients than the recommended quantity. In my field, the nitrogen level is marked in dark green, which means it is very high. So, I am applying only 37% of the recommended dose of fertilizer. This information helps us to save the fertilizer cost. This is how we have made changes in applying the recommended dosage of fertilizers to the crop. Under reward program, land resource inventory has been done and the LRI cards are given. Besides, information on crop suitability and quantity of fertilizers to be applied to my land is also given. Appropriate crop management advisories are sent to our mobile phones from time to time. Further, advisories include precautionary measures to be taken during adverse weather conditions. For any doubts, we will call 924 33 454 33 Varuna Mitra helpline and get the required information. This system has indeed helped us to get good crop yield.
पहले वाटरशेड विकास का डीपीआर का मसौदा तैयार करने में 2 साल लगता था। तब किसानों के खेतों के दौरा करके वहां की स्थिति के बारे में जानकारी लेकर निर्णय लेना पड़ता था। अब रिवार्ड योजना में डिसीजन सपोर्ट सिस्टम लागू की गई है। सिर्फ 6 महीने में भूमि संसाधन सर्वेक्षण कराया जाएगा और डीपीआर का मसौदा तैयार किया जाएगा। इसके बाद संबंधित किसानों के साथ चर्चा करके अंतिम रूप दिया जाएगा। एलआरआई आधारित वाटरशेड विकास योजना से 3 प्रकार के लाभ हैं। पहला, डीपीआर तैयार करना और 6 महीने के अंदर मंजूरी लेना। दूसरा, स्थल विशिष्ट संरक्षण उपायों को लागू करना। तीसरा, भूमि की स्थिति के अनुसार उपयुक्त फसलों का चयन और उर्वरकों की आपूर्ति। रिवार्ड योजना के तहत भूमि संसाधन सर्वेक्षण के आधार पर कार्यान्वित ट्रंच कम बंड में वर्षा जल को संग्रहित किया जाता है। इससे भूमि में नमी लंबे समय तक रहकर फसल की पैदावार बढ़ती है। इसी प्रकार नाला बंड, चेक डैम और गौकटाओं के निर्माण से वर्षा जल उनमें संग्रहित होगा। पशुओं के लिए पीने के पानी की सुविधा होगी। अंतर्जल का स्तर भी बढ़ेगा, जिससे बोरवेल में पानी की मात्रा बढ़ेगी। फसल की पैदावार बढ़ने से हमारी आय भी बढ़ती है। रिवार्ड योजना के तहत भूमि संसाधन सर्वेक्षण के बाद हर किसान को एलआरआई कार्ड दिया जाता है। एलआरआई कार्ड में उचित फसल चयन के बारे में जानकारी दिया जाता है। इससे किसानों के भूमि की गुणानुसार फसलों का चयन करने में मदद मिलता है। मैं पहले यहाँ रागी उगाता था। एलआरआई कार्ड के अनुसार सब्जी उगाने की जानकारी प्राप्त हुई। अब सब्जियां उगाता हूँ, जिससे आय भी अधिक हो रही है। रिवा
Ladies and gentlemen, one quick announcement to delegates. Those who are interested program, at morning 7:30 a.m. bus will depart from here, and further if any communication is there, you can please contact him, Mr. Manjunath, reward program. Once again, so if at all, tomorrow, those who are interested to go to the field visit, so kindly give your name to Mr. Manjunath. So you can come and contact me.
Who are interested for a field visit, please come and contact me. Please give me your details. 7:30 will go. We will arrange the process. That details we will share.
Okay. Tomorrow at sharp at 7:30, bus will depart from here. For further communication, you can please contact Dr. Manjunath, please. agriculture transformation. Our chairpersons and panelists are waiting, and I request all the delegates to come inside the conference hall. So we're going to start the panel discussion, that is technical session 4, shortly. So once again, I request all the delegates, so after having your tea, please come to the conference hall. We're going to start the technical session 4, that's panel discussion on role of private sector on data-driven watershed and agriculture transformation.
उपलब्ध नाइट्रोजन, फास्फोरस और पोटैश पोषक तत्वों के परिमाण का पता चलता है। एलआरआई कार्ड में किसी भी पोषक तत्वों के परिमाण लाल रंग में हुए तो समझ लेना कि वो कम है। तब सिफारिश किया हुआ पोषक तत्व से 67% ज्यादा पोषक तत्व देना चाहिए। मेरी खेत में नाइट्रोजन का परिमाण गहरा हरा में है, तो इससे पता चलता है कि वो बहुत ज्यादा है। उर्वरक की सिफारिश परिमाण का केवल 37% ही देना है। इससे उर्वरक की लागत बचती है। तदनुसार फसल में सिफारिश उर्वरकों के प्रयोग में हमने परिवर्तन कर लिया है। रिवार्ड योजना के तहत भूमि संसाधन सर्वेक्षण के बाद एलआरआई कार्ड देकर किसानों की भूमि के लिए उपयुक्त फसलें और उर्वरक परिमाण की जानकारी भी दिया जाता है। समय समय पर मोबाइल फोन से उचित फसल।
I once again request all the participants, distinguished guests, please enter the hall. We are going to start the technical session 4 now. Since we are running short of time, today I got a validity session and way forward too. Technical session 4. It's a panel discussion, role of private sector on data-driven watershed and agricultural transformation. Shri Nitin Khade, IAS, Joint Secretary, DOLR, New Delhi, will be the chairperson for this. I request Shri Nitin Khade, sir, kindly come on the stage, sir, please. The panelists will be Dr. A.V. Bhavani Shankar, Chief General Manager, NABARD, Shri Prabhakar L, Executive Vice President, ITC, Kolkata, Shri, instead of Amit Vatsen, you will Shri Tanay Joshi, Director E&Y, and Shri Abhishek Sharma, Deputy Vice President, Research, Sambodhi Research and Communication Private Limited. Distinguished guest, may I now introduce Dr. A.V. Bhavani Shankar, sir, the Chief General Manager at the National Bank for Agriculture and Rural Development, NABARD, one of India's foremost institutions driving innovation, investment and inclusive growth in agriculture and rural development sectors. Dr. Bhavani Shankar is a highly accomplished professional with decades of leadership experience in rural finance, natural resource management, watershed development, climate adaptation, agricultural value chains, and institutional strengthening. His work at NABARD has made significant contributions to improving rural livelihoods and supporting sustainable development across India.
Ladies and gentlemen, it's my privilege to introduce Shri Prabhakar L, the Executive Vice President and Head Social Investment of ITC Limited, Kolkata, a leading Indian conglomerate. He oversees all social interventions of ITC focused on enhancing social and environmental capital that includes areas like natural resource management, sustainable climate, smart agriculture, social forestry, etc. I welcome you as a panelist, sir.
We have one more panelist here, the eminent personality. Dr. Tanay Joshi is an agriculture sustainable development expert with over 15 years of international experience across Asia, Africa, and Pacific. He currently serves as director at Ernst & Young, that's E&Y, and has previously held leadership and technical roles with FIBL Switzerland, the International Rice Research Institute, Niti Aayog, and global donor-funded programs. His work spans agroecology, biodiversity, conservation, organic cotton system, climate resilient agriculture, and policy advisory for governments and development agencies. Dr. Joshi brings extensive experience in multi-stakeholder program leadership, research, capacity building, and south-to-south cooperation.
And it's my pleasure to introduce our next panelist, Sri Abhishek Sharma, the Deputy Vice President for Research at Sambodhi Research and Communications Private Limited, one of India's leading evidence generation and impact measurement organizations working across the development sector. Sri Abhishek Sharma is a distinguished research and evaluation specialist with extensive experience in monitoring and evaluation, impact assessments, policy research, large-scale surveys, and data-driven program strategy. Sir, welcome you on behalf of our organizers.
I now humbly request our Honorable Chairperson, Shri Nitin Khade, IAS Joint Secretary, DOLR, New Delhi. I hand over this session to you, sir, please.
Welcome back after the tea break. So we are going to discuss a very interesting topic, role of private sector on data-driven watershed and agriculture transformation. So we have some leading luminaries who have worked in private sector and also worked in water and soil conservation. So we'll be hearing from them. Before I hand over the mic to them, I would also like to put things in perspective. So we have been thinking for long how we can increase private sector's participation in soil and water conservation, especially in watershed development works, to be specific. So we had thought of 2-3 models. How we can make the recurring costs accrue to the project so that we can sustain the works, we can enhance the works with that money. So if we look at the models, there are 2-3 models available. First model is typical, that BOT model, or the model which we see about the civil works like road construction and infrastructure works. There is a concessionaire and government tells him to do some work, he does it, and in return he can levy some charges for the public. So that is one model. So we had thought of this model, whether it's feasible in Indian context. If suppose there is a watershed area of 10,000 hectare, and if we do some kind of bidding and we allot that area to a private bidder, he invests 20 crore rupees in doing the watershed development works there, then what do we give him in return? So one of the option may be if there is any government land which is 50 hectare, 100 hectare there, and if we give him for some long lease like 50 years, 100 years, then he can do some kind of plantation or industrial activity, whatever he wants, and he can earn back his money. So that is one model, but this is very difficult. In Indian context, it's very difficult. Land is too sensitive a subject, so it's not easy to bring in private sector in public-private partnership like being done in other sectors. We are just getting ideas how other sectors are doing, road, shipping, everyone is doing like this. So why not we do it? The volume of our degraded land is 9.8 crore, that is 98 million hectare. And if we deduct the forested degraded land, so it will come around 50 million, that is around 5 crore. So with the amount of resources we have at our disposal under WTC, we may be able to cover hardly 5 million, 50 lakh. So that will not be able to meet the need. So we need to think of other revenue streams, how we can undertake watershed development works by augmenting resources from other sources. So this is one model. Second is if corporates come forward and if they take up some area through CSR, but there is a limitation. We have generally observed that corporates are willing to undertake CSR activities in the neighboring areas of their industrial activity. They want to influence the local population staying there. It's quite natural. They feel that if the local population gets a school building, a hospital or some other thing in the area, they will have some goodwill for the corporate, for that particular industry. So what we have seen is that our watershed projects are generally in drought-prone, rain-fed, agriculture-based areas. They are quite far. They are in underdeveloped areas. To give example of my place is in Satara district of Maharashtra, in Man Taluka. There is hardly any industry there. All the industry is in Satara town or in Pune or in Mumbai. So why will a company based in Pune or Mumbai invest in my place? So I think this logic may apply to most of the projects. So that is one factor. If they really have that philanthropic thinking and if they invest their CSR money in areas which don't have any connection for influencing the local population for their industrial activity, then I think that's the best case scenario. But this is one of the factor which we have observed. Then third model can be, can we have a 4P model? We are trying to explore through our Jan Bhagidari Cup. So in public, private, people partnership, can we have some kind of crowdfunding in whatever possible way? There can be CSR component as well as crowdfunding in terms of cash, in terms of kind, in terms of shramdan, in terms of services offered. So will that be able to take care of the resources which we need? I don't think. It is possible to do some kind of augmentation. If suppose our project cost is 10 crore, then through this PPP, we can add 1-2 crores to that. But this model will not be able to cater to the entire fund requirement. So we heard from our friend from Ethiopia yesterday that they have done something successfully in watershed, in getting PPP in watershed development. So we would like to know some such novel ideas from these 4 experts. So now I request Mr. Prabhakar, Senior Executive Vice President of ITC, to please share his thoughts on this.
Good afternoon, everybody. I think a very pertinent topic, I would say, sir. And my first response to the suggestion that you are making, I think we should not rule out any option at the table. I think there's always a beginning for every option. And I'm sure whether it was road, shipping, that time also they would have thought, hoga kya karke? So I would actually not take them off the table, and I think we should pursue that. That's one response first. I think the second thing is, I'm a strong believer of small drops make an ocean. I think when we sort of look at the size of the problem and then sort of we look at one corporate, one government, one state, etc., it looks very humongous. But I think one needs to sort of look at, if there are 1,000 big corporates, how do we get all 1,000 big corporates to also sort of join together and then add to that ocean? That's the second quick response. I'll share some examples of what we've been doing in terms of both watershed and agriculture per se. You are right in terms of most corporates would actually focus on their business value chains or the manufacturing catchments per se. But what's also happening now, sir, is I see a pattern where corporates are also moving towards the tier 2, tier 3 towns and districts from the earlier Bangalore cluster, Mumbai clusters, etc., more driven by incentives. Over a period of time, I see definitely the footprint may not be into the taluks the way you mentioned it, but at least the spread will increase. So few suggestions for consideration, and this is based on our own experience. We've been working in almost 50 districts in the country. We've done almost about 35,000 water structures, which has created a storage potential of almost 60 million cubic meters. whole soil moisture conservation of almost about applying 91 lakh metric tons of silt, the whole aspect of climate smart agriculture across about 31 lakh acres, 15 crop value chains. As I said yesterday, quite a few PPPs that we have worked in this particular area. In fact, our first PPP was with NABARD actually, and that was in Rajasthan and Maharashtra. So based on the learnings from what we have been doing, I see, yesterday I spoke of 7 C's. Today I'll speak of some other 6 elements. The first is corporates themselves will have to start becoming responsible. Typically, corporates would look at water only from inside the fence, what I call as inside the fence. Focus tends to be there. Not much focus goes on outside the fence. The outside the fence also will have a contributing factor in the larger catchment or the larger basin area. How do we get, whether it is through law or through value systems, get corporates to participate in watershed interventions outside their factory fence also, what we call as the outside the fence. So that's being responsible in terms of what you're doing. Otherwise, on one side, we'll do all the efforts that the government and others are doing, and this will negate per se. The second part of it is, how do we look at collaborations? And like what Sir was mentioning, most corporates work within their own catchments, and that is where, let's say, if they're wanting to put 1 lakh, they put 1 lakh there. But can we look at a model if they have to move outside their catchments? Some sort of a blended financing model could be an incentive or an attraction. If you put 30 rupees there, government will put some 40 rupees. So there's some sort of a co-sharing that could happen per se. The third element there that I'm seeing is in terms of collaboration is accelerating innovative ideas, accelerating transfer of knowledge from lab to land. How do we get corporates to participate? One, in prototypes and pilots. Power of government is in scaling up, in amplification. But if new initiatives have to be tried as prototypes or pilots in a sandbox environment, that's where again, both in terms of their physical presence as well as domain expertise, that could be looked at. The second element of collaboration there would be is in terms of, we saw today morning also, there was a lot of data that has been done by our scientific and research institutions. How do we drive interoperability in terms of using that rich set of data that has got created, translating into decisions, whether it's business decisions or translating it into a language that the farmer would understand. So that would actually help in terms of creating very rich cases. It can work backwards also. If somebody is looking at data sets, and I think it was mentioned in the previous panel that there is, you have a shortage of trained resources. The reason for shortage of trained resources would be budgets, etc. How could corporates collaborate on funding research projects with institutions so that they can actually put in more resources, better resources, reduce their cost of research? If I am present in 50 districts, can I actually partner with these institutions to ensure that we can collect data or provide data based on certain protocols so that you don't need to go everywhere at every place per se? Or even as you're doing the experiments, we can actually help you ground the experiments on ground. The other part is more in terms of orchestrating the local ecosystem. What I mean by orchestrating the local ecosystem is you have the local administration, and then you have the local community. You have the local, whether it is a KVK or the Agriculture Institute, etc. And since yesterday we have been discussing that community is at the center of it. We could actually facilitate, private sector could actually facilitate orchestrating the local ecosystem. And imagine it is like 100 odd lighthouses or 200 lighthouses, which then become as model and exemplars. And one of the examples that I see, sir, is there's something called India Sanitation Coalition, which is working with Department of Drinking Water and Urban Sanitation. So they have brought actually 8 or 10 corporates together. And they interface between DDWS and the corporates. And in the phase 1, we actually sort of worked on 75 gram panchayats as model gram panchayats. In phase 2, we are saying that corporates together, we will work in converting 150 blocks where you're leveraging government funding, leveraging corporate funding, and the local domain expertise. And it seems to be a very, very good model per se. Last piece, I think, is reporting. Reporting of impact and outcome. Very often when we sort of look at the lens, it doesn't sort of get covered in terms of all the data work that is being happening. So if there is again a protocol which can feed into a central portal of what others are doing, that can actually also help you.
Prabhakarji, the project or pilot which you mentioned about that it's being done in 75 places, is it already operational?
Yes, sir. I mean, the phase 1 is already completed.
Where?
I think it's in almost about 12 to 14 states.
Is it being done by ITC or by some other industry?
ITC, out of the 75, ITC did in 36.
36?
36.
Oh, that's great.
And
so
now they are looking at almost 150 blocks where there are 8 corporates. We are working in 50 blocks.
So which Ministry of Government of India is coordinating?
Department of Drinking Water and Urban Sanitation, DDWS.
Okay.
And previously we worked with Niti Aayog in 27 aspirational districts.
So we'll be grateful if you can share this data with us,
sure,
some documentation, so we can also think of such initiative in our department.
That's the way we should be looking at, sir, actually means how do you actually create a coalition of 10, 15 corporates, and each corporate takes a particular geography or districts, etc. You then create a multiplier effect actually. And most importantly, you demonstrate that it is actually possible to work in a literally a 4P model.
And what's the scale of the investment in these 75 villages?
So we would have, in terms of our efforts, our everything, we would have spent almost about 15 to 20 crores.
Total?
For in our 36.
Okay.
In our 36. I don't know about the spends of the other corporates.
Okay.
And in fact, the P4 model that you mentioned, means the public-private this thing, day before yesterday we had a discussion with the government of Andhra Pradesh.
So roughly it's 50 lakh rupees per project?
Per project, that was at a panchayat level.
At a panchayat level.
As you go to a block level, the spend will be much, much higher actually.
But is there any scientific planning like we do in a case of our watershed project, a scientific DPR making?
Absolutely.
Is it done?
Exactly the same way. In fact, we are working with Karnataka government on the South Pennar River Basin.
Would like to know about the cost, and if any outcome related evaluation is done, that will be very helpful. We also would be happy to know if the watershed development works can be executed at lower cost.
Absolutely.
If it is possible, we will definitely explore. Right now we are generally seeing that for executing a 5,000 hectare project as per our standards, it's taking 11 crore rupees. So if we can do it in 2-3 crore rupees, that will be a great saving on our part, and we can cover larger area.
Absolutely, absolutely. In fact, we'll be more than happy to sort of share all the details, including the impact assessment and the protocols that get followed. All these protocols follow the government norms actually. Through the DPR route, government does all the validation, etc. And it's not just for water, including land restoration.
You also may please find out if these 36 villages or these 75 gram panchayats, are they also falling under our project?
Sure.
Then it makes a huge difference. Recently what we have seen is that last week Honorable President of India, she gave away National Water Awards, and the top 2 gram panchayats which got the awards, first and second award, they are from Andhra Pradesh and they are from our project areas. So our project area has very good water harvesting works, and those works are helping the drinking water supply scheme. So you may please throw some light later on this aspect also.
I think that's a struggle we find in terms of these silos that exist, and which is where our learning has been is to able to converge at the collector level. Who has a line of sight of all that is happening in his or her catchment, it actually makes a difference. And that's the approach that we followed in Bhadrachalam, Bhadradri Kottagudam. And the awards that you mentioned, sir, is actually that district got in category 3 the first prize in the Jal Shakti award actually. And it was basically because of this integrated approach converging at the collector level. But more than happy to share the details.
Now I request Shri Bhavani ji from NABARD. He is Chief General Manager of NABARD. And NABARD has been our very old friend and partner in watershed development. We have seen NABARD working in watershed development, I think, since 80s or 90s. They also have executed Indo-German project for watershed development. So I think it's quite interesting to hear his thoughts about private sector's scope for private sector involvement. One more issue which you may touch upon is how can we monetize this LRI related data? I think you heard the sessions on LRI, they were highly technical, but still you and me, we should think how we can monetize it. The scientists are here, they will make it simple for common public's usage. So if we can put in place some monetizing model, if suppose the LRI data which Karnataka has gathered of 10 lakh hectares, if it can be given to some private vendor and he will make it available for common public. Yesterday we were listening to Mr. Chawla. Chawla has told that in AgriStack they are collecting the crop related data from each and every village for each land parcel by engaging volunteers who are being paid 15 rupees per land parcel. They are not depending on the village patwari or talati or mandal system. They are not depending on the regular revenue staff. So they have engaged some 6 lakh volunteers like this. So they have been paying for that, but there is a huge value for that work. So can we think of such thing if Karnataka LRI data, if it is made available to the common public, if suppose some farmer uses that and he pays 10 rupees, 50 rupees, whatever, and there is some platform aggregator like Uber, Ola, Airbnb, somebody who will be keeping that data updated, who will keep it refining, who will improvise the system delivery, and we all will get benefited. So along with your other experiences, you may please throw some light on such possibility also.
Very good afternoon to all of you. I am Bhavani Shankar. I am Chief General Manager of NABARD. I lead a department called Farm Sector Development Department at NABARD Head Office, Mumbai. Now, 3 aspects. One, I would quickly in a half a minute tell what's NABARD involvement in watershed development. Second, on the subject of this particular panel discussion, that is private sector involvement, I would also like to round it off with some good examples of, if with his permission, I'll talk the examples of ITC collaboration in this. First about NABARD, yes, as the chairman of the panel has said, NABARD started its watershed journey in 1992 with Indo-German Watershed Development Program. It's a long way. As of now, talking about some few numbers, we have roughly done 3,800 projects of 1,000 hectare each, covering around 27 lakh hectares. We have almost spent near 3,000 crores of grant over a period of time. These programs, which have initially started as a soil and water conservation model, has transformed over a period of time, evolved with many layers getting added, considering the factors of climate aberrations, climate change, adaptation, mitigation, and then the latest is adopting a landscape approach. For us, The landscape would mean integrations and building a social asset which is of significant impact. It's not about the money that is spent, it's about the catalytic effect that particular project would have. Now, this is about NABARD's in short, in very, short. And one other point is, I was listening to the presentations in the previous session. I was, unnerved with the kind of technology that is available and the data that is being generation. As Sir had said, we should productively use this data. We should certainly do monetization. Now, as far as private sector participation, our experience is that there are different ways private sector can join hands. One is the CSR, which is up to a limit, up to a particular limit, maybe 2% if I am right, 2% of the PAT, profit after tax. Yes, of course, right? That is one way of doing it. We have done many experiments. Right now we have about 50 odd projects going under CSR with the CSR partners, the corporates. We join hands with corporates. It is not just the money or the financial contribution that they would anyway willing to do so, but then to bring in the technical expertise they bring into the project implementation. I repeat, the expertise of project implementation, the professionalization of that, we look forward for that because they look from a different perspective than a public funded entity. In some instances, they help us as project implementation entities at the ground level. So for your information, and then our experience also says, things have changed. It is not necessary that the private entities are looking to work in their catchment area. I quote an example. There is something called social stock exchange, where the NPOs, that is non-profit organizations, propose projects. We are doing a project in Telangana, Adilabad district, remote areas of Adilabad, where Jerodha has contributed and we have contributed. Jerodha doesn't have any catchment area there. So this is how even the corporate's involvement is changing. Now, the second way of this is that I will again take the example of ITC. Second way of providing, see, Watershed is what? Watershed, I'm not a scientist, though I understand agriculture, but for me, Watershed is a platform where on which layers of livelihood can be built upon. This is my, and it's a planning tool for us to ground those livelihood interventions, right? In this context, the private entities, either they can invest or they can bring the investment that is sunk, that is put into that particular project area to translate into a clear livelihood, enhancement of the income. I quote an example here. Recently we have, ITC is an integral part, we have recently entered an MOU with them. There's a program called Kalyan Karnataka in this very state. There is 7 districts of Kalyan Karnataka where I quote example, all the districts are dry districts, if I understand properly. The 7 districts, the government, how public-private partnership works. Each part of this district is a watershed. Each part of this, every inch of this land, because it's all rainfed agriculture, a lot of watershed works, the scope is there. Now, state government has come forward and take a very proactive step of allocation of land. Allocation of land for setting up agro-processing units, right? Now, government has given land. From MP lads, some money has come. NABARD has put in some money. NABARD has helped in setting up those units through a third party. And then ITC volunteered to bring that market linkage to those agro-processing units. And the agro-processing units are being manned by farmer-producer organizations. I mean, this is how the private player can provide that cutting edge to an otherwise largely funded programs of any natural resource manager or any livelihood program that is by public entities. So this is how the programs can happen. And then on the monetization, sir, on the monetization part, yes, I mean, again, I come back to the rich wealth of data. Even we generate a lot of data. While I am not technically competent to provide any comment on that, but then we have also made a humble beginning of using geospatial technologies for planning, for monitoring and impact evaluation of the watersheds. We made a humble beginning. NRSA has helped us, and then some civil society organizations have helped us in building this. And a lot of data is getting generated. Soil data, land use planning, everything, lot of data is getting generated. That we are intending to build this data into the AgriStack, which is a larger entity, right? And then this particular data, I mean, monetization can happen in different ways, but this particular data, if it can be made available as fast as possible to all of us, each one of us, even for a common man, okay, then the impact would be much catalytic. Our investments, whether it comes from public sector or private sector, will have a meaningful impact when that happens. So I stop here. As we progress, I am ready to contribute to the discussions. Thank you.
Thank you, Bhavaniji. Now I request Mr. Amit Vatsayan, Sector Head, Sector Lead for Agriculture and Social Sector Advisory, E&Y. So you may please share your thoughts on this.
Thank you. Good afternoon, everyone. Thank you, sir, for giving this opportunity. I'm Tanay Joshi. I'm replacing Amit Vatsan. He had to go back. I'm a researcher by profession, recently moved into consulting, so I'll probably speak about the operationalization of what has been happening and how things are working. So primarily when we visit, or if we are invited by any of the big conglomerates having discussion around such topics, the first and the foremost question we've been asked is what kind of solutions are available? And everyone starts with the solutions. They need solutions which are frugal, at the same time solutions which are scalable. If you don't go with these two words to any of such corporates or for that matter any big business conglomerates, it is very difficult for them to digest that where and what kind of, because everyone is now looking for a social return on investment, and there are indicators which are to be followed, there are measurements, there are some scales which have to be observed, because every single penny has to be accountable. And that return cannot just be, it should not be just balancing out. So basically it should be at least 3 to 4 times of what you've been doing. So primarily generating empirical evidences and going with empirical evidences has become a necessity now. And data is really doing that. Second important point that we have, that once you have developed some successful models, once there are some successful models around, government has been very supportive, specifically in Karnataka. With one big business conglomerate, we were working on some FPOs, and the FPO's output sales and the total revenue, it increased from about 40 million Indian rupees to about 100 million Indian rupees in a matter of 3 years, which was well received. Right now with Government of Karnataka, Watershed Development Department, there are 20 FPOs. These FPOs were just doing small businesses, very, very small businesses, and with the intervention, because it's primarily, it's primarily the community-driven initiative, and ultimately these initiatives have to have some return. So just 18 months, now the value which was a small business, it is from about 5 million to about 1 million plus Indian rupees worth of revenue, and it's just 18 months. So when
the conglomerates, they see such examples. Of course, blended finance, I mean, NABARD supporting, other private players supporting, government has a little say to everything. With all that, this ecosystem, when it evolves itself, it becomes really, really important for all of us. So for us, the key takeaway is that, firstly, you bring solutions which are really acceptable, which can generate empirical evidences. Two, all of these solutions should be having participatory approaches, because participatory approaches have very strong force that it can scale any technology, it can scale any intervention to the extent which is highly replicable, adaptable, and it's fast-paced. So I think these are some of the points which I felt they're very logically aligned to what we intend to do. Thank you.
Okay, something has come to my mind. You all please may give it a thought. Since last few days, we are thinking of introducing agri-voltaic or pastoral voltaic in our watershed project areas. We all know that there has been tremendous growth of solar energy sector in last few years. But there is a criticism on that it's damaging the natural ecosystem, it's damaging the grasslands. And where are generally these solar power projects are located? They are generally located in drought prone areas, where there is large land available, which is barren land or less fertile land. So there is some thought that if the solar panels height is increased, then you can practice horticulture, especially vegetable cultivation, or a crop which doesn't grow much taller. And in some cases we have seen that even sheep rearing or goat rearing is also possible. So here I think we can think of a PPP model. If a corporate is already there in our project area, then we can definitely, we have higher chances of roping him in. For example, if in our project area, if there are 5 gram panchayats, 5 villages, and if some solar power plant is coming there, can we have a kind of synergy or a kind of arrangement with that investment, that the corporate will have to spend something on soil and water conservation in that project area, and whatever is possible by practicing solar voltaic, agri-voltaic or pastoral voltaic, that can be an added benefit for him and for the farmer. We can very well speak to MNRE ministry and other relevant ministries, and we can come up with such model. देखो हमारे यहाँ अदरवाइज कोई इन्वेस्टमेंट नहीं आ रहा है, अब उसका क्या लेना है भाई? अगर सर्विस सेक्टर है वो ठीक है, 2% से he will spend some CSR money there, will do some work, but he doesn't have any permanent stake in that area. But if some solar power plant is coming in our area, then we can definitely tag these aspects with that. And we will definitely need support from 2-3 ministries, but this can be done. I think we can suggest some state to undertake a pilot, and along with these added income, I think they should be, if suppose they have taken some 500 hectares of land for solar power, if we advise them, you please have some more height and you also do contract farming, or you also have vegetable farming, you earn additional income through that, and whatever additional income you generate, you please spend some amount of that in the watershed development activities for those 4-5 villages. So this kind of model I think is possible. So this thought just came to my mind. I would also like to know from you if some of you can throw some light on this. We have one more speaker, but we have time till 2, so we have a lot of time. So now I request our friend from Sambodhi to please share his thoughts.
Good afternoon, sir, and thank you so much for this opportunity. I am Abhishek Sharma and I lead the research vertical, especially for livelihoods and agriculture at Sambodhi Research and Communications. In fact, we are the evaluation partners for the reward program in Odisha as well, and we've been working very closely with the team. We very recently conducted the baseline assessment and the midline evaluation also, and we've been sharing the findings with the team in Odisha. Some slide that I would want to share or throw light on, probably based on today's discussion. I've been seeing a lot of data being churned out, a lot of analysis and GIS data available. Then we also heard something on collaboration, partnerships, community participation, and maybe a negative word of isolation as well. So some of the factors that I believe are very crucial for the success of a program, particularly in the watershed and the agriculture space, would be largely the 5 pointers. The first pointer, which all of us have been talking about, is we cannot look at watersheds in isolation. We are working in a systems wherein this system is exposed or interacting with the other systems around it as well. So for example, the livelihoods is also getting affected. Poverty reduction is also one of the factors that is getting influenced because of the watershed interventions. So this is more of a geo-hydrological as well as a socio-economic sort of a model that one needs to undertake and probably understand. So this requires not only looking at improving soil moisture, but also looking at the other structures. So for example, forestry, agriculture, livelihoods, poverty reduction, so on and so forth. So all these systems talking to each other, sharing data, sharing learnings from each other, and then trying to achieve the objectives towards the end. The second most important point, which my fellow panelists also talked about, was on community participation, participatory approaches, and community engagement, which is at the crux of the program. Because at the end of the day, we are interacting with the farmers, and the farmer is the focal point here. All the kinds of community institutions, if they are not strong, probably the program might not be able to achieve the objectives to the fullest potential. So some of the structures that we usually use, so for example, the self-help groups, the watershed committees, the water user groups, and the other kinds of similar committees and groups that are formed within the communities are basically the backbone of the entire program. Some of the pointers that I would also want to share with all of you is that, we are basically asking the farmer to change the practices, the farming practices that has been working for him or her for the last so many years, and maybe for generations. In the LRI card, we are mentioning some of the crops that probably they should be undertaking to basically increase their profits. Now, a lot of convincing is required, actually, and that requires a lot of people to be on the ground to convince the farmer to take up certain activities. So here is where I think the collaboration model can also come up, because there are a lot of cadres that are already available on the field. So there are Pashu Sakhis, there are Van Sakhis, there are Krishi Sakhis that are already some of the structures or some of the institutions that have been promoted by the NRLM. Probably they could also be leveraged to actually further the kind of information to the community and inculcate that sort of a change, because in a way we are talking about a behavioral change, and we all know how that goes. That usually takes a lot of time to register any changes at a scale. The third most important point is that we should be leveraging not only the surface water, groundwater, but also look at obviously the integration of the third structure based on the different water structures that we're talking about, the farm ponds, the percolation tanks, and so on and so forth. So making use of all the water that is available through all these structures. Because if we only rely on irrigation from the surface water, obviously that leads to runoff, and obviously you'll be losing the topsoil, which leads to decrease in fertility, and obviously the lesser price for the produce for the farmer. The fourth, which I think is the most important pillar, is the policy and the various the institutions that are following, or the policy guidelines. So one, the most important component here, I would say, is the understanding or a shared understanding of the policy guidelines by all the stakeholders. The second is the continuous monitoring of that data, whether the policy is being implemented to the T, or are there any gaps, challenges, customizations made over a period of time. That also brings up a lot of learning. The third is the learning component. So there are a lot of interventions that are happening all across the country. We were talking about a few interventions here as well. Why not have a learning mechanism, maybe a learning unit which is set up at the national level or a state level, which basically collates all the data that is getting generated from different sources, assimilates that information, synthesizes it, and helps inform the policy over a period of time. I think that could also be really very helpful. And the last pointer, which is the farmer-centric approach or a livelihood-centric approach as well. So whatever interventions that are being undertaken in a watershed program, at the end of the day, if it is helping the program, helping the farmer achieve its objectives, which is the profit, which is getting a better produce for the, getting a better buck for the produce, I think that is very, very crucial, while also maintaining or looking into aspects of social equity, whether it is only the more financially well-off farmers getting the benefits of the program, or is it the more marginalized communities also getting the benefits? So these are some of the thoughts that I just wanted to share with all of you. Happy to go ahead with the discussion as well.
Thank you, Mr. Sharma. So taking forward the thought which I just mentioned is that there is going to be more and more spread of solar energy sector. The reason is, we all know that due to climate change, the thermal power is going down and renewable is going up. And if we see the focus of our industrial policy now, it will be on data centers, on AI. And to run the AI systems, you need data centers. And data centers need huge amount of energy. And we can't imagine the kind of energy which is required to have that computing power. It will require huge energy. And if the solar sector is going to go, this energy is ultimately going to come from solar sector. In the world, there are certain examples where the big cities are opposing data centers coming up in the area. Their fear is that if they come up, then there will be a shortage of electricity. So in case of India, we can produce more and more electricity. We can satisfy demand of both. So that is the thinking, I think. So my point is, solar is going to expand. And it's going to expand in our areas, in our drought-prone areas. So we can definitely catch up upon this. So I would like to know from some experts sitting in this hall how we can go about this. We can definitely tie up with MNRE and we can get the necessary policy changes in place. We can at least give a try. देखिए बाकी सब philosophy ठीक है, पैसा कहाँ से लाएं? Who has got his skin in that area, in the game? If some industry has their physical presence in our area, it's most likely that they will invest in the welfare of that area. Otherwise, the CSR is good, but CSR is too small. CSR amount, whichever is coming, is too small. It's not sufficient to take care of our requirements. So I think this is one of the resources which we can definitely tap. So I would like to know from experts sitting in this hall if they have any opinion on this. Yes, please. Junaid.
Sir, this was a very interesting and enriching discussion. I want to add some points from our own experience in Rajasthan. I think we have the government looking for CSR, and at the same time there is private sector also looking for ways to engage with government. So there is demand also, there is supply also. What is lacking is kind of platform where the roles are very specifically clearly defined. So when it comes to our experience, even in Watershed projects, some companies may be interested in building the civil structures. Some are interested in helping us in the technical expertise part. Some are more interested in giving their expertise in community engagement, participatory rural appraisal. Some are looking for documentation and impact analysis part. So if we can define the clear area where we need private participation, that's definitely a good start. So that's the area I think where we need to work. If you have a good platform, if you have a good data layer, you have a portal, these things will definitely give the CSR partners also a better starting point. That has been our experience. ITC is also doing Watershed project in Rajasthan. In Jalabad district they are doing, where we clearly
gave them the area that was out of, not in our project area, it was out of the project area. And we told them that this area is delineated for you. So they have a better understanding. We can even give the pre-survey data that the existing conditions are like this and you can now intervene. So if you have that kind of data layer, that kind of planning tools, that's also a good area for CSR. Another thing, sir, I have one more thing. Last year, our finance department suggested that the government PSUs, they should also chip in. They are also spending CSRs. There are good PSUs who are earning a huge amount of profit. So that's a very good start. Government PSUs can also chip in. And lot of scope is there for, today we discuss about lot of data and data collection. And instrumentation is an area where even I went to ICRISAT project area also, their instruments are also imported from other countries. So there is a lot of scope for startups also to pitch into Watershed. So not in terms of monetary support, but in terms of technical support, new startups can also come. Finally, I want to thank the panelists, and I want to invite you for the CSR conference that we are doing in Jaipur on 1st December. We'll be providing you various, we have prepared packages for CSR to intervene. Like you want to intervene in skill development, you can do that. In capacity development, you can do that. So that's the kind of engagement, collaboration we are looking for. Thank you, sir.
Thank you, Junaid. We really appreciate the help which we are getting from CSR source. But there are thousands of claims on CSR. Watershed development is not the only worthy cause on which CSR is being requested for. So now is the time we need to think of bringing our own investment. So you are from Rajasthan, you are heading our program in Rajasthan. So can you think of some solar energy project which is there? I guess in Rajasthan there must be big solar projects or which is coming up, and we can experiment with this idea. If there is any requirement for policy change from Government of India, we'll definitely do it. But what I have seen is that Rajasthan is one of the most pro-watershed development states. The kind of importance Rajasthan, Karnataka, Maharashtra have given to watershed development, in some 2-3 other states also they are giving. But I must say that Rajasthan even now is giving the highest importance. So you can definitely explore this aspect with your power department, with your renewable energy department, and you can come up with some model project. So let's do a pilot. Getting a CSR fund of 5 lakh rupees in a project is not going to solve our problem. We need 5 crore rupees. And if suppose some industry has their investment, physical investment in our project area, and if it is related to our cause, then I think we may be able to gather that much investment. So please.
Definitely, sir, we'll explore this solar boom that is happening in Rajasthan. We have a lot of companies coming in, especially in the western part, and definitely this is an area where we are looking. Just want to mention one figure, sir. Last Mukhyamantri Jal Swawalamban Abhiyan period, the amount we collected through CSR was more than 100 crore rupees, not in lakhs. So because there was a very systematic collective campaign led by the Honorable Chief Minister himself. So if we have the will, sir, we can do this. That's what I want to say. Thank you, sir.
So that's very heartening to know that you have collected 100 crore rupees under CSR. We want other states also to take this lead. Last year during Watershed Yatra also we had appealed to all the states to get their Honorable CMs involved. When the Honorable CM is involved, the response from corporates is very spontaneous. So this is a very good example. But now I would like you to take up a task and please explore if you can do this pilot of solar plant. If required, you can try for agrivoltaic and pasture-voltaic and come up with a model. I want some progressive states to come up with model. Rajasthan is there, Maharashtra is there. Maharashtra is one more state which is very innovative. So there are other states, CEOs also, Jharkhand is also there. So please think of such ideas wherein we can bring in that kind of investment. The scale of degraded land is huge. with WDC 3 funds, we will not be able to achieve that saturation. To some extent, we should be able to make a larger impact. So if you can think of such projects, we'll be very happy. I would also like to know from CEO Karnataka, Upendraji, how can he think of monetizing the LRI data bank which you have generated? You have generated LRI of around 14 lakh hectares. So if you can get some startup which can act as an aggregator, which will provide services to people, to common farmers, and they will earn some revenue, and our purpose will get served. So if you can think of initiating such project, will be really grateful to Karnataka. That will act as a pilot, that will act as a lighthouse to entire country, and we can create a sustainable model. Right now, this data is only with us, or we are doing it in our government fashion. Government is not great when it comes to delivering such services. So I would like to know your thoughts on this.
Good afternoon to all. And the Karnataka Watershed Department is having around 46 lakh hectares data. And already we are in touch with the Rajiv Chawla Sahab. And as he presented yesterday, so again the idea is that the data which are with us, so that can be monetized. And the one idea what he has told to us to link this data with the agri-stack. That is one thing. And then again we have approached to the government, and we are trying to find out the people who can take this data, and basically if I give this data to somebody, so he should be in a position to utilize it. Unless and the data which we are having, actually that may be useful for the fertilizers as well as even planning also, because we have got a huge data, some 46 lakh hectares. So even for projects also, whether it's a canal project or any other project, even laying the fiber optics also. So we are exploring the possibilities because it is in the initial stage, and hopefully we will get somebody, and then we will try come back to the Government of India to also, so that we can tell to others how to do it. So that model we will try to develop. And one more thing which I wanted to say, like regarding the CSR, one thing which comes to my mind, that at least at the Government of India level, if we can tell to the corporate sector that these are the things where you can invest your CSR fund. This was a problem because, people who are in investing into the CSR funds with the government, they know what are the options available. But in watershed development sector, what are the opportunities? If we can provide that information to the corporate sector, and like in one department, I don't remember, they have made the packages as per their requirement. Suppose they have got 10 crores to invest or 20 lakhs to invest. So they have offered that, yes, if you are looking a project where you want to invest this much money, this is the project which you can opt. I think that may even provide a platform where the interactions may take place. I think this discussion, after you have taken this issue only, it is getting discussed till now. Otherwise it was just a matter of regular watershed development, and we were doing in our old-fashioned model. So in asking other participants, whether it's a corporate sector or public sector units, we should provide them information that these are the options available. I think this may help us. Thank you.
Thank you, Upendraji. So we are hopeful that Karnataka will submit a proposal very soon, and I think you will have to explore some issues like about privacy rights. I don't think there is any such hindrance in case of Indian context, but if it is there, you please examine that also. And other thing is I think for the price discovery or the bidding process related, that you can do. I think some other departments might also have done this. So you can find out what are the precedents on similar models.
Yes.
Their area, their sector may be different, but we can find out the model on which they have worked.
And as far as privacy things is concerned, we are in discussion. So because privacy of the data, for that we will find out some solution.
What we can do, in case of AgriStack, the information is there. So if there is really an issue regarding sharing of the data of one farmer with another, then you can link it to his phone number. Nowadays, we all are using that way only. Our phone number is our password or is our key to access that data. So if the relevant farmer, if the owner of the land or if the leaseholder, if he wants to know about his land's LRI related data or crop advisory or nutrient advisory, then he will only be able to access the LRI related information by logging in through his phone number. Yeah. So I think there is a solution if suppose there is any privacy issue.
Yeah. No, definitely there is a solution. We will find it out. No problem.
Okay.
Thank you.
Thank you. Umakanji wants to say something. Yeah.
Thank you, Chair. Watershed development in our country has been facing the challenge of sustainability. We all are aware of it. What I understand, and I'm a firm believer that the sustainability could be ensured by making the economic model rolling. And there comes the role of FPOs. And I'm happy to see all the four panelists apart from the chair who have contributed largely, and their long history of association with the government and sector. I believe that the opportunity available, though as you mentioned, the amount involvement is maybe not much in respect to or when you compare with the government allocations, but nevertheless, I believe that their role as the private player is humongous. Whenever a government servant approaches a community, they have got a different hue, different perception. But a private sector organization, when they approach the community, they have got their stake differently understood. So I would request that if 10,000 FPOs have to be operationalized, I believe most of them must have been operationalized by now, what Ministry of Agriculture has conceived the idea of one of the schemes. The FPO, wherever the private players have done their exercise, must have realized the kind of challenges they have faced while operationalization. I would request, can all the private panelists available today to come up with a model, standard model of functioning of the FPOs, and then depending upon the suitability as per the state's requirement, we can customize those things. Because this varies. You cannot say that FFPO 1 working in Maharashtra is doing well, earning 400 of crores of rupees. I know one of the FPOs who has within 4 years could realize the 40 crores of rupees when they started with 1 lakh or 2 lakh rupees. So can it be done? I think this is one of the area where our panelists could contribute largely. Thank you.
With the permission of Chair, can I, very interesting observation. First, connecting to the earlier suggestions that there should be a platform, right? Okay. And also the point made by Sir that the private corporates should have the information on the opportunities available. Yes, there certainly, I mean, in the recent times, these platforms have definitely evolved. In the sense, I mean, they may be few, but still there are beginnings in this. I quote an example from NABARD itself. We have a subsidiary, we have set up a subsidiary which is called NAB Foundation, okay, who interact with corporates on a periodic basis and implement projects to them. As Sir had said, 5 lakhs is not sufficient. Very true. I mean, it's a fact. It's a fact. 5 lakhs is not sufficient. Given the massiveness of Indian agriculture, even sir, even 5 crore is also not sufficient. If you have to go and implement a program, earlier we had the concept of micro watersheds, 1000 hectares or even 200, 500 hectares. But then now it is all about landscaping. Okay, so higher amounts are required. So, I mean, like NAP Foundation, there are definitely entities with whom we can hold an interaction, okay, and then bring the players together, throw some project ideas, and then start working on them. And as somebody else had said, it could be a sandbox environment, okay, and then this can be experimented upon. The other, and there is, I have made a mention of social stock exchange. Options, informations are certainly available on social stock exchange. I mean, the best part of social stock exchange is everybody can contribute. Everybody can contribute. It doesn't depend on their catchment area. Okay, any corporate can contribute. The biggest advantage of a social stock exchange post project is that there are independent social auditors or social assessors who will independently, they are professionally certified. They will evaluate and monitor the projects. So it also means that the organizational leanings which we have as a NABARD, if I have to monitor a project, I carry some baggage with me. Baggage in the sense my experiences. But then see, these social auditors or the assessors will have clear impact indicators and they strictly go by that. Okay. So that third party evaluation, which is very important for this kind of NRM projects, is built into that. So these are the immediate 2 examples that came to my mind. And coming to what sir has said, that FPOs, right sir? So I quote a small example here also. Sorry for quoting so many examples, but then these examples can as well be replicated. Now, the Government of India has come up with a program, 10,000 FPOs. All the 10,000 FPOs under Central Sector Scheme have been registered. Majority of them have got licenses for doing businesses. Input business, Mandi license, okay, GST number, all these are in place. Now, the moot point here is how many of them are doing the business, how the ecosystem is enabling them to do the businesses, and when NABARD is a part of that program, and when we have promoted FPOs under the scheme, we made it a point that we take up these FPOs in those areas where we already have a footprint in terms of a natural resource management project, like a watershed. Okay, so that majority of the programs, there is already a social structure that is inbuilt. Okay, so taking from this, how to make them effective, we have run a program called FPO Accelerator, where we are not giving promotional grants. No, we are not doing that. We are certainly not doing that. What we are doing that is, we choose a cohort of 30 FPOs or 40 FPOs. In that, it could be a watershed, it could be a district, it could be anything. Okay, and then work very closely in mentoring these FPOs for a year or year and a half. And the objective is to create a delta. Their turnover at this point of time is X, we move them to Y. Not great money is involved, but private market linkages. Here where again private sector could contribute. The market linkages are coming from, let us say, Reliance Foundation. Okay, or let us say an exporter. That very program is implemented in Maharashtra and Karnataka. So these are some additional points that I wanted to bring to your notice.
Yeah, you want to add something?
Yeah, I would, since you have mentioned about photovoltaics, agrivoltaics, and how these could be integrated. So there are some successful running models. I've worked in Tanzania in Masasi, Lindi region. And how it supports is like they are most efficient way of utilizing scarce natural, physical, financial, all 3 resources. What you have said has a wonderful, I think this could be a wonderful model even for this place, because what it does is the heights have been increased of those photovoltaic systems, And then they've been using some shade-loving crops, primarily the green leafy vegetables, which can even up to a shade of 50%. They can still sustain and give you an equivalent yield. So that's one of it. Now those shade-loving crops for Indian context, we are now preferring to eat a lot of exotic salads, and these crops are primarily lettuce, kale, broccoli, which is extremely expensive at certain point of time. You can even buy it for 400 rupees a kg at certain given point of time. Now what happens is, as you rightly said, we need to integrate FPOs. So there is this photovoltaic. You have those crops which are very, very important, which are shade loving. You are improving water use efficiency because there is less evapotranspiration out of those crops. At the same time, the land use efficiency is increasing. Diversification increases. The livelihood generation, because the entire region is surrounded by farmers, villagers who can integrate it to the small markets, the primary markets, and ultimately this goes into the market linkages with these the application platforms like Blinkit and Zepto, who would be very fast to pick it up. So I think this could work very well from the scratch right to the market. So this is something which is very, very doable.
Thank you. So we all need to think big. We need to think of big picture. What vision we have set? Our Honorable Prime Minister has set up a vision for all of us to make India a developed country by 2047. And to contribute in achieving that vision, we have set up a vision for our department. Let's make a drought-free India for a developed India. So what is the quantum of degraded land which we have at our hand? If the entire degraded land quantum in the country is 98 million hectares, and if we take out the forest land out of that, it's the non-forest land, that is the land which can be used for agricultural purposes, it's around 5 crore, 50 million hectare land. And how much money we are going to get from the WDC scheme? We may get the same kind of location which we are having in WC2. That is only for 5 million hectare. So it is coming to around 20,000 crore rupees if we take central and state share combined. Central share may be around 12,000 crore rupees. So to cover 50 million hectare, we may need 2 lakh crore rupees. So I agree, sustainability of the existing projects is important. We can definitely think of FPOs, we can definitely think of having some user charges, we can even think of supporting the local water supply schemes because their sources are getting strengthened from us. CSR, okay, crowdfunding, okay. But if we have to increase the pool of the agricultural land, then we need to find out additional resources. And we must understand what other sectors are doing. There is saturation in case of all sectors. Every village should have a school. Every household should have a toilet. Every kid should be in school. Every ladies' delivery should take place in an institutional place like a PHC or some kind of hospital. So if all other sectors are targeting for saturation, why shouldn't we target for at least near saturation? My point is, if suppose for ecological purposes we need to leave aside some 10 million hectare, theek hai. We should target to cover at least 40 million hectare. Then only we will be able to effectively contribute in achieving the vision of Develop India. Otherwise, doing only 3-4 million, 5 million in 5 years will not take us too far. By the time we develop this land, some other land will get into degraded category. So how much will be the net gain? So I want all of you to think of this bigger picture and give ideas accordingly. How can we source investment for making this happen? And government is telling us, explore how other sectors are doing. We have seen how other things have gone under transformation. We have seen passport offices, how were they 10-15 years back? Now you see how passport seva kendras are working. They have raised the revenue. They have given it on outsourcing. TCS is, I think, engaged. They have got very good office facilities. They are charging some user fees from citizens. But the service has increased and they have been able to do it in a very faster manner. They have been able to do they have been able to provide very fast and efficient service. So why not to think of such possibilities? I want all of you to think on these lines. Sustainability, yes, we should have FPO or village organizations or village cooperatives taking care of that. But what about the other remaining areas? We must understand that we are a growing population. Lot of agricultural land is being converted into non-agricultural for urbanization purposes, for other purposes. So point is, let's raise resources. Other states are also here. I took names of 4-5 states, but I would request them also to please come up with some concrete proposal. Andhra's director is also here, Shanmukh. Andhra has also been very positive. You are going to have AI city in Visakhapatnam. That will need lot of data centers, lot of electricity. So I think you will also be seeing huge solar growth in your state. So you can definitely think of this model. So I would like you to come up with concrete proposals. If some state does some pilot, we can definitely take it up at Government of India level. We will also take up from MNRE and with MNRE, and let's take this forward. As of now, I am seeing only this as a major source. Otherwise, we don't have any other major source. The first model which I mentioned in my opening remarks is very difficult. It's very difficult. Give away land to some private party is little difficult in our setup. But if this we can think of, if we can impose some obligations on the solar corporate that you'll have to do this if you want to set up a solar plant of this capacity in this area. We can definitely think of this, and we can also suggest to him that you can maximize your revenue by undertaking this agricultural activity in your solar plant or this pastoral activity. So please give a deeper thought to this. I would lastly request Dr. Million from Ethiopia to please share his thoughts on public-private partnership. Yesterday he made a brief mention that they have successfully done public-private partnership in watershed development. So Dr. Million, please come on the dais and you can share your thoughts. So we will see how it can be adapted to Indian situation. So that will be really a very good model for us if it suits Indian conditions.
Sir, sir, I have one submission, sir. Tata Projects, one of my colleague was supposed to come, he didn't turn up for the project. We are putting a lot of solar panels in Chitradurga and Hospet area. And your model, we can come into this model, sir. You can come into the participatory, this one, wherein all these ideas, we can give you a pilot project, sir. But he didn't turn up today. And your idea of putting all that, this one under the solar project, I think so it will work out, sir. We can just put a pilot project and we'll say submit this proposal. You can look at it, and we want to bring all those concerned departments into that ambit, and we can submit the proposal, sir. If you can kindly cooperate on that, and
definitely we will give all kind of support. You please bring up a proposal. We'll talk to the state government concerned. I guess now a lot of solar related decisions are done at the state level. But if there is anything which we need to talk to the state government, we'll definitely do it.
Yeah, he's already working with Karnataka Renewables, sir. He's already done a lot of projects with Karnataka Renewables. He's put a lot of projects on solar projects in all these 2 districts. Maybe we can collaborate and we can come back to you, sir. We are thankful for that, sir. Thank you.
Thank you. Thank you so much. Please bring up as soon as possible. Yes, please.
Yeah, thank you so much. Again, I think this is an important issue for all of us. For all of us, it's a very important and also a challenging issue. From Ethiopia experience, what we did was, like 5 years back, 6 years back, we tried to approach a brewery, beer brewery, in the northern part, Tigray region, Raya Brewery. Its name is Raya Brewery. So the Raya Brewery is pumping water from, the site, like 10 kilometers far from the town. So we had a project supported by the World Bank in a different watershed. So we talked to the university, Mekelle University, We had very good colleagues there. Then how the Raya brewery is pumping from that 10 kilometers from a community and, selling the beer without supporting even those communities. Not only supporting the communities, for its own sustainable water supply. Now, we convinced them, and then imagine without outside of our target watersheds, they said okay. Now, through the process, we developed, all the agreement, memorandum of understanding, are supporting the regional state, Bureau of Agriculture, and also work closely with the university, Macaulay University. And then we came together, discuss, and then they actually did it. They allocated 200,000 USD to just, protect that area for the priority actions related to the watershed management activities. Where really the national government, the federal government, Ministry of Finance officials were very happy. I myself was very happy with colleagues, with the task team, was the World Bank team. We were very happy. That is also well taken by the World Bank management. Oh, please can you go ahead with this type of, supporting the communities. The Raya Brewery did that. Not only, paid, transfers the money, that 200,000 money to the Bureau of Agriculture. It's also assigned a study to team, what is the impact of those activities done by 200,000 USD. So
Dr. Millian,
that relation is established, and the Ministry of Finance, the government, Ethiopian government officials, why not you just keep on this? Now, the challenge is we have the same many companies pumping water and selling the water everywhere in the town. We approach Heineken, we approach the water pumping companies, but we don't have a legal system to influence them. The Ethiopian government now is under, preparation to approve payment for ecosystem service, which is going to be legally approved as a proclamation, which is going to help us to approach now legally. Fortunately, before that, there are 3 companies now down in the southern part of Ethiopia, which already, interested to support, us in my presentation, like 1.6 million Ethiopian birr assigned now. The regional government already signed memorandum of understanding. This is really what we have to push with the help of the state government or the national government, supporting policy documents, including the proclamation. Thank you very much.
Thank you, Dr. Millian. So, I think in Ethiopia, the watershed development and the water resources development is is under one and the same ministry. Water ministry is different.
Ministry of Agriculture is, responsible for undertaking the watershed management. The Ministry of Water and Energy is separate, but we have included them in the National Steering Committee, so that we can work together. We advise the Minister of, the Ministry of Agriculture as well as the Ministry of Water to assign a person in our technical and steering committee at national level. That is how we just, try to work together.
So, I think we need to find out in Indian context how we can adapt this model. We need to see to the Indian setup. We have Jal Shakti Ministry, Department of Water Resources, Department of Drinking Water, and right now they are thinking of making such enactment, some law or rule which imposes such, which I think probably imposes such obligations on the industry. They have pan-India mandate. Okay, we have mandate in very limited area. We have in a very small presence compared to them. So, if some such arrangement is to be done, I think it is in their domain. So then what is left to us to explore other sources? As I mentioned, if we can think of solar sector as our partner, they are solely, I think, no other ministry apart from MNRE, Ministry of Natural and Renewable Energy, no other ministry has any domain as such on that. So I think we can definitely explore this. We'll also explore how it is done in Ethiopia. One more point which I would like to know from you is whether the private sector has actually implemented watershed development works? No?
You know, as I said, look, I have also, someone asked me about the watershed, how they evolve, you know, the evolution of watershed, because we have tried a lot through even my experience. Now, you have to have, as I said, at the country level or at ministerial level, strategic framework for undertaking the watershed itself, you know. So now we have developed the second ISIF, Ethiopian Strategic Investment Framework for Sustainable Land Management, for which all development comes together and you know, supports the government based on that document. That is, it helps you to coordinate and also to align what you are doing, you know, in terms of getting the results at higher level. So that is one point, by the way. So what I'm suggesting is you need to have a guidelines, the document at state level or at a national level, no problem for that. But the private sector is somewhat weak. It seems in Ethiopia weak. But when we are approaching and coming with a convincing idea, how do you pump water from a poor community and sell the beer without helping them? That was a challenge for Ethiopian government, in which we convinced now to get that proclamation. Once we get, it's not, you know, enforcing or quarreling with the private sector. No. We start even to work with IFC nowadays. We try to get their input as well. International Finance Corporation, working with the private sector, you know, so that linkage is now also established in our, you know, task team in the World Bank country office, which I'm also very happy to see the result in the coming, you know, P4R program for results project, program actually. Thank you.
Thank you, Dr. Millian. I thank all the esteemed panelists for sharing their thoughts on.
Sir, I have a suggestion. Sir, I am here.
We can catch up during the lunch time.
Okay, Niti Ayog can take up this collaboration, sir, what you are trying to promote now. Maybe, because I'm also part of the Niti Ayog, maybe Niti Ayog can do this collaboration involving all the other departments in the state and the central, as well as all the stakeholders in this one, sir. That is only my suggestion. If you can just explore
Definitely,
the option.
we will
you
be...
can explore the option, sir.
We'll be very happy to explore that.
Yeah, Niti Ayog will be much better, sir.
You can get in touch with Dr. Reddy, our Senior Additional Commissioner.
Yes, sir. Yes, sir.
Immediately take it forward.
Yes, sir.
If required, you can contact me also.
Yeah,
so
we'll
this
do it,
is
sir.
a very, I think, very encouraging idea to meet our investment deficit. Right now, we are not getting that much funding directly from the government. So we need to tap other sources. How we can raise funds from other investments so that we can cover more and more degraded land or rainfed area under watershed development activities. So I thank all the esteemed panelists for giving us very useful insights on private sector's participations in watershed development activities. Thank you.
I heartily thank all the distinguished panelists for sharing your valuable insights during this session. Your practical examples, forward-looking strategies you presented have provided us with a deeper understanding of how a private sector partnership can accelerate efficiency, resilience and sustainability in watershed management and agricultural transformation. Thank you one and all. And I thank delegates of the dais for sharing your valuable inputs during this session. And also rapporteurs of this session. And mainly I thank our respected chairperson of this session for your thoughtful ideas, insightful guidance and balanced stewardship of this session. Your contribution has truly enriched the deliberations and strengthened the overall impact of this program. Thank you, sir.
I would now request Sri Nitin Khade sir, IAS, Joint Secretary, DOL, New Delhi, to kindly present a token of appreciation to all the guest speakers who are here, our panelists. May I expect big round of applause from the audience. अभिनंदन के समय थालियों करताल का
A quick announcement for the delegates. Tomorrow before going to the field visit, I request you to kindly check out the rooms and you can directly go to the field visits. Then from field visit, you will be directly dropped to the airport. So I once again request all of you to, before going to the who are all going to the field visits tomorrow at 7:30. So you need to check out your rooms. Then you can travel to the field visit, and directly from the field visits, you will be dropped to airport. Thank you. And whoever has flights in the evening, so you will be directly dropped to the airport after field visit.
Yes, sir. Yes, sir. Now we'll break for lunch. Shall I mention the time now to reassemble here? By 3 p.m. sharp. I think we have got sufficient time for the lunch now. Thank you. Thank you one and all.
स्थानिक डेटाबेस विभिन्न स्रोतों से प्राप्त किए जाते हैं और उन्हें तत्काल उपयोग के लिए संग्रहित किया जाता है। DSS एक संगणन आधारित विशेषज्ञ प्रणाली है जिसमें वैज्ञानिक डेटा को निर्णय मानदंडों के साथ एकीकृत करके किसी स्थान विशेष के लिए उपयुक्त हस्तक्षेप उत्पन्न किए जाते हैं।
Ladies and gentlemen, after lunch break, so we are going to start technical session 5. This is the last technical session. It will be going to start now shortly. We are going to start this technical session 5. And I request all the delegates and all the participants after your lunch kindly come to the conference hall. We are shortly going to start our technical session 5 on impact assessment and community engagement in watershed projects. The chairperson will be Dr. Crispino Lobo, Watershed Organizations Trust, Pune. And we have 6 distinguished speakers during this session. Dr. Vivek Pandey, Sri David Hogg, Dr. JVR Murthy, Dr. McQuint Melisse, Sri Sagar Bharat Katkale, and Dr. NG Patil. These are the 5 esteemed speakers. They are going to share their views and insights on impact assessment and community engagement in watershed projects. Once again, I request all the participants and delegates after your lunch kindly come to the conference hall. Shortly, we are going to start the technical session 5, and this will be the last technical session during this conference. The rapporteurs for this session will be Dr. Manjula N, Professor of Agriculture Extension, US, Bangalore, and Sri Parameshwarappa KJ, Consultant Watershed Development Department, Government of Karnataka. I request both of you to come to the dais. Ladies and gentlemen, shortly we are going to start our technical session. I request all of you to come to the conference hall. Rapporteurs are there. They are coming. I hope our speakers also present here. Evidence-based impact assessment of watershed development. This topic will be delivered by Dr. Vivek Pandey. Then embedding social capital into agriculture and rural development programs. This topic will be delivered by Sri David Hogg, Chief Regenerative Agriculture Advisor, Nandi Foundation, Hyderabad. And Dr. JVR Murthy sir will be dealing on the topic emerging pathways for engaging local institutions for climate resilient watershed management. And is there? Okay. And Dr. McQuint Melisse, Senior Scientist ICRIS at Nairobi. Okay. He'll be dealing on the topic challenges in scaling agriculture technologies and determinants of adoption in smallholder systems in Africa. And Sri Sagar Bharat Katkale, DBT Specialist, POCRA, Mumbai. Sir, are you there? And Okay. Sir will be dealing on the topic lessons learned from project on climate resilient agriculture. And Dr. NG Patil sir, Director NBSS and yes sir. So sir will be throwing light on scaling up LRI at national level and its challenges. So once again I request all the participants and delegates kindly come to the conference hall. We are shortly going to start our sessions.
all dignitaries and participants. How was the lunch today? Can anyone tell what were the delicacies that was there during lunch? I'm just trying to make you wake up. Can anybody? The most number of delicacies who actually says Rutter will have a prize. That will come to know later, so that's surprise. Shall we start now? Thought of waiting for 2 more minutes. All right. Post-lunch, we are going to start technical session 5, impact assessment and community engagement in watershed projects. This will be chaired by Dr. Crispino Lobo, Watershed Organization Trust, WOTR, Pune. So with this, the 2 rapporteurs, Manjula N, Professor Agriculture Extension, US Bangalore, and Shri Parameshwarappa KJ, Consultant, Watershed Development Department. Ladies and gentlemen, just to give brief introduction about Crispino Lobo, the chairperson. Crispino Lobo is a pioneering figure in watershed development and natural resource management in India. Best known as the co-founder and managing trustee of Watershed Organization Trust, that is WOTR, established in 1993. Prior to founding WOTR, he served as program coordinator of the Indian-German Watershed Development Program, that is IGWDP, from 1989 to 2001, overseeing large-scale watershed interventions in Maharashtra. Under his leadership, WOTR developed pioneering participatory methodologies, notably the participatory operational pedagogy and participatory net planning, that is PNP, approaches, which have since been widely adopted across national watershed programs. Crispino brings a strong academic and multidisciplinary background. He holds multiple degrees across physiology, theology, psychology, economics, and public administrations, and is an alumnus of Harvard Kennedy School, USA, and Gokhale Institute of Politics and Economics in India. Over nearly 3 decades, his work, spanning grassroots watershed implementation, capacity building, livelihood support, microfinance, and policy advocacy, has impacted millions of rural lives and influenced national water resource management policies. With his brief introduction, now I would like to call upon Vivek Madinuru, Research Manager, IRMA, Anand, Gujarat. Just to give a very brief introduction about Mr. Vivek Madinuru, he is the research manager. He is involved in government and World Bank funded projects concerning livelihoods, nutrition, and agriculture. He has designed SHG simulative game, that is 5 years SHG life cycle constricted into only the 5 hours. That's the beauty. In the field of experiments and then impact evaluation studies across the country. I would now request Mr. Vivek Madinuru, Research Manager, to come on the dais and present. Thank you, sir.
May I make a request, please? Each one has been given about 20 minutes.
Yes, sir.
So I request you to please keep your presentation for about 15 minutes, so that 5 minutes we could leave it open to the audience to ask questions.
Sure.
About 20 minutes is yours.
Sure.
Thank you.
Yes, sir. Thank you, sir. Good afternoon, everyone. Myself, Vivek Madinur. I am replacing Professor Vivek Pandey from IRMA. I work under him as a research manager at IRMA,
and I am closely associated with the reward project, and since it is post lunch, please don't mind me if I start at a little bit of a lighter note. This is a completely fictional story, okay? So I went to Parmeshwarappa sir and I told him, sir, we have done so much work. I have millions of data points. Let me present it, sir. We have done so many things. And Parmeshwarappa sir said, oh, is it? Then tell me what all is happening. Is reward performing very well? Are we doing good job? Are the results good? I said, I don't know, sir. Game to abhi baki hai. We have just started. I don't know. But please give me good time slot, sir. Parmeshwarappa sir said, take the first slot. Start in the morning. I was like, no, sir. A lot of people would not have come. It is still very fresh day. We can't be doing that. Then he said, okay, start after 12 o'clock, after tea break. And I was like, sir, there are a lot of big people who will be coming. I need to meet them. I need to talk to them. There are a lot of ideas that get shared. Nowhere in the world, 30 minutes tea break ends at 30 minutes. Right? I was like, sir, please, sir, don't do that to me. Then Parmeshwarappa sir said, okay, then take after lunch. I was like, sir, who will listen to me after lunch? Right? He was so irritated. Now we all are here. Yeah? Please don't be irritated. Just bear with me and my presence for next 15 minutes and we will show something maybe unique, and let's start. So what we are trying to do is, we are trying to see whether there is any impact or is there a way that we can study the impact of lot of these watershed based interventions, right? There are n number of watershed based interventions, not just in the world, even in the country, right? There is PMKSY, there is integrated watershed management, there is reward, there was Sujala. There are so many different models with different ideas and with different things and departments coming together with different levels of technologies, right? So we wanted to see, and it is a very expensive project, right? Like a lot of people have already shared on this dais. So we wanted to know if there is a way where we can use geospatial data in order to do impact evaluation, right? The reason why we were taking geospatial data is, no matter what the constraints are, we can obtain the satellite data because the work on that has already been done across the country, across the globe, right? So the satellite data are available. We need technical know-how and systems to process it. So we were wondering if there is a way where we can evaluate the watershed interventions using GIS, geospatial data. So what we have done here is, we have tried to compare the reward watershed with the control areas around it and see if we can see any discernible changes between the two. And the curiosity got a little bit better of us as well as the commissioner sir of WDD, and we were wondering, can we also do watershed project versus watershed project comparative study in order to know what kind of interventions bring out better outcomes and can be more helpful. So when commissioner sir suggested this idea, we picked it up immediately and we were like, yes sir, let us do it. So we are trying to explain how we are using certain econometrics and GIS data in order to do this impact evaluation. These are the watersheds that we have selected. We have selected a watershed Chitragi from Bagalkot, Maidalkere from Tumkur. These two are treated reward watersheds, and we are trying to see what is the evaluation result between them and the control areas. And what we are also going to do, because of our curiosity, is try to see whether there are any discernible changes or in terms of impact between Maidalkere watershed, which is reward watershed project, and Yeladevara Halla, which is PMKSY 2.0 watershed, right? Again, lot of it is based on our own curiosity ideas from the various officials from WDD, and our zeal to understand what is happening and which is good, right? That is where a lot of our studies in this particular presentation are coming from. Like I explained, these will be the reward areas. This is the PMKSY watershed intervention, and we will be also comparing in the end between Maidalkere and Yeladevara Halla, right? So what we did was, we compiled data from various satellites for various things. For indices, to compute indices like NDVI, NDWI and all, we tried to use 10-meter resolution data which are obtained at 5 days interval from Sentinel-2. For rainfall data, we relied on chirps. For temperature, we relied on MODIS mainly, right? Lot of the data, KSRSAC helped us a lot in order to obtain them and in order to process them. What we did was, because we tried to make every 10 meter by 10 meter pixel as one data point. Understand that we have not, like normal econometrics, we have not sampled from the population. Whatever pixels we are having in that watershed, we are taking all of them to our analysis. So it is a complete population to population analysis and not a sampling based analysis, right? So there is no room for saying something like this sample might be biased, that I may not have considered a certain area, or there might be issue with the sampling itself, right? So every 10 meter by 10 meter resolution pixel, I consider it as one data point, and then I use it for my analysis, okay? Because we have millions of data points, this is the, we have 11.28 million pixels across all three watersheds that we are considering. Because I need to consider them for every single season in every single year. My time period of study was between 2018 and 2024, right? So every year, if I say Rabi, Kharif and Zaid, I have 3 data points per pixel per year. So that is the amount of data that we had to compute, right? To do that, we have used Google virtual machine and we have used Google Earth, right? These are the major 4 indices that we try to analyze, right? What we are trying to do here is land surface water index gives us the moisture level at moisture content at the soil surface level. Normalized difference vegetation index, normalized difference water index and soil adjusted vegetation. These are the certain parameters that we used in order for our evaluation. Why are we using these parameters? Because 2 of the major biophysical parameters that we expect to change because of water intervention is water availability and greenery and vegetation and the photosynthetic activity in that particular region, right? That is the only reason why we did not want to complicate it too much by bringing in too many geospatial data points. We just wanted to see this is what we want because of the intervention. Are we getting this, right? The econometric tool that we use is called DID, difference in difference. What DID does is, it tries to compensate for small variation and differences between 2 entities. 2 entities can be control watershed and a reward watershed. It can be reward watershed and a PMKSY watershed. They are not in the same place. So there might be small differences, but the small differences would be across the time period, right? It would not be a difference that would have suddenly come up. So DID accounts for that. DID also checks to see, because of the intervention, is there any change, right? And we can use econometrics DID tool to discern a minute change and with what percentage of accuracy can we attest to this particular intervention, right? This is the formula that goes with the DID. I will not go too much into it. This is a standard formula. We also took it from Google only, right? But this is what DID basically does. But one thing to understand is, when I am comparing two things, are they moving in a similar trend? Are they having similar rainfall? Were their vegetation and other indices similar before the intervention, right? If they are completely two different things like apples and oranges, then DID cannot be used, okay? So what we try to do is, we try to take the variables first and see across the time period, are they both similar to each other? Like I am showing here, this is sample of few of the variables. They basically track each other from the watersheds that we are considering as like they are mirror images of each other, right? So this is called parallel trend assumption in econometrics. This says I can use DID properly and I can justifiably use it for these watersheds to compare them, right? Now, what is the control area that I have taken for this particular study? This dark green is my treatment area, lighter green is my 3 kilometer radius around the treatment area, right? And the orange belt is the 5 kilometer radius around the treatment area. Now, why am I doing this? Because one, we got it referenced by other people who have done similar study and has been accepted, first of all. And second, what is the logic behind such studies? One is, the area is assumed to come under similar agroclimatic zone and agroecological zones. How do I know this? Because Government of India has also published agroeconomical zones for different watersheds, right? And these are the studies that were done by World Bank in Ethiopia, and the results were pretty good. Pretty good as in, whether the outcome was good or not, that's not what I am pointing at. The results were pretty strong in terms of they were scientifically holdable. That is the reason why we have taken this particular method to take up the control areas for my study. So these are the two watersheds that I was considering, and these are the results that I am getting. What are the results? What do the results say? One, you might see that there is too many zeros after the decimal. The reason being, the intervention time period for this watershed has not even been like, it has not crossed even 4 seasons. It has not even been 1.5 years, right? But across both the vegetative indices and the water indices, I see that there is an improvement when compare it to the control areas. There is some discernible changes, and I can say it with 99% accuracy that there is some discernible changes between the control areas as well as the treatment areas, okay? This was the study at 3 kilometer radius that I had done. Now, how do I know whether this particular control area that I had taken was sufficient? Is my data robust enough? Does it stand when I expand the area? We did the same thing for 5 kilometer buffer zone. We expanded the control area, right? And we saw whether my data still holds good, and it does hold good. In the same agroclimatic zone, in the similar ecological zone, agroecological zones, my data still holds good when I am comparing between the control and the or treatment areas, right? The study basically, our findings was that the water availability at the surface level as well as the vegetative indices obtained by satellite images show that they have improved. And by the way, the improvement that we see here, sorry, yeah, the improvements that we see here are generally the improvements that are seen in watershed intervention for after their intervention has been done over at least 2 to 3 years period of time. And that is not the period gap that we have right now, right? Reward in both of these watersheds that we are considering, reward project is still ongoing. We have not completed. So the results are pretty positive when we compare it with the other research done with similar methodology across the globe. This shows us the area under consideration. The subwatershed area is around 5 to 7,000 square hectares. Hectares. Control area, because the radius around the watershed that we are taking, control area is multiple times more than that, right? So this is a brief of the watersheds that we are considering. Now, the curiosity study that we were doing, which was comparison between the reward and the PMKSY watershed. Here we find some really interesting stuff and I have justifications for them. So what we find in the study is that compared to PMKSY, reward watershed, which is Maidal Kere, does not perform so well when it comes to surface water indices. But when it comes to vegetation indices, it performs better compared to the PMKSY watershed. Okay? Remember, all the data that we are taking, it is not about whether everything in the world has improved or not. It is a comparative study always, right? So, and we came back to WDD and we were like, what happened, why this happened, sir, it is not coming good and all of that. And they said, the watershed that we have taken, less than 30% of the projects were completed in that area and it is still ongoing. Whereas the watershed that we had taken for PMKSY, all the physical assets have already been created and they are already in place. So what we do need to get a better understanding and to get a better proof of concept, like somebody was asking in the morning, is there a way to do impact evaluation using GIS, purely GIS? Yes, we can do it. We have done it. Only if we have good computation power, we can do it. This is a proof of concept. And for a better study on PMKSY versus reward, we would need a little bit more time, which would be at least about 1 year time period post the intervention, post the physical asset creation. So this was our study, and these were our limitations and the conclusions that I already gave. Any questions? This was
thank
my
you very
presentation.
much.
Yes, sir.
Now it's open to the floor. Anyone has any questions, please address them. Yes, go ahead, please. Anybody else, please put up your hand so we can take the questions at one time.
Have you done the accuracy assessment?
Accuracy assessment?
Yeah.
Yes, we have.
Or what was the sample size?
Sample size was, like I mentioned, this was my sample size because I did not do sampling at all.
And what was the
7.28 million data points, that is my population size and that is my sample size.
Okay, okay. And what was the accuracy?
Accuracy was 99%.
Okay.
Like you can see.
Is it possible at
Yes, yes.
99% is?
So on Stata, when we run the t-test and the coding, so it does give us the p-values.
Okay.
Right? And it does show us at what accuracy and so everything is basically a hypothesis testing. Whether what I am thinking is right or whether it is wrong. And I put some percentage for it, right? Okay. And all my data does give the 99% accuracy in terms of p-values. Right?
Interesting. Thank you.
Thank you. Very nice study. I want to ask, as you took this 2 kilometer and 3 kilometer buffer as your control sample, so when you are comparing, in watershed management, we go from upland to downstream, like from upland side to downstream side. So when you do some intervention on the upstream, there will be some impact, like positive or negative, will happen on the downstream side. So while comparing, do you consider those aspects? Because when have water plant stream, then the water availability, not necessarily that it impacts the agriculture, but water availability may be decrease sometime. So using those temperatures, the indicator will show that water is reducing, not necessarily for agriculture. So those considerations are considered in this study.
So what we have done is robustness check, where we increase the radius of the control area from 3 km to 5 km. The reason being, like you might have seen some of the material that was shared on the screen by WDD. Generally, a sub-watershed area is 5,000 hectare and micro-watershed areas are around 500 to 1,000 hectare. That was one of the material that was continuously being run by WDD in this conference, right? And when we consider 5 km radius, these sub-watershed, both uphill as well as the valley regions, they are covered under that area, generally for the neighboring watersheds that are around my intervention watershed. And second thing, no, we have not done comparative study in terms of hill to hill, valley to valley. We have not done that. We have done it based on my micro watershed and the entire area around it. That is how we have done. Maybe that is something that we need to pick up. In reward, there are 20 intervention watershed and there are 20 control watershed. That is something again we want to pick up, where we, but there are not enough material to say that is the way to go. That is the reason for this particular study we did this, right? Again, this was a study that was published in 2020 and the study done in Ethiopia by Dr. Claus and Daniel Ali, right? It was their paper and they are still the leading economists and consultants for this reward project. So we referenced and we saw what other projects were studied this way, and that is why we picked up this methodology. But watershed to watershed, hill to hill, valley to valley is something that we need to do.
Okay.
Thank you.
Thank you. One query from my side, please.
Okay, go ahead.
Chair. Hello, I am speaking from here.
Sorry.
This exercise that you have taken up, this is very, very important for us to understand. Because we have to take a call what way the reward project is to proceed, or maybe to, or whatever decision government would like to take. So we want to understand, in your experiment, what were the parameters you have taken, and can we list those parameters, juxtaposed WDC 2.0 and reward, exactly parameters where maybe plus or minus whatever you have observed. So can you make a remark on that?
Yes, sir. So these are the only 4 parameters that we considered, right? Water indices, 2 of them we considered, and one was in general water index and other was where I consider for green cover and all of that. Similar to the vegetative index, right? Soil adjusted vegetative index, normalized vegetative index and things like that. So I only went with 2 major categories, moisture and vegetation, and these are the variables that are in 99% of the geospatial studies considered when it comes to like biophysical parameters, sir.
Elaborate a bit. Number one. Number two, do you feel that the 4 years period of implementation of reward is not sufficient period to assess the outcomes? Do you feel so?
Sir, so that is another study that we did. We took up Sujala watersheds, right? And we saw that if I need to look at the groundwater table, that is something that is ground truth, right? Data is collected from the ground. You can see any visible changes only after 2 monsoons, right? But GIS, I am only looking at the surface level changes, where I am looking at whether there is higher green cover, whether the soil moisture is more, right? And these are some things that we expect to change relatively immediately and in a shorter period of time frame. And another major limitation we had was lot of reward watersheds, the projects are still undergoing, right? The Maidalkere watershed that we took, if you look at this, there is a cut here. The reason being that is the watershed where PMKSY project is being run, right? And intervention, that is the again PMKSY watershed that I have taken for my study. And all the physical assets for the PMKSY were already built, right? So the comparison was not completely equal in terms of that, but with a little bit of more maturity, I'll be able to actually understand how the project is faring.
Thank you.
Okay, thank you very much, Vivek.
Thank you, sir.
Thank you, sir. Thank you for sharing your insight on this particular session. Now I request Dr. N.D. Prakash sir to give away the token of appreciation to the speaker. So Dr. N.D. Prakash sir, kindly give away the token of appreciation to the speaker. Dr. Vivek Madano, Research Manager, IRMA, Anand, Gujarat. Ladies and gentlemen, I would like to introduce our next speaker, Mr. David Hogg, the Chief Regenerative Agriculture Advisor at the Nandi Foundation, Hyderabad, one of India's foremost leaders in sustainable farming systems, soil regeneration, and community-based ecological agriculture. Sri Hogg is internationally respected for his pioneering work in regenerative agriculture, soil health restoration, and agroecological transformation. Working closely with indigenous communities, his efforts in Araku, a hilly region in the eastern Ghats of Andhra Pradesh, coffee cultivation has not only been an economic driver but also improved soil fertility. With over 4 decades of experience in India, he has dedicated his life to helping farmers adopt practices that rebuild soil fertility, enhance biodiversity, conserve water, and improve long-term farm resilience. Sir, I request you to address the gathering, sir.
This is forward and this is back.
Yeah.
Okay.
Sir.
Yeah, thank you.
Dr. Lobo, respected participants in this wonderful Watershed conference, happy to have been able to share a lot of the information that I've gained over the last 55 years in India, but also it's so nice to see that there's so much information now being collected for us to understand how to manage our watersheds and ensure that farmers and communities prosper as a result of that. Today, I'm going to share something quite different from what we've been seeing. These technical sessions have been a lot on data management, data collection, how to do satellite mapping and whatnot. So I'm going to share something, an experience that I've had over the last 20 years working with a tribal community in Araku. For foreign guests, Araku is it's a tribal region, a designated tribal region in the northeast of Andhra Pradesh. It's a hilly region, altitude around 3,000 feet to 4,200 feet. It's the home to traditional tribal groups, approximately about 750,000. And I came there 20 years ago to share some expertise I have on coffee, because I'd been working in the Palani Hills for 30 years, developing sustainable coffee protocols. Worked with the Coffee Board a lot as an advisor, and as a result of that, created some was able to develop and got challenged to develop a lot of great Indian coffees. We have some wonderful Arabica coffees that unfortunately go out into the world as commodities, bought up by the Italians, and then they sell it back to us as illy coffee at a very high price. And they call it Italian coffee. So that raised my angst, and I developed these coffees because I felt that coffee was a wonderful product like tea in the watersheds, that if it was done sustainably, it would ensure that water flowed unpolluted, that we would stabilize our watersheds. And for that, we had to take on board small farmers, because 85 to 87% of all coffee growers in India are small coffee growers with less than 2 hectares of land. So that's one of the figures that most people get a bit surprised at. They hear about Tata Coffee, they hear about all the other big estates, but they don't know that 87% of farmers have less than 2 hectares of coffee. So when I came to the Palanis, it wasn't like this. This is a recent photo. This is a photo of Mushrigondaguda. It's an elevation of around 3,600 to 4,200 feet. The hills you see there are now fully clothed with shade for the coffee. In the lower reaches you have agroforestry, and then of course down on the plains you have the paddy. So I'm showing this in the beginning for you to understand that we're talking about an ecosystem of many different agri-landscapes which we can develop in these tribal regions to ensure that the farmers get prosperous. So this is about how do we create community capital? How do we get communities to come together to share their resources, develop their resources, and get expertise in cropping in a sustainable way? When we first came 25 years ago, it was a dire situation. There was a Naxal uprising, Naxals being the Maoist rebels, as most of you will know. There was a lot of violence. All of the government offices, and particularly the Forest Department, was targeted. So it was a rather dangerous place to work. Fortunately, our friends, the Maoists, they left us alone as an NGO because we didn't associate with government, and we couldn't associate with government. And unfortunately, also a lot of the government services couldn't reach the far reaches of these tribal communities, these small villages, simply because of the threat from the Maoists, the Naxalites. So there was a very high mother-child mortality rates. There was no schools. There were no girls going to school. And so we set about, Nandi Foundation made a pact with the community to say, look, let's explore development together. We'll exit when you're fully developed. And I haven't yet found a community that's been fully developed, so we're still there. We worked with a pediatric hospital in Hyderabad, and they started training midwives in all the villages to resolve some of the problems of the mother-child mortality. We arranged ambulances for emergencies for these situations. A lot of the problems were to do with malnutrition, anemia, the usual things in the rural areas that now the government is addressing. We worked assiduously, working on street theater, bringing in importance of nutrition, importance of sanitation, and also when the farmers came back to us, they said, look, if you want our girls to go to school, we don't have a problem with that, but we need cash. They were living in a subsistence level, and they were bartering for whatever they needed. Even a kilo of salt they had to barter rice for. So we said, okay, there is, the British had introduced coffee with the Forest Department. Shall we explore the idea of growing coffee? It was a perfect coffee zone. The temperatures were right. So we began, the government had already initiated some work. We took up that work, and we started training these farmers who didn't understand coffee, didn't understand what was needed, didn't understand that it needed to be pruned, that we had to create coffee bushes, we needed shade, but most of all, we needed good soil. So we started programs, training for good soil programs, creating coffee landscapes, and also at the same time making sure that the landscapes, the steep landscapes where the coffee was growing around the parameters of the village were all ensured that we had terracing and that we had very little erosion. So this is typical of the farmer field schools that we developed. In the early days, we had no woman would come forward for this. Today, we have 50% of our workforce in the villages is women helping us with the training. They are the best students, to tell you the truth. And we started creating these landscapes of coffee. We overlaid it with, in all of the shade trees with pepper. So you had a double income. And so from averaging an income 20 years ago of around 5,000 per acre, now many of the farmers are more than 1 lakh an acre for 1 acre. Many of them are reaching as high as 3 lakhs an acre from their pepper and their coffee. We wanted to democratize the knowledge of how to improve the soils, how to bring in the carbon element into the soil, because this was all rain-fed. There's no irrigation in the coffee here. So we had to ensure that we sequestered the water. And the only way to sequester the water was to sequester carbon. And by sequestering carbon, as we all know, 1 gram of carbon can hold 8 times its weight in water. So unfortunately, there was a lot of degraded land. So we had to start addressing that problem by bringing in situ composting, mulching, and setting up compost units to be able to start resurrecting the soils, getting the microbial levels up. But for that, we needed the carbon. And from around about an average of about 0.4 to 0.5% organic carbon in the soils, we now are reaching carbon levels of about 2.7 to 3% organic carbon. As a result of that, the microbial content is coming up, and as a result of that, the coffee quality is improving. Here's we have 3 large composting units. India is blessed with so much biomass which is wasted every year. It breaks my heart. We have so much biomass, it's wasted, it's carbonized in the summer. We don't put it back in the ground. We see that with the crop stubble in the Punjab. There is no value for the carbon, unfortunately, and that's a result of misplaced ideas in our modern agriculture that carbon is not important. But carbon is the crucial element. And I was so happy to see that one of our Indian friends, Professor Ratanlal, who went from Andhra Pradesh to America, he worked on carbon, the importance of carbon, and he got the World Food Prize in 2020. And that triggered the whole understanding that carbon is important. So as you can see, we inoculate our heaps with a lot of mycorrhizal fungi, a lot of beneficial azobacters, rhizobacters, so that when the compost goes out, it becomes a kind of a nurturing element in the root zone of the coffee. We have biofertilizers which we produce in situ, so there's no external inputs. We took our Prime Minister's injunction seriously, make in India. We make in India all of our fertilizers, but we make it in the soil where the plants are. And I think that's a good thing that we can take up in our agriculture in order to be able to create more prosperity and secure our watersheds. Here's typical farms. The surrounding hills are now clothed in very rich, biodiverse, what I would call food forests. We inoculate the soils 4 times a year with beneficial bacteria and fungi. And we also do a lot of evidence-based testing on the way. We have an MOU with ECRSAT. We have done around 14,000 baseline samplings of our soil to ensure that we're going in the right direction regarding mycorrhiza and bacterial inputs. We work well with chromatograms. You can see the control plot that hasn't had any treatment compared to the regenerative, and these are the kind of samples we get here. Regenerative, the organic carbon gone up to 2.73 for this plot in the space of around 4 years. So these are some of the results you can get if you work with the community, make everybody understand how important putting the biomass back in the soil is. We bring in, as a result of that, we got the community was encouraged that all their spare land that they had, and there's quite a lot of land that they'd taken from the forest department, which we managed to get putters for. So they're secure in their land titles. So they go ahead and now they're very keen to grow trees, indigenous timber trees, jamun, a lot of the wonderful terminalias that we have, but also fruit trees. We have a lot of, we're experimenting with mangoes, of course, chiku, and it's a perfect place for growing a lot of the citrus. So they're getting incomes from that, they're getting incomes from the coffee, and they're beginning to discover what prosperity could mean for them. Here's a typical rich, you see the rajma growing in there, we've got bananas coming up. There's a whole plethora of biodiversity. Because we have a lot of light, we're blessed in this subtropical zone. We have so much light, we can grow so many crops in 1 acre. The vegetable plots in some of the villages, they will grow like 5, 6, 7, 8 crops, and every one of them will produce. Some are for the market, some are for the home consumption. When it came to the coffee, as you can see, it was a rather meandering thing. We explored how do we produce a quality coffee, one that could stand alone in the international market. So we began by developing our microbiomes of our soils. We started putting in terroir practices. We got experts from the wine industry in France to come, got to understand how to measure terroirs in terms of altitude, exposition, and training farmers on how to do that. We developed a cooperative in 2007. That cooperative now has 38,000 members. It's organically certified, fair trade certified, and we get a lot of value addition as a result of that. We had to attract buyers, international buyers who were inspired by the story, but more than anything, inspired by the taste. And as the soils got better, the specialty coffee tasting experts began to say, hey, your coffee's taking off. And suddenly from an average coffee of around 78 on the specialty range, 78 out of 100, we started getting into the 80s, and now we're striking we get scores of 91, which is really high on the specialty range. And as a result of that, it could stand alone in the international market. We could attract much higher prices. We could afford to pay much more to the community. And as a result of that, we had productized our coffee. We no longer had to look at Brazil and pray for frosts or floods. We could just name our price in terms of our coffee. And as a result of that, we ended up at the other end, global distribution. Surprisingly, one of the nations that was most interested was South Korea. The great coffee lovers. South Korea and Japan take up probably about 2/3 of our coffee, and they buy it by the container load now.
David, 5 minutes, huh?
5 minutes. Now, when you look at this, the water conservation departments over the years have done great things with trenching, with the Narega funds and whatnot. We needed to overlay that with farmers maintaining it and taking advantage of it. Many of these landscapes were so degraded, they were nothing but rocks. But what we discovered that those rocky lands happened to be the best coffee growing areas. There was good drainage. Coffee doesn't like to have its feet wet. So it was a perfect sort of area, a perfect terroir to be able to develop. It was a wasteland, but we could turn it into a very productive land. So you can see here, farmers went assiduously about creating terraces. They're still growing. This was a recent picture I took of farmers working on dry stone stacking, which is an art in the West. It's certainly an art and article. It's amazing how skillful they are in creating these landscapes. Here's a trenching. I took it recently in the end of October. There was a heavy rain. We got in about 2 hours. We got about 1 centimeter of rain. And not a single drop of water ran out of the coffee estate. It collected in these trenches. That was the most. That was the only sort of surface water I ever saw. Otherwise, it got percolated into the soil carbon and got trapped there and became available for the plants. Then we got into mapping. We had to map everything. We had to know. There was a wonderful talk this morning where you have to measure in order to manage. So we had to measure what we had. How much land did we have? What can we expect in terms of yield? So we started measuring. We started training all of the farmers' sons in technology and be able to do all the geo mapping. This is a village, Gondivalsava. As you can see, it's a vast area of plots, polygons there. And then overlaying that, it wasn't just data collection, but it was overlaying each one of these polygons, sending everyone out to do these landscape mapping to understand, is the coffee healthy? Is more gap filling needed? What's the shade like? So you can see all of the things that we had to do. We had to understand what the soil colors were like, how is the shade, whether the coverage is scarce, incomplete, and then whether the coffee bushes were designated healthy or unhealthy, and what is the range in between. So we had a massive amount of data. And as a result of that, over the years, this is a recent map of all these dots. You can see these colored dots are all polygons. From the 8 mandals that we work in, we have these different agroforestries, coffee, fodder, paddy, and then of course the pulses and millets. So all of this we have data on. We have, each farmer has a farmer family, because we only work with farmer families. We have all the data on when did they plant what, when can we expect the yield, and we have a guaranteed buyback system, not just for coffee, but also for the millets and the rajma. Expertise. Brix meters for testing to see when our coffee is getting sweeter. The cherry, every coffee is tested for its quality as it comes in. One of the most revolutionary things we brought in, which is so simple, a digital scale. The traders and the money lenders were there with their weighing scale, you know, with what I call the thumb rule, where you can manipulate it to just about any weight you want. We brought in and we got government stamped digital scales so that the farmers could see down to the last gram how much coffee was there, how much turmeric was there, how much millets were there. And that made a revolutionary development in terms of trust, because then they could see with their own eyes how much it was, and they didn't have to rely on traders and moneylenders who were looking after their own interests.
1 minute, David.
Just finished now. So expertise, we centralized all the processing, which is another revolutionary thing. Normally each farmer does his own processing, normally quite badly, not dried properly. We brought in expertise for that. We got angel investors to invest in go-downs and proper processing equipment, central processing equipment, We got trucks to collect the cherry from the villages and deliver it to the central processing unit. And as a result of that, we were able to treat all the wastewater according to the Pollution Control Board standards so that there was no pollution come out of this. Established good go-downs, aerated go-downs for storage of the coffee. The Max Cooperative, we have Max members. It's a democratically elected federated farmers over 8 mandals. And these are some of the office bearers here, with the president, secretary, treasurer. And radical inclusion was one of the main things. We wanted to celebrate coffee. We wanted to celebrate farmers. And so every year we organized these melas to celebrate the coffee, to celebrate how, and this was a gathering of 10,000 farmers all celebrating the fact that they had a good year harvest, that they got money from their coffee, finally they were making a profit, and they had money to invest in housing, children's education, and most particularly women with their gold. We organize competitions, monthly assessments for all of the Best Farmers Awards, Best Village Awards in terms of hygiene, in terms of techniques of mulching, in situ mulching, understanding how to prune coffee and all of that. And this was a wonderful time, a gathering in which everyone had a great time. Just one thing that I wanted to say, one of the surprising things for us, and I'll just take 1 minute extra, Dr. Lobo. We introduced some volleyball nets just as a bit of a lark, and we distributed 10, and suddenly there was a request for 10 more, and then 10 more, and today we have 900 volleyball teams throughout these 1,200 villages. It took us around 6 to 7 years to get 2 teams of women. Now we have 40 teams, and every year we have a round robin which takes 3 months to get round in order to be able to get to the finals. So this is the final, this is the awards. There's awards for everything. In the background you can see a hill which looks pretty bare. It's only because it's just nothing but rock outcrop. I just wanted to tell you that. We haven't forgotten to treat that, but it's nothing but hard rock grazing for animals when the grass is green. Then we had to productize our coffee. And this was a result of a lot of hard work, teaming with specialty coffee people from all over the world, from Korea, particularly from Germany, Norway. And they used to come on invitation. They would pay their own way with the rights to be able to buy the coffee, have the first rights to the coffee. We developed, as a result of that, we developed cafes because we wanted to go the extra mile in terms of retail, because that's where we could monetize in order to pay more for the coffee. And so we have tonight actually we're opening a second cafe in Bangalore. We have one that's been running, Araku Cafe. Do come to it. It's in 12th Main. You can get organic food there. You can get really great coffee. And we're also opened in Paris, 2016, I think it was. We have three cafes now in Paris and one in Bombay. Opening in 2026, one in New York. So as you can see, good things come over coffee. Just wanted to say that this is the mantra for our regenerative agriculture. And I think we are all consumers of food. So I have this question that I always like to, wherever I go, I want to say, when I'm buying a food, did the farmer make a profit when he sold this food? So our first mantra is profit. Did the farmer make a profit? It's the onus is on us to make sure that no farmer sells at a loss. And I think that's important. It's a government obligation. It's also a private, it's each citizen obligation. Don't crimp on buying quality food and ask whether or not the farmer made a profit. Because when he makes a profit, you can be assured of quality. And if you're doing it, it will regenerate. It will ensure that all of those watersheds will be secured because you overlay it with a quality vegetation, ensuring farmers are looking after their plant and machinery as any industrialist would. Because he knows, the industrialist knows he's got depreciation going on. The farmer knows that. He's got to reinvest money back in terms of carbon, in terms of microbial life.
Okay, David.
Done. Just finished this one. We got an award from Rockefeller. We had peer review of our methodologies, and we got a nice sum to be able to plow back into the coffee development. Rockefeller Food Prize System. And diversity. I'll just go through quickly. You can see the streams that were once seasonal are starting to revive now as a result of more than 50 million trees planted in these watersheds. Diversity is thy name. They love diversity. Beautiful Rajmas. Every village has at least 30 or 40 different crops that they can go to if the price is right in the market from the previous season's information. And then they start getting prosperous. They can look after their homes. They can redo their homes and start discovering what prosperity is. That's a typical landscape. It's assured. There's not going to be any soil erosion. It can withstand heavy monsoons. And just to swing through that, we're sequestering at minimum 400,000 tons of carbon annually in this region, 50 million trees, and still planting every year, an average of around 3.5 million trees we plant with the farmers. They always find land and put on which to plant trees. This is the landscape, just to wrap up. This is the kind of landscape we have. We've got so much more to do. You can see many of those hills that need to be clothed again. We are halfway, we're 1,200 out of about 2,200 villages. We're at the 1,200 villages that we're looking after now. Lovely little village down below there, nestled there with a good water supply now, and ample land to develop. Just to end, this was a photo I just took on, I was coming down the hill. Nice steep land, secured with good vegetation, and then suddenly out of that, the late monsoon rain came a rainbow. And I just thought, we've got the pot of gold, the abiotic and the biotic above ground work that we have to do on Watershed. I think of the pot of gold at the other side is what we do below the ground. Reinforce our soils with soil carbon, get it beyond 1%, ideally 2%, then we'll have a microbial life that will generate phosphate solubilizing bacteria, iron solubilizing bacteria, all those things that we need in order to be able to make in India, make in the soil, and ensure that our food crops are nutritious, that we grow back our iron into our crops, into our seeds, so that we no longer have those deficiencies which have plagued us in the last 25, 30, 50 years.
So thank you, David. Thank you. So if you have any questions, I would suggest that you keep them because we really run out of time. We'll continue with the next, and then when we are finished, we could ask this question. Would that be okay?
Happy to answer any questions offline as well.
Right. Thank you.
Okay.
Thank you so much, Mr. David Hogg, for your wonderful illustrious presentation. In fact, your thoughtful discussions have shown that building watershed resilience is not merely a technical task, rather it's a shared responsibility. One eye-opening fact was that, more interestingly, an artistic way of growing coffee, especially on the rocky soil. Thank you so much once again. I would request Director Watershed Development Department, Mohammad Parvez Bantral sir, to present him a token of respect, sir, please. I expect a big round of applause from the audience again. There is just for the chairman, sir, please. There is just a minor change. The next presenter will be Dr. N.G. Patil, Director, NBSS and LUP Nagpur. So he'll be presenting on scaling up of LRI at national level and its challenges. Just to give a brief introduction about Dr. N.G. Patil. Ladies and gentlemen, Dr. N.G. Patil, the Director of ICR, National Bureau of Soil Survey and Land Use Planning, Nagpur, India's premier national institution for soil resource mapping, land evaluation and agroecological planning. With an illustrious career spanning several decades, Dr. Patil is one of the India's most expert in soil survey, land resource inventory, pedology, digital soil mapping and land use planning. So the podium is over to you, sir, now, please.
Can you change the PPT, please? Good evening, ladies and gentlemen. Thanks to the organizers for having me here. Now, I'm supposed to speak on this topic, that scaling up of LRI at national level. So I begin with the premise that everybody agrees that LRI is a base for any watershed development, and I need not convince anybody for that. So what are the challenges that we are facing? Currently, DOLR is thinking of PMKSY 3 or WDC 3, right? And then there are so many other stakeholders, right from forest managers, livestock managers, and even fish department and industry like laying internet cables, laying railway lines. Those are all interested in soil survey data or LRI data. So is there a comprehensive database in the country? And if it is there, how much of that part database is operational? That is the question we are trying to address. So we have been, as Dr. Obi Reddy mentioned in the morning, that we have been tasked with this soil theme under National Geospatial Policy 22, and we are supposed to serve the nation irrespective of the stakeholder, and we are serving as a repository of the soil information in the country. Now, what are the soil database that are available in the country right now? One is with us, that is National Bureau of Soil Survey and Land Use Planning. The another organization is Soil and Land Use Survey of India. Together, as on today, the two organizations have covered 60 million hectare area of the country. That is roughly more than 1/3 of the cultivated area. Then there are some state soil departments. Not each federal state has such a department, but few of the states in India have. Then there are state agriculture universities who have collected a lot of data. Then there is irrigation departments, state agriculture departments, and so on. So these are the major sources of soil data in the country. The trouble is the data are not brought at single unified platform so that it could be served to the stakeholders. So what do we need to do to create a national soil information system? The first obvious thing that comes to anybody's mind is convergence of database. Then once you have converged all the database data that are available in the country, obviously you would need to find out what are the gaps, what are the windows where there is no data, or what are the soil data poor states in the country. Obviously there are some states like Karnataka, Maharashtra, and some other, to name a few, like Kerala as well. They have a good amount of soil data collected over the last 4 or 5 decades, and the need is not so acutely felt in those states, but there are some states which are completely lacking. Then what do you do with the data? Once you have put all the data in a single platform and identified the data gaps, obviously you would like to fill up those gaps. Obviously you need to do collect some soil data from the blank areas or where we are lacking the soil data. Now the question is, are we willing to invest in fresh soil surveys? Now if you look at the global agencies or the other countries, nobody is currently active in soil survey. Most of the countries have moved on to the digital soil mapping or predictive soil mapping, and precisely that is what we are doing right now. As Dr. Reddy talked about in the morning, that we have developed a hybrid method wherein we try to collect any state agency that approaches us for either for reward, either for PMKSY or other forest management, whatever problem they come up with, we try to collect the available data. Then we do some digital soil mapping or predictive mapping, but then we validate it and hand over the data to the user agency for transforming it into knowledge, or depending on the objective, probably we help them in drawing inference from the data, soil data as well. So what are the challenges that the nation or India is currently facing? So as I told you, there are different data sources, disparate agencies engaged in different domains. So they don't have a common uniform protocol in collecting soil data. That is one thing. Second thing is, there are NGOs, they keep on working. To be honest, I think the millions of data are collected every year. Even agriculture department is collecting 50,000 plus soil samples every year, each and every state, I believe. And they are collecting soil samples from, of course, surface soil samples, analyzing it, but none of the state as of now is georeferencing it to draw some spatial pattern or some regional patterns of developing deficiencies or a pattern of say excess nutrient, whatever. So to make the sense, all the data need to be georeferenced, that need to be brought together. So there are 63 state agriculture universities in India. Each university is also collecting lot of soil data. Again, the same problem, it is not georeferenced. Then there are central agriculture universities, 3, and these are the broad contours. I mean, I am not, it's not illustrative. There are so many other agencies also involved in soil sampling and soil testing. So the troubles or the questions I am facing is, different protocols followed, the data are skewed or scattered. Then there is always a question of quality and quantity of the data. What are the equipments used in collecting data? What are the methods that have been employed? And the time period. Some of the data were collected maybe some 30 years back, so they have lost relevance probably, especially in as far as chemical properties of the soils are concerned. But nevertheless, there are these are all valuable data points for me. Then there is always a problem of georeferencing, that recently all the departments, I am requesting wherever I go, whenever I am given a platform like this to speak, I request everybody, please whatever data you are collecting about your soils, please georeference it and share it with us. So the other problems are sampling techniques used by different agencies. Again, we need to have a national standard or at least a state standard wherein the same sampling technique is employed. There is lot of gap between the methods used by different agencies and the methods we recommend. Then there are of course data related problems that Dr. Reddy talked in the morning, database management and so many other things. So the other important problem that probably we need to understand is, or rather some of the researchers are there here, we are not very forthcoming when it comes to sharing the soil data. I repeatedly make a plea to all the university vice chancellors, directors, professors, researchers, academicians, that please do not hesitate to share the data with us. We are a national agency. We are responsible. We will give due credit to you whenever you share your data with us. Do not be apprehensive about it. Then when I request the universities or state departments to collect the data or at least put georeference on the sample collected, they say we do not know the method of georeferencing, that is a skill problem. Then some of them say that we have shortage of manpower, but I think these are the problems that could be overcome. Then the federal structure of the country is also in a way responsible, because we have different set of experts, so we vary in our sensitivities about this importance of using LRI data for different development schemes, including watershed management. So these are the challenges. Now what are the solutions? We need to find some solutions. One of them is, I am requesting each and every state agriculture university to develop its own soil information system. So ideally each university would have 7 to 8 districts under its jurisdiction, all the 63 state agriculture universities in the country. Now if the universities decide that each regional center or agriculture research station located in there could be 2 or 3 research centers in single district. So for me they are the big data sources. So if each soil science department or each university decide that all the soil samples collected, analyzed by them are put at a single platform through by creating a university soil information system. And when all these 63 universities join hands, it automatically becomes a soil information system at country level. So that is the proposition and that is the thought we are trying to spread across the country. Then we have some we have PG students everywhere, MSc or soil science and PhD soil science. Now if one of the students could be assigned to develop that university soil information to retrieve the data collected over last 4 or 5 decades, that will be a great service to the country. And it does not require a great time. Assign a PhD scholar, he will collect all the data that are lying in different research theses, georeference it. If the georeference is not available, at least name the village from where that data or that soil sample has been collected, and that way you are contributing to the national cause. Then we have developed some digital soil products for different states. Now we need to validate it. Now it's very simple. We have BSc AG students who are undergoing some 4 or 5 months RAWE program. You hand over the digital soil map prepared and ask him to validate it. It is very simple. So if all the universities in each of the state decide to do so, I think within a year we would have validated the digital soil map. Now another proposition or another solution is we have now almost each and every farmer has smartphone. Now if it is linked to his survey number and if I have done some digital predicted some soil property or some soil map, it is very easy for me to call him and check with him. Let us say I have predicted that your soil is 30 centimeter deep. I simply need to make a phone call to the farmer. Do you agree that it is 30 centimeter deep? If not, what is the depth? So that way we can do some crowdsourcing or some validation using cell numbers attached to each and every land parcel in the country. That is one of the quickest way to acquire or validate your soil data. The third solution I am offering here is many of the state agencies lack alertness or sensitivity of about the soil data, and most of them come to know about the LRI or land resource inventory only when I happen to visit or my head or my scientist happens to visit the state department, and they try to impress upon them that look, this LRI is a database that is pivotal or at the base of the pyramid, wherein you can go on adding one after other layers of information like land use, land cover, livestock, forest and so on and so forth. And once this everything is integrated, it becomes a wonderful decision support system. Now the thing is some states are very advanced. Some of the young collectors come to me, they say, look, I want to develop DSM for my own district. Can you help me in building? We are doing that. But this should not be an isolated effort confined to only few young collectors who realize the importance. It should be a national cause, or it should be taken up in national interest. So what I propose is at least DOLR can recommend, or state level nodal agencies can have at least one NBSS scientist on their executive committee, just to advise them how LRI could be leveraged not only for watershed management. Watershed management happens to be one of the applications. Believe me, there are n number of applications. I was so appreciative of this International Union of Soils Science. We organized an international workshop during January this year itself. And one of the South African delegate, he said, we are using these digital soil maps for arranging a path of wildlife safari. We don't want to disturb our flora and fauna, we don't want to disturb our animals, and at the same time, we want to give up close view to the tourist. So they are using very smartly. Then some of the power companies, somebody mentioned Adani in the morning, now solar power utilization and all that. Now Adani's interest is engineering properties of soils. What are the soils where I can have my solar plant? So can you help me where to locate my solar plant, or what are the soil properties that are that can help me in building a solar unit? So it depends, railway tracks, water conveyance line. So the corporate world has quickly realized the importance of using LRI for the development, but somehow we are lagging behind the farm sector, agriculture sector, wherein lies the most important application of soil data. So I make a plea or make a submission that there should be a scientist in the executive committee of SLNA who can explain, and not only explain, but he needs to impress upon the importance of having skills to use the soil data that are available, including GIS and modern tools. Then the last solution, the secretary ICR has already written to Chief Secretary of each federal state to mobilize data sharing, but as you know, it is always lost in the almiras or the files that we keep. So we have so far had success with only few nodal officers that have been nominated by different secretaries across India, but we are still awaiting many nominations. That nodal officer is supposed to collaborate with us, help us in building a national information system on soils. So I won't be talking about much about the work that we have done, but let me give you an example of how we work. This is, I think, Vidarbha, Vidarbha region of Maharashtra state. This covers roughly 9 million hectare area. And you can see the encircled part wherein we did not have any soil information. And some of the green points that you over here, we had some database. So we requested the local university to share their data, some data we had. So all the data that were available were put in at one place. Then we identified these windows wherein we did not have any information. And within 6 or 7 months, we could finish this job of covering almost 9 million hectare area. So this is the beauty of the hybrid approach that we have adopted. We are not departing from the traditional soil survey. At the same time, we are not completely going with digital soil mapping. It's a mix-up thing, or a hybrid approach. So that is what I propose, that during the next phase of PMKSY or the reward, whatever program that DOLR plans to implement, to make it, to explain it in a layman's language. Researchers, please excuse me for making it very simple, but for some of the unexposed person, let me start you with a simple geography. As we start from Himalayas up in the north and we go down to West Bengal, what happens is whatever sediments that are brought by the water through different river channels culminating into Ganges river system, the soil soils particles or sediments are deposited on the way to West Bengal, wherein in West Bengal you would find that the soils are as deep as maybe 10 meters, 15 meters, I don't know. But when it starts from Himalayas, the soil depth is hardly 30 centimeter. Now this same thing or the same concept is replicated in each and every stream, each and every water channel, whether it is peninsular India or whether it is North India. Now if this is roughly accepted, that means I should not be expecting very good soils over here at the top, right? And at the foot I would be expecting very deep, well nourished or good soils with good nutrition capacity. Now, if that is so, if I prepare a simple terrain map like Dr. Reddy presented in the morning for Maharashtra, I can do it for the entire country, I can do it for any watershed that you name. So I have prepared a 50% soil map just by delineating geographical units. And what I do is for the digital soil mapping or traditional soil survey, whatever I am doing would be adding to that 50%. So I start with the premise that I have prepared a base map, that means I have done LRI 50%. So if that is the approach, probably the problem I am facing with the administrators, secretaries, they approach me or the bureau in solving so many problems. Somebody comes to me and says, I want all the soil data within 24 hours. Can you serve me? Raitu Sudhar Kendra or Raitu Seva Kendra, RSK it is called probably in Telangana. So each one has its own set of problem and everybody is impatient. So the thing is, if we have a data rich state like Maharashtra, Karnataka or maybe Rajasthan, to some extent some part of Rajasthan we have covered, Arunachal entire state we have covered, and I can go on adding the list. The thing is, we have data rich countries, not so data rich states, and there is no state in India that has not been covered either by us or by Soil and Land Use Survey of India. So we need to understand that something is already available and all we need to do is build upon the available data sets.
Dr. Patel, 3 minutes more, please.
Yeah. I think I have finished. That is the thing, and these are the things that Dr. Reddy covered in the morning. So, only thing I would like to show here at the last is, this is land parcel advisory. Now, if what is new about this is, in Karnataka we have land parcel advisory. Obviously, so many years we have done it under Sujala, Reward and so on. But this advisory is based on digital soil map prepared for 5,000 villages in Maharashtra. So the point I am trying to tell here is, let us not wait for all the data, whatever data that are available with us, let us move ahead, go on doing something. If you come to me for a watershed development program, I will hand over some data within 3 months to you. And as you start implementing your drainage engineering development structures and so on, we will come out with some added value data, or the plan for crop management, nutrient management, then the contingency management and so on. So there are n number benefits to be had from the LRI, but let us not wait for the entire thing to be finished and then start implementing it. That is the message I want to give here. Thank you.
Thank you. Any questions for Dr. Patil? Yes, somebody raised his hand. You can start. Please articulate your question.
Oh, sorry, sir, I didn't hear. Acha, this any mandate is there to share the data from the government departments in the state?
Sorry, can you repeat?
Any mandate, Government of India mandate is there to all?
Yeah, it is there. And Director General Secretary DARE has already written to all chief secretaries twice or thrice, and I have been also writing to all the state agencies again and again.
Okay, if you can kindly share it, no? Maybe we can just take it forward.
Yes, please. Keep the mic there, please.
Thank you. Good presentation. My question is, different agencies, state government, agriculture universities, state government, then IC, sample and analyze. System. It is my suggestion to this August House and the chairman and the speaker and the director of NBSS and LUP to develop a SOP that one agency will be the custodian of all the analyzed results, so that it can be used very easily. Otherwise, AICRP are keeping its data as its own data, then NBSS LUP is keeping its data as its own data, and many times to share those data, other agencies are facing difficulty. And there should be SOP where to share and where not to share, but there should be authority for the all the analyzed soil data depository.
Yeah, I think that is already in place, and Dr. Reddy is responsible for the collection of data across the country, and he has already communicated that SOP to the, and it is also there on our website as well. So if need be, he can share it with you, no problem.
No, sir, my submission to this house, as well as the chairman and as the director of NBSS LUP, the speaker, that there should be development of a policy in the government level, so that all the agencies, those who are involved in soil analysis, suppose reward is analyzing LRI data, NBSS LUP is also analyzing. They are all utilizing the government property, government money, fund, developing data, but these data are remain in the sectorial. So it should be goes to a common agency, so that it can be utilized properly. So I am analyzing as a State Agriculture University, I am telling that it is my data, I may share, may not share. NBSS LUP is also telling it is my data, I may share, may not share. LRI reward is also analyzing data, they are in thousands and lakhs in number, but they remain separately.
Right, right.
That should be unified, so that it can be utilized. And you are telling we have 40,000 data, suppose like this. Every agency has in thousands and lakhs data, but they are in segregated manner.
Very true.
That should be unified and come under the control of one agency. And why not NBSS LUP in the national level?
Yeah. I think,
and take this opportunity
Dr. Patil,
to collect those data.
We've got the point. Thank you, and Dr. Patil has noted that. So thank you very much, Dr. Patil.
Thank you, Dr. N.G. Patil, sir, for sharing your valuable insights on how we need to scale up LRI at national level. And also you have mentioned the challenges and proposed probable solution for that. And thank you, sir. And also I thank the audience for the fruitful discussion. Now I am going to introduce our next speaker, Dr. J.V.R. Murthy. He is a consultant to the World Bank, known widely for his contributions to hydrology, watershed management, river basin planning and climate resilient water system across India and beyond. With over 3 decades of experience in water sector governance, irrigation modernization, hydroinformatics, environmental planning and climate risk assessment, Dr. Murthy has been at the forefront of guiding national and state governments in designing sustainable and science-based water management strategies. Sir, I request you to throw some light on emerging pathways for engaging local institutions for climate resilient watershed management. Sir, please.
Post-lunch, I have not received even one delicacy so far. I am expecting still, but just to wake you up, एक शायरी आपके नज़र में, तोड़ देना हर पिंजरा, तोड़ देना हर पिंजरा, अभी मेरी उड़ान बाकी है, मंजिले जमीन पर नहीं, आसमान अभी बाकी है, लहरों का थमना नहीं समंदर की बेबसी, बाहर तूफान, बाहर खामोशी, भीतर तूफान अभी बाकी है. This is one. दोस्ती, मैं लब ए शिकवा को सी लेता हूं, मैं लब ए शिकवा को सी लेता हूं, चंद घड़ियां हैं यूं ही जी लेता हूं, जिसे मानता हूं मैं दोस्ती का हाथ, उस हाथों उन्हीं हाथों से जहर भी पी लेता हूं. उन्हीं हाथों से जहर भी पी लेता हूँ. Thank you so much.
Only 2 operations. No? Good afternoon, ladies and gentlemen. My name is Murthy. I'm a freelancing consultant, mostly working with the World Bank projects. I've been working across all the water-related projects, water governance, rural drinking water, urban water supply, sanitation, watersheds, irrigation management. So I'm a master in none, and I know a little bit in many fields. So I'll try to be as brief as possible today. The topic is to see how do we engage communities. So I will not talk about LRI, hydrology or anything. We have been talking about it since yesterday. I'll try and analyze what is happening with the community engagement in the watershed space today and how can we improve it, bringing in lessons from what we are doing, what we have had in the last 2 days, but also in the other sectors. I'll try to be as brief as possible. So what do we have in India in terms of community engagement? So don't think about any science and technology, it's purely people, we, communities. We have a long history of community engagement, both in the watersheds programs and other programs, mainly all rural development programs. A lot of community engagement is there. India is strong decentralization governance structure up to Gram Panchayats and even subcommittees of Gram Panchayats. We have established local governments. Water and land management is a decentralized subject. In the 73rd Amendment, we have decentralized it. So panchayats and communities are free and they are responsible for managing it, of course with assistance from higher order organizations. We have also had large programs, not only in the sector but devolution programs, the finance commission programs, the state finance commission grants, etc., which is giving a lot of money, the devolution strength, resources, people, etc., to local governments and for community engagement. We also had programs from bilaterals, multilaterals across rural development, also in watersheds, focusing on community engagement. So a lot of community engagement models have come up from 80s or 90s, mostly from 90s. We have a lot of experts from those organizations in this room. So it's a lot of experimental learning that came up. We have several well-established civil society organizations, philanthropies, CSR organizations. Some of them have spoken in the afternoon session on private sector participation. Some of the large civil society organizations are in the room and we can hear more from them. But interestingly, we also have new age startups with technology that's coming in, the digital technology, not LRI and hydrology alone, who are using the internet and mobiles and whatnot to reach to communities, either as a collective or as individuals. Now, I want to clarify that community engagement doesn't necessarily mean we'll deal with groups. It could also include individuals. So, it's a good space to be in, right? I mean, nothing new for us in India about community engagement. I've also reviewed what does the Watershed Guidelines 2021 say, PMTSY WDC 2.0 on community engagement, and it's a very good situation to be in. So the word watershed committee came up 123 times. It's a 93-page document, so more than once in every page, which is a very excellent achievement. Community 76 times, almost once in every page. Gram Panchayat, women and SSG, FPOs. Nobody might think that FPOs would have had such an important role in the WDC 2.0 guidelines, once in every page. Farmers, of course, the main object, the main target. Landless, interestingly, NGO has come up only 5 times. There might be some other forms, but what I could get is that. So that's also a good space to be in. One would then expect that we have very good community engagement in the sector, right? We have very good enabling situation, long history, and good guidelines. But from my assessment or our assessment on what's happening on the ground, situation is not that good. So watershed committees are formed, but in most states they are not effective. Why? There could be other reasons. This is what we think are too small and isolated institutions. 10 members, 11 members, a lot of time goes in selecting those members, registering them, so on and so forth. They short period support. By the time they are formed and they start working, the project ends and we walk away. Watershed development department or the programs are very nomadic. I worked for 5 years, then I moved to another watershed area. So there's no permanency, and therefore the support to organizations is short term. They are not long lasting permanent institutions, the watershed development departments. At the field level, at the state level, district level, they may be. I'm not criticizing, I'm just trying to understand the causal relations. We only have a few good cases or models. I mean, any conference we go, we hear about those 5-10 villages that have done well and everybody wants to go there and learn. For the last 20 years is what I'm hearing. There aren't 100, 200, of course we have other models like what we heard about Araku today, but these are far and too small a number to expect in a country of this size, right? These are mostly led by civil society organizations or other support organizations or local organic leaders who have very strong vision and influence on their communities. And results are seen over a long period, 7 to 10 years plus. I mean, we heard Nandi Foundation saying we are still there. Our job is not yet achieved. 2 decades, I think, yeah, and maybe more, yeah. Same with other large civil society organizations. They spend a decade and more to build these committees and get these results. The results are what we heard about prosperity, about higher productivity, market linkages, incomes. These are the results. Of course, through watershed endowments, whether it's soil and soil improvements, quality improvements, water endowments, etc. They're not sustainable beyond a project because there's not much focus on maintenance. The focus moves away to the other watersheds. Value chain linkages, not everywhere. Very, very few cases that we are seeing. Weak convergence with other programs and funds. Though the guidelines say that at the field level there's only so much money in that time period that can be converged. Everybody wants convergence. WDF money is collected and is in bank accounts, but largely not used. That's what we saw in Karnataka and Odisha. We're trying to get more data on it. Are there incentives for the committees? Why should they do it? We all have incentives. I got a ticket to fly here, I got a hotel, I'm getting good food, and of course I'm getting pictures of me. So these are all incentives, right? What are the incentives for the committees? Nothing, or barely nothing. So maybe these are all some of the causes why the ground reality is not as good as it should have been given our enabling environment. What can be done? $1 million question. We keep debating, keep writing these in the guidelines, keep experimenting. So all that I want to say, we have been hearing, I think Dr. Asim said 5 R's. Dr. Reddy said 6 V's. So we are all using the alphabets and numbers. So I would suggest adopt a 3E framework for community engagement, stronger community engagement. Looks a bit academic, but I'll try and explain that. The first E is educate. Most of us know, relatively easy. Enable. We need to understand what does that mean. Empower. Slightly difficult to understand and achieve maybe. So I'll take you through the thoughts on these 3 and leave you with those 3 thoughts. This is not a prescription, this is a loud thinking to open up our thinking on how do we engage the communities more effectively to achieve the objectives, which is incomes, prosperity, sustainability, environmental protection, so on and so forth. What does educate mean? Most of us doing this year 1, but do it differently. So we are trying to reach out to communities with knowledge, not just to tell them what they should do, what should be the committee like, how many times they should meet, what records they should maintain. And these are all very prescriptive training programs we do to committees. If you ask me to sit in that, I'll be sleeping in most of them. So collate and share new knowledge that I don't have as a committee. As a farmer, I don't know what is LRI. Dr. Patil said some data is already there. It's not that I need to invent new data, wait for 10 years and grow. So take our whatever new data that the data that we have in forms of LRI charts, soil data, weather information, water balance estimates, very, very important for a knowledge piece, etc. I mean, these are just some of the examples, and explain how to use the same. These can be in cluster meetings, individual meetings, whether you want to reach digitally, farm field tools, choice is yours. Of course, we need additional workforce. For example, in Karnataka, they use LRI extension managers very, very effectively to reach out with LRI cards to 500,000 people, 5 lakh, 10 lakh farmers, I think you reached, and explain to them what it is. Everybody might not have understood, but even if 50%, 30% have understood what it is, excellent. 10% start adopting it, beautiful. That's the objective. It's not about how many committees, how many meetings, how many trainings. That's not community engagement. That's an old style. Let's think new, what can we do with so much knowledge that we have. Provide information on schemes, entitlement. This is like convergence at their level. It need not be only the PD should do the convergence. And the panchayats, the individuals, it can be private sector schemes, markets. How do they just give them knowledge that there is such a market available, such schemes available, would you like to access it? So that is education, the first E. I said that already, use traditional and digital means to maximize outreach. No need to only work with committees. What happens with committees, we are pre-selecting them. But here we are educating, it's like a classroom, we are teaching to 100 people. After 1 year, maybe 20 people might want to do more work. Select them for your committee. Don't pre-select based on whatever criteria. Then start forming watershed committees. I'll come to MSP later, multi-stakeholder platforms, other groups as required. These years are again very tentative. So if you take 6 months to 1 year for educating, then we are getting into the enabling mode. What does that mean? Guide the first batch, those interested. I said those 10% who raise their hands and say, hey, now I understood, I read this card, I want to do something, tell me how to do it. Right? That will be your first batch of leaders. And the word that we keep using in any natural, say water projects, is there are two sides to managing your environment, water environment. One is your supply side. So your engineering side, all busy building dams and check dams and nalas, etc., is one thing that you do as supply. You are increasing more water. But on the demand management, we all know why the problem started in the first place. They are felling trees, they are depleting the groundwater resources, using more and more water. So why don't we tell them to stop that or reduce that? We don't introduce the demand management aspects at all to these committees, or it comes in the 4th year. Because we are busy preparing our DPRs, getting technical sanction, administrative sanction, procurement, construction, so on and so forth. But he is sitting idle, the farmers. Start telling them to manage their own farm. Let them not even worry about the entire village. So the demand management is very, very important to bring in. Initiatives, they can do at their own thing, bunding, plantation, reduce water use efficiency, so on and so forth. All these contribute to your soil and water conservation. I have given some examples, micro irrigation, nutrient management, so on and so forth. So assist them and the committees in developing treatment plants in watershed area. We are coming to the DPRs now. I'm not saying it's not important, but there are other things that we can do parallelly or in advance. Then enable active interactions among MSP partners. So MSP is something we saw in the afternoon session led by Mr. Nitin. Public-private civil society partnerships. So at a district level, if you look at forming these multi-stakeholder platforms, All may work, may not work, but get together people, interested people, CSRs, philanthropies, private sector, markets, FPOs, farmers, committees, anybody who is active, SHGs, and say what do we want to do, what can we do, how can we help each other. No need to put any money to them. These are like a platform that we are creating to interact, exchange ideas, maybe exchange commodities and start trading or start building relations. If you do it at a village or a micro watershed might be too small a scale, but maybe a block level, district level, where it is headed by some senior government officer, but you call them and make them transparent and friendly environment. It's not to say how much money you will give me tomorrow. So those MSPs are important, and initiate some prior activities like market linkages, knowledge sharing, federations, etc. Also, I think we need to think about building these small institutions into bigger institutions for leveraging markets or leveraging convergence or leveraging more community participation. The federated structures, which we see in livelihood missions, we don't see in this place. We see some of them in the multi-village water supply schemes. We have examples where federations happen. At a village level, you have a water supply committee, but in a multi-village scheme, you have a multi-village water supply committee coming and managing things. Also, I wanted to add that in the demand management is not just about individual actions, but also community actions. So some of the case studies that we know, Hivre Bazaar, etc., I don't take other names. An important element is they have community regulations, rules that what to do, what not to do. It's by them. It's not imposed by a guideline. It's not imposed by a collector or a watershed department. What do we do with our water? How much farming do we do? What kind of crops do we take? What do we do with grazing? So on and so forth. So I think those committee rules are very important to put them together.
Dr. Murthy,
that's also a part of the demand management.
Dr. Murthy.
So these are all enabling.
4 minutes
yeah.
more.
One more slide. These are all enabling factors. Then empowerment. I mean, it's too complex terminology to define, but I think this is again an indicative steps to strengthen institutions and collaborations. The MSPs, even if 10 of them go forward, out of the 20 that you might do, today we have nil. No multi-stakeholder platform in the watershed sector. Whereas in the morning, in the afternoon we are talking, we need them. So use that, build those MSPs. We need the regular support from watershed departments for longer periods, maybe 7 years to 10 years plus. How to enable that is an institutional question that needs to be addressed. 5-year period is no longer useful. Of course, periodic monitoring, what we had from IRMA, do that monitoring and get back to them to say your things are improving or they are not improving. Why? So that's the knowledge that we give them back, but don't come back without that. Incentives and rewards. I think what we had in the Nandi case in Araku Valley, they are celebrating their prizes, their recognition, rewards. I think this is a very important element for any community engagement and participation. They said, what are my incentives? That's the first question that we raised. Keep them innovative, keep them regular. They have to be periodic, not once in 5 years, everybody will forget. And what we had from Ethiopia and other things is some kind of credits. Can we get water credits, carbon credits, or payment for environmental systems? There are new age instruments that are coming which can help the communities to increase their incomes on a regular basis. We need a policy or we need a piloting to understand how to enable these credits to come in. And that's the empowerment phase. So some of these we are doing, but in a very methodical manner. The advice or the loud thinking here is, can we disrupt that and start structuring in a different way with new knowledge, new financial instruments, new partners like multi-stakeholder platforms coming in and breaking our thinking on a linear planning, baseline data surveys, DPR, approval, implementation, and then a withdrawal. By that time, everybody is tired. So I'll stop here. Thank you for your active hearing and nodding the heads in between. After lunch and before tea time, I understand how difficult it is. Thank you very much.
Thank you, Dr. Murthy. Are there any questions?
Mr. Murthy, this committee is what you have mentioned, it is mandated in the Act or policy?
Sorry?
Watershed committees you are talking, right? Watershed committees. That is already mandated in the Act or policy?
It's mandated in the guidelines.
It's there in the guideline.
Yeah.
So that has to be implemented by the state government, right?
It's implemented, but they are not very effective.
Oh, okay. So what is the suggestion? How you can go about it?
Sorry?
You have any suggestions to how to improve?
That's what I said. Make it more knowledge-oriented, multi-stakeholder platforms, and long-term support for them to grow. And by the time they are active, the projects are withdrawing. It's a 5-year tenure, 6-year tenure. There's no support beyond the construction period, sort of. So a longer-term support, whether from the department or any other department, are the multi-stakeholder platforms. A private organization, CSR, civil society, anybody come in, and also recognition and awards will keep them more motivated.
Okay,
Thank you.
I think we are running short of time, so we won't take further questions. I would like to thank you, Dr. Murthy, and
Thank you very much, Dr. J.V.R. Murthy. We deeply appreciate your insightful and eloquent contribution. Your perspectives enriched today our participants, sir. May I now request Honorable Commissioner, Watershed Development Department, Shri Pratap Singh, sir, to present a token of appreciation. Ladies and gentlemen, now we have two plans. Plan A will be remain in the hall and have a small game. Plan B will go outside, have tea, and then come back within 5 minutes. Which one you like? B. Thank you. So we'll take a short break. 10 minutes time break, sir, please, because we are running short of time. We have valedictory session 2. Now it's 5:10 in my watch. I expect your kind presence by 5:20 in this hall. Thank you so much. Our next presentation will be on challenges in scaling agricultural technologies and determinants of adoption in smallholders system in Africa. That will be delivered by
Good evening, everyone. My name is Makwant Mallesa. I work with ICRISAT, the International Crops Research Institute for the Semi-Arid Tropics. I'm going to make a presentation slightly different from what we have heard over yesterday and today. Basically, we have seen quite a number of innovations being presented in different domains of watershed management, agricultural technologies. But now the next step is where we can really be sure the technology is ready for scaling. What is the decision criteria? What we need to take into account in this process? Basically, the most important element is going to be understanding readiness to scaling readiness. Scaling readiness basically means where the technology is ready for scaling. And often we depend our decision based on pilot testing. But of course, if we are going to engage into a serious business of scaling, we need to know more than really piloting the technology. So we will go through different considerations in the scaling process, but importantly, as you can see, my title says Scaling Agricultural Innovations in Smallholder Systems in Africa. Africa is really a very big geography, especially if we are going to talk about scaling. This is not a right framing because scaling really requires specific adaptation and contextualization of the innovation to specific agroecological domains, social settings, systems. So basically, even if it says in Africa, the most important thing to consider here is we need to really understand our specific context where we are trying to scale out or up the innovations that we are considering. We'll definitely go through the concept of scaling and try to understand what are the specific contours that we need to understand in the process of scaling. And then I would try to present two examples that we really engage in a scaling process where we can reflect in terms of our experience and lessons synthesized out of that scaling process. scaling. The concept of scaling, obviously, we know that when we talk about scaling, it is very simple. Literally, it is a matter of taking a technology either into a large number of users or a large domain of geography. But of course, the key question is what we need to really understand to take this technology into a large number of users or a large geography. If we literally define scaling, it is really a process of achieving a sustainable use of an innovation or a technology. A sustainable use, it can be defined in different perspectives. When we are going to be sure that that technology can sustain its use by target users of the technology, we will consider different considerations. And we know that scaling is being used by the dentist. Basically, for the dentist, scaling is very straightforward, and you can see the after and before comparison. But in terms of technology scaling, probably I would prefer the reverse one. We are really going from a clean technology into making it very messy as we take it along the scaling pathway. So that is going to be what we would like to understand and make sense of the process. Basically, scaling as a concept, it can be considered in different dimensions. What is important for us is really horizontal scaling, where we try to spread the technology horizontally without making any adjustment or adaptation to reach a large number of users. And the vertical scaling, this is an important component of scaling where we try to achieve institutionalization of the technology into the existing system. For instance, this is related to integrating the innovation that is to be scaled out or scaled up through the government system, through the national system. So we would focus on these two elements because they are important for us as we go. So in terms of scaling in practice, we know that the national system, international agricultural research systems, we have managed to produce quite abundance of technologies and innovations. But then if we see whether they have been sustainably scaled out or widely adopted, diffused, always that has been a question. That is really the real challenge. So what is really the issue holding back from these technologies from being used very widely? Scaling is really more than a delivery. We will see why it is so. It is really more than a delivery. We need to consider quite a number of components. And it is intentional and imperfect planning that tends to take the technology from a pilot to a wide-scale adoption of the technology. If you see on that side, we have just a few words to characterize the process of scaling. Obviously, we want to be intentional, but we don't have really a complete control of the process because it involves quite a complex interaction of partners, technologies, and quite a number of other elements. When we consider innovation for scaling, often we are not going to think about a specific technology. Usually, it is going to be a package of technologies. For instance, when we try to promote an improved variety, if we are really focusing on the improved variety alone, our scaling would not be successful. We need to think what is going to be the package of the innovations that would need to be taken into account when we are really aiming to promote the adoption of this technology. So we will have a core technology and at the same time complementary innovations that would be identified and as well as addressed for the scaling process. And obviously we said that scaling we can plan, but it is also unpredictable. That requires adaptive management during the process. Scaling really requires intentional learning and reflexive feedback, because when we try to scale, unless we learn and engage in an adaptive management, the environment would change automatically, and the technology context, the system is in a continuous change. Unless we adapt for those changes, definitely our scaling effort will not achieve this objective, and that is why we have the innovation, and the learning component is coming very strongly. And this learning component should not also be considered as a byproduct. We need to be ready to learn intentionally toward this, the process of scaling. So if we consider scaling as a process, there are some guiding principles that we need to take into account when we consider thinking about scaling a technology or an innovation. Basically, the scaling readiness, that is an important decision support tool for any organization aiming to scale a specific innovation, because it tells us whether the scaling process would be successful or not. And often when we talk about scaling technology adoption, we talk very much about the external factors like the availability of finance, market opportunities, and all that. They are important, but they would be very impactful if we understand the technology and its context. Unless we make the technology and its context right, if we address external constraints, we will not achieve the scaling levels that we are expecting. And that is also what our experience really tells us. In terms of the scaling pathways, we could conceive 3 different types of scaling pathway. One is the public pathway, where government would play an important role in scaling a specific innovation or technology. And this is typically the case where the innovation is not aligned to generate an revenue system or aligned with the market system to sustain itself. And often the extension innovations are aligned to this because they have to be taken with a public extension system, since the private sector would be very selective to take those components. The market-led, especially like the seed, is a typical example where we expect the market to take up for the scaling, but often that is not the case. For instance, we know that for dryland crops like sorghum, finger millet, the seed system, especially the private seed system, is not responding to scale out specific varieties. Why? We need to understand and prioritize our investment. Probably I will share one of the examples there. The hybrid, basically this is the public-private partnership. This is also important, especially the tendency is to have the public scaling pathway at the initial stage of the technology development, but once the technology gets matured and achieved a threshold for sustaining market demand, the private sector can even the farmers would come into the picture. Often we try to sell an innovation highlighting its positive impact for their welfare, income, profitability, but the farmers would resist to adapt unless we also address the other component, the risk component. So the responsible scaling is important. In terms of scaling readiness, this is where we need to understand basically where we can say a technology is ready for scaling. We need to do quite a rigorous analysis about the technology and its context. we need to start from characterizing the technology and its innovation system. Generally, the stakeholders, the partners that will be interested in the technology, and then we need to conduct a diagnosis about what is really the scaling readiness, especially to understand what is the context of the scaling. And then we need to strategize, meaning we need to identify what are the specific bottlenecks and what would be the potential solutions. That is where we need to have a strategy to address, especially scaling bottlenecks. And then obviously, once we come up with a package, we need to have a coalition of partners where different roles and specific responsibilities are identified within the system. Well, finally, we need still to be active in terms of learning and navigating the process. So this is going to be important, but obviously this is, these 5 components have a very detailed consideration in their own. Just to show you an example, what does it mean when we say characterize? When we say characterize, basically, we need to understand whether the technology itself is ready for scaling. Basically, we could consider a number of criteria. Is the technology profitable? Is the technology adequately backed up by sufficient evidence to inform scaling? Is it cost effective, profitable? So we need to ask all those questions and come up with a proper profiling of the technology, but of course, not only the technology, but all other components of the technology environment. Is the policy or the regulation of the government in line with the technology, or it works against the technology, market access for farmers? All these components need to be characterized before we think about scaling. So scaling, when the scaling readiness, we can think of it in terms of 2 unique parameters. The first parameter is the readiness of the innovation itself. How mature is the innovation for scaling, and then the usability of the innovation. How widely the innovation is used. We can have different characterization to understand these 2 components, but they are going to be critical in terms of assessing whether the technology is really ready for innovation before even we think of addressing the external factors holding back innovation. Just to take the innovation readiness, obviously the innovation readiness refers to the maturity of the innovation. And obviously, the innovation will be designed or developed through a research system. It starts with idea. It starts with idea. And you can see, we can have different score levels depending on the stage of the technology itself. Obviously, they have their own descriptions. If we consider a technology to be scaled out in this spectrum, basically we need to consider the technology from score 6. The technology should at least have a score of 6 if it is going to be considered for scaling. Before that, if we really apply all those logics, it would not really make sense to consider the technology for scaling without addressing these issues. Basically, you can see from 0, it is an idea level, it is just at the research level. But at 9 and 8, that is where we consider the technology is ready for scaling, incubation, and the readiness level. The readiness level is really a level where the technology can be used without external support, without engaging project support. When it comes to the innovation use, obviously we need to understand who is using the technology. Who is using the technology? If we consider it as ecosystem, the intervention team, basically this is where the piloting phase is happening by the research team. and then we could have some effective partners that are closely linked with the research team that would use the technology with the support of the project, and the innovation network, obviously, within the domain of the technology development. We need to have a stage where the technology is being used by the wider system, the livelihood system, without the support of the innovation. So again, here, we should consider from 7 up to 8 if we are going to consider the technology for scaling. The law of the minimum, this graph really shows that if we have a specific technology, for instance, if I take seed as a technology, I need to have the seed market, the grain market for the grain to be produced, the seed multiplication, the seed certification. All those elements have to come into effect if the seed is going to be scaled out. But obviously, if one of the components of the innovation has the lowest value, basically that is going to be the bottleneck. That is going to be the bottleneck. If you can see the barrel, its content will be determined by the lowest wood plank, and ultimately this is also how the scaling is going to be constrained if we are not addressing the different components at the same time. Examples, I know I have 2 minutes. Basically, a couple of examples. Improved seed variety, especially for dry land crops, since we are very much focused. There is success where the system and the market is working. Without addressing these issues, just have delivering a seed into the system would not take it forward. And then conservation agriculture, which really relates to the term of this conference. Basically, it is mixed. The conservation agriculture really requires a lot of labor and equipment needs. We need to address those elements if it is going to be scaled out. Digital agro-advisory, again, it is very efficient in terms of outreach, but of course, information alone is not ensuring behavior change. We need to see the behavior change that we are expecting. We are also still mixed on this. For dry land crops, obviously, this is what I was talking. If we see the innovation readiness on the y-axis and the innovation use on the x-axis, you can see that the core technology is seed, new seed variety, but of course, it is coming as a package of 8 different components. If we see here, basically, certification of seed multiplication is the core bottleneck. Now, if an investor asks me to invest in the seed system of this specific crop, I would prioritize investment to be made around supporting the seed certification and multiplication, which is really going to be the bottleneck. So this shows us that the delivery is completely different from scaling, and of course, at ICRISAT, we have come up with our own innovation to address these bottlenecks in terms of supporting community seed production and seed revolving fund models in Malawi. The second one, I'm not going through it. This is really one of the successful scaling experience that ICRISAT and partners have managed to develop. Scaling the harmonized digital fertilizer and agronomic solution for Ethiopia, where the government has embraced the technology and we developed a scaling delivery strategy at a national level. And what we do here is basically we develop an advisory solution based on the landscape. So far, fertilizer has been recommended at a blanket level, but this one is addressing the landscape where we also consider the strata of the landscape, the high hill and the mid and also the foot slope. Obviously, this is the work that we have been considered. It has passed through the scaling readiness analysis of the different components, which involves a huge data and machine learning to develop the prototype of the advisory, and then it passes through validation and again And of course, if I have to pick some of the success factors in this, partnership for scaling is the most important thing. We have engaged quite a number of government and non-government partners in this scaling development process. You can see the partners network where we have different roles. Each partner has been assigned a specific role depending on its own expertise, area of focus. And of course, we have also purposely integrated the scaling strategy into the government policy, and at the same time, partners' own programs and projects. Quite a number of leverages have been identified through this process, and importantly, as much as we are focusing on the partnership, understanding the context and also framing the economic analysis of the technology was important. Just to conclude, obviously, scaling is a very complex process that we need to frame it in terms of systems thinking, taking into account not only the technology but also the different actors and components of the system. And we need to be ready to learn as well as also practice responsible scaling during the process. A couple of references that I have used. Thank you very much. I know I have taken...
Thank you. Thank you very much, Dr. Melese. I suggest those who have questions, please contact Doctor directly because we are running short of time. Would that be all right? Thank you.
Thank you, sir. Thank you for your valuable insights and your perspective from Nairobi. Greatly enriched our session. Now I request Dr. Parvez Bantnal, sir, to felicitate the speaker. Dr. McQuinant Millis, Senior Scientist, ICRISAT, Nairobi. He has thrown light on scaling up the agriculture technology and also the realities faced by smallholders across barriers and institutional factors influencing technology uptake, along with the various examples from African farming system. Thank you, sir. Now, I would like to introduce our next speaker, Shri Sagar Katkale, the DBT specialist with the Nanaji Deshmukh Krishi Sanjeevani Prakalp, Government of Maharashtra, a flagship climate resilient agriculture program supported by the World Bank. Shri Katkale is a key technical professional responsible for strengthening direct benefit transfer DBT system, ensuring transparent, efficient and farmer-friendly delivery of program benefits across POCRA's extensive implementation landscape. Sir, I welcome you, sir. Shri Sagar Bharat Katkale. So he's going to throw some light on lessons learned from project on climate resilience in agriculture.
So, good evening ladies and gentlemen. I know it's a whole tired day for you, so I will not take too much of your time. Within the restricted time, I will complete whatever the lessons learned from the Nanaji Deshmukh Krishi Sanjeevani Prakalp, that is a project on climate resilient in agriculture. So, Nanaji Deshmukh Krishi Sanjeevani Prakalp, that is the known before the name of the one of the great social reformer who is the Bharat Ratna awardee from the Maharashtra, that is Nanaji Deshmukh, and this project is implemented with the assistance of the World Bank from 2018 to 2024, and it is also known as a project on climate resilient in agriculture, that is a POCRA. So the project development objective is to enhance the climate resilience and profitability of smallholder farming systems in selected districts of Maharashtra.
So whatever the project is implemented, it is in the selected 16 districts of Maharashtra. We have implemented the first phase of the project. So in the 16 district, we have selected the most vulnerable villages. For village selection, we have taken the ICR Krida methodology, where we have indexed the mini watershed, and whatever the villages that lies within that mini watershed, that are chosen for the project implementation. For ICR Krida, we have considered 3 major factors: vulnerability, exposure, and historical hazards. So all the whatever the government data, that is SECC data, then rainfall data, drought data. So all that data has been compared and analyzed, and after that the selection has been made for the villages. Besides that, whatever the red patch that we are seeing, that's the saline tract. So that is the Purna river basin of in the Maharashtra. So 932 villages in that particular region, that has been also selected. So project duration is a 6 year, 700 clusters whatever we have selected, and 5,220 villages. Across 5,220 villages, we have landholders around 1.7 million and land holding of 3.7 million hectares. So triple win solutions. To achieve the project development objective, we have enhanced 3 triple win independent solution we have proposed, that is enhanced water security at farm level, then improved soil health, and increased farm productivity and crop diversification. Project have phased on the various key areas across the watershed, that is the mini watershed whatever we have selected. First one is the scaling of the climate smart technology that are present. Then focus on farm and watershed management intervention, digitization of climate resilient intervention, support to the FPO, and project itself acting as a mini CIC by acting as a consortium for knowledge and policies. So approach and methodology. So in this slide particularly, I will lay out the whatever the 6 year implementation we have done, because 2 years of COVID, despite of 2 years of COVID, we have successfully completed our financial achievement within the 5 years. By 2023 May, we have completed our financial achievement, and by June 24 we have successfully closed our project. So first one is a village selection that I have already told, that is based on the climate vulnerability indexing. So that's the score on the basis of which we have selected the 5,220 villages. Then community involvement. So here community has been involved in the planning, execution, and monitoring. Just before lecture, there is a social involvement lecture. So project have formed the VCRMC, that is a innovative village climate resilient management committee with the RDD department, that is rural development department. Under the Sarpanch, that committee has been formed, and that's only committee has been empowered to sanction the project of the individual, then NRM activities, then all social audit procedures. So the committee has been given the more responsibility. Then soil water conservations are based on the water balance assessment. That water budget app is developed with the help of IIT Bombay. Then demand driven and saturation approach. This is the key takeaway for this project, because if you search YouTube after this lecture, you will find the many YouTubers in Maharashtra have made videos on Pokhara, because Pokhara is not a government scheme. I will say it has become the movement and it is a popular name in the mouths of farmer, because it's the demand driven and saturation. If a farmer want to adapt a particular climate resilient technology, he have to apply. If he is eligible, he will going to give his benefits for the whatever activity, say micro irrigation. Then existing farmer groups. So in that farmer groups, particularly FPCs, FIG, self-help groups, women SHG, all have been strengthened in the project villages, and social inclusion have been given the more focus. So that's the $600 million project, 70% from the World Bank. So already we have achieved that. Due to dollar exchange, increased exchange value, we have got 700 crore more. So 4,700 crore is the whatever we have spent. Then coming to the project component. So project is having four main components. The first component is the promoting climate resilient agriculture system. Then climate smart post harvest management and value chain promotion, where the FPOs have been given the key role. Then component C is the institutional development, knowledge and policies, where project have tied with the multiple national level institute and state agriculture universities in Maharashtra. And component D is the project management. So in component A, particularly promoting climate resilient agriculture system, we have started with the participatory micro planning. The beauty of the project is that whatever we have done, it is totally digitized. So micro planning process, it's also done through the MLP app. In the next slide, that's also covered. So everything is digitized. So in the micro planning process, VCRMCs have greater role. Then Gram Sabhas have been empowered to do the Shivar ferries and sanction whatever the plan. So village level planning, that is the bottom up planning, has been ensured, and villagers have themselves made the plan for their villages. So it is the VCRMC, Village Climate Resilient Management Committee, 13 executive members and 4 are non-executive, that is the village level officials from agriculture, rural development and department, and cluster assistant and Krushitai. These are the two persons we have recruited from the project also. So out of that 13 members, we have ensured that 6 to 7 members must be female. So women participation we have also ensured, and that committee is inclusive of all. That is the Sarpanch, that is who is the elected head person, then Gram Panchayat member, progressive farmers, FPO members are also there, women self-help group and agri-allied business farmer. So whatever the committee composition is made in such a way that the committee will guide the villages to help implement the project. Then after completing the micro planning, we have the second component, that is on-farm climate resilient technology and agronomic practices. So project have across 5 years implemented 37,000 plus FFS in project villages, where we have almost 15,500 host farmers and 4,90,000 guest farmers. So all these FFS data is also taken in the digitized from our FFS app, and all this data have been now we have given to the university for further analysis also. Project have multiple climate resilient technology, that is bouquet of climate resilient technology from climate resilient varieties, then sowing on BBF, INM technology, INM, IPM, micro irrigation. So all these things have been taken. So broadbed furrow is the most important technology in the climate resilient agriculture, because during the periods of dry spell or also during the periods of heavy rainfall, in both these situations broadbed furrow has been successful and proven technology. So project has successfully demonstrated also, and widespread adoption has been made in the BBF technology. Then integrated nutrient management with the help of National Institute of Plant Health Management, farmers have been trained to make their on-farm production and use of biofertilizer for their own field. Also through FFS, neem seed, kernel extract and all that has been prepared by the farmers themselves. So these are the low cost technology that project have proposed, implemented. Then in our individual farm activities, we have almost got 29,000 horticulture plantation covered through the project. So for various these activities implementation, farmers have been supported through the financial assistance. Almost 700 crore have been spent on construction of shed net houses and poly houses. So particularly in the regions of Chhatrapati Sambhajinagar, Jalna and Buldhana, where the seed product high quality seed production has been taken up by the farmers, and income levels has been also rise. Then besides agriculture department activities, so the project has been implemented by the agriculture, we have taken whatever the allied department activities that also taken into the project. So we have taken the sericulture, then fishery, integrated farming system, goat rearing. So all that has been required to make the village climate resilient. All that activities have been included, and they are implemented by the agriculture department with the technical assistance from the concerned department. Then component A3, that is promoting efficient and sustainable use of water for agriculture. So this is the component where project have made highest investment. So first one is that soil and water conservation works have been carried out. On that area treatment, almost 59,000 hectare, and some drainage line works have been carried out. Then open dug well and well recharge, and third one is the micro irrigation. So micro irrigation is the highest demand activity, and almost we have covered 4.4 lakh farmers and 5 lakh hectares area with the costing around 2,300 crores. So these are the photos of various water security initiatives that has been taken in the project, that is compartment bunding, then desilting, water harvesting structure by CNB. Then with the help of Groundwater Survey and Development Agency, that is GSDA in Maharashtra, we have also recharge trench and recharge shaft activity has been implemented in the project villages, where the technical assistance has been provided by the GSDA department. Then farm ponds have been constructed. So this is the photo in the Jalna, Ghansavangi Taluka. So the project villages and all these assets have been constructed through the projects. Then in component B, we have, after supporting the individual farmers for adopting various climate resilient technology, then whatever the FPOs, FIG, self-help group and women SHG, that all have been supported for the post-harvest management and value chain promotions. So these are the just numbers. So in the FPO, that broader component, we have supported almost 5,211 proposals amounting subsidy of almost 567 crores. In that particularly custom hiring center, then go down processing, post-harvest processing unit and agro-business activity. So these are the all activities that have been taken by the concerned FPCs. And here the support has been provided through our DBT portal. So these are the some photographs, that is the cleaning and grading unit, custom hiring center, turmeric processing, neem oil. So these are the various activities that have been taken by the godowns. Seed production. In this component also we have supported the farmers for taking the seed production of climate resilient seed. So whatever the Mahabis and FPC, in Maharashtra Mahabis and FPCs are taking the production of foundation and certified seed. So we have directly supported the farmers who are taking the certified seed production. Then comes the component C. So here I have, as already I have mentioned, for institutional development, knowledge and policies project have tied with the various partners. So these are the various partners through which various MOUs project have ICR Institute, then CRIDA, NBSS, LUP, then GSDA, Vanamati State Agriculture Training, Apex Training Institute, NIPHM, all State Agriculture Institute, Tata Institute of Social Science and Gokhale Institute of Politics and Economics. So these are all the institutes through which project has strategic partnership has been made. Then capacity buildings and awareness. So whatever we have learned, that the capacity building and awareness is the ongoing process. So throughout the project we have concentrated on the capacity building sessions. Then social audit. So whatever the VCRMC we have formed, so VCRMC has been made responsible to handle all the grievances in the villages itself. So whatever the village grievances that comes, so that you can see that that lady is searching the names of the beneficiaries are displayed in on the walls of Gram Panchayat. She is searching for probably her name is there. So that social audit process has been conducted, and that ensured the transparency in the projects. Project management. So due to the adoption of digitization, and agriculture department itself is implementing the unit, so almost 4.86% project management cost we have completed the whole achievement. Then these are the IT initiatives. The beauty of the Pokhara lies is in its IT initiatives. So I will go there. So whatever the benefits we have given to the farmers, FPC, then natural resource management, all is digitized. Even our all procurement audit, AG audit, all have completed because we give them the access of our portal, and they, so not a single paper lies in our office. So all record is in the digital, and due to the DBT farmer success, Government of Maharashtra have introduced in 2020 MahaDBT. So where all paperless work has been done. So similarly, now DBT farmer for FPC also and NRM also. For as already I have mentioned, FFS, micro planning, water budgeting, so all activities have been carried out using the digitized mode. No paperwork has been introduced in Pokhara. So due to this digitized work, the farmers have been more responsive, user friendly and transparent process has been introduced, and this IT system has resulted in the substantial gain in the efficiency. So these are the numbers of benefits farmer. So coming to the gender wise, almost whatever the benefits we have given to 78% are male and 22% are female. So in Maharashtra almost 17% landholders are female. So the number is substantial to that achievement. So these are the bundle of activities and supported amount. That's I will just take to the key impacts. So increased drip irrigation adoptions. So that is these are the findings of the monitoring and evaluation agency, that drip irrigation adoption has been 15 to 25 in projects. So control figures are there also. So adoption of sprinkler irrigation is there. Then cropping intensity has been significantly increased from 130 to 158. Control you can see it's 137 to 144. So due to the impact of micro irrigation, the cropping intensity has been increased. Also there is a significant increase in the yield also. That's the figures are compared with the baseline. Soybean you can say 26% higher productivity, with respect control you only achieved 14%. So key learnings. So institutional design and implementation. Project have been constructed in such a way that the PMU level, DPIU level and the village level committee and the participatory village mobilization itself has strengthened the awareness, ownership, awareness and demand for intervention. So VCRMC just not only form, they are entrusted with the responsibilities to sanction the various application. Then for watershed and resource development, we have water budget based activities, and that have helped us to increase the water availability. Then FFS has proved to be a highly impact capacity building model. Digital integration and governance. So end-to-end digital system that have ensured transparency, monitoring and direct beneficiary transfer. So whatever the benefits we have given, that's directly in the form of Aadhaar enabled payment system that goes directly to the farmer and then market and post harvest support to the FPOs, that FPOs now are grooming also, and knowledge and partnership we have built with the various state institutes have helped, and Pokhara itself, I have already mentioned, mini CIC worked as a mini CIC. So that's all about it. Thank you.
Thank you very much, Mr. Katkale. That was a very informative presentation. I regret we will not be able to take any questions. You may please contact him directly.
Yes.
Could we move on to the next stage, please?
Thank you, sir. Thank
you. Thank you very much, Mr. Sagar Bharat Khatkale, for your sharing your expertise with us. Your presentation was truly inspiring and includes personal wisdom or touch to our audience. Thank you. And now I request our Honorable Commissioner, Watershed Development Department, and also the Director, Watershed Development Department, Mohammad Parvez Bantanar sir, to present a token of respect to the Speaker and also to the Chairperson, Crispiano Lobo. Now I request Honorable Commissioner sir and the Director sir to present token of appreciation to Dr. Crispiano Lobo. So, I have been asked to announce one kind notice to you all. the participants, the dignitaries who are staying in this hotel and the other hotels, you will be arranged dinner in your respective hotels. This is for your kind information, sir.
While they make arrangements for the valedictory, I have a quick announcement to you all. Instructions for tomorrow visit. 85 participants are confirmed as per our list. Accordingly, 2 buses we have arranged. Buses will start exactly from the Coral Tree Hotel at 7 a.m. Before that, you have to finish your breakfast and board the buses. Those who are having flights in the evening, then you need to check out the rooms and hotel rooms and take your luggage along with you. And you need to, after the field visit, you will directly go to the airport. By 1 p.m., field visits will going to complete. 1 to 2 p.m. lunch will be arranged in the field only. After that, you can go to the airport. And those who are not staying in Four Seasons, Coral Tree and Dacia hotels, you are requested to assemble in this hotel, in Four Seasons Hotel by 7 a.m. And I request respective liaison officers to bring them here. And the contact details for further clarifications of field visit has been displayed on the screen. You can please note down their numbers. For Dacia Hotel, Nitin and Lakshmi Narayan. And for Coral Tree Hotel, Hanumant and Virupaksha. And
Gentlemen, we have galaxies of intellectuals, excellency, eminent speakers past 2 days here in this conference. Now, I'll begin with welcome. Welcome is to show honor and welcome is to establish integrity. Dr. N.B. Prakash, Special Officer, COE.
Good evening, everyone. I know all of you are tired and then waiting for the event to happen. So good evening, everyone. So over the past 2 days, we have witnessed very rich deliberations on the watershed aspects. Many facets of watersheds have been learnt. It is my honor and privilege to warmly welcome all of you for this valedictory function of this international conference. Over the last 2 days, this conference has brought together some of the finest minds and practitioners working in the field of watershed development. climate resilience, land governance, and sustainable agriculture. At the outset, I extend a warm welcome to our chief guest, Sri Nitin Khade, Joint Secretary, Department of Land Resources, Government of India, and Sri Andrew Goodland, Lead Agricultural Specialist, the World Bank. Sri Nitin Khadeji's support and active involvement throughout the past 2 days have been really invaluable in ensuring the smooth and effective conduct of this international conference. Hope all of you have witnessed him, how active he was throughout 2 days in almost all sessions, and throughout his involvement not only by mere listening to it wherever it is necessary, asking questions, clarifying there itself, and really his energy is very, very high. And we have also witnessed how active involvement during the cultural program also. So really, we sincerely acknowledge and appreciate your leadership, which has significantly contributed to the success of this conference, which I hope so. On behalf of all of you, let me wholeheartedly welcome you, sir. And similarly, Sri Andrew Goodland, who has been a key partner in Karnataka's journey of adopting science-based watershed management, LRI-based watershed management, and in scaling innovations through reward program. And his involvement is very much acknowledgeable. We are particularly grateful for his presence in all the sessions of this conference, and his insights and observations have been enriched with the deliberations and strengthened the overall impact of this event. Let me wholeheartedly welcome you also for this valedictory function. Welcome our today's president of the function, Sri Upendra Pratap Singh, Commissioner, Watershed Development Department, Government of Karnataka. Sir, your leadership and commitment to watershed development is highly appreciable, and we are really honored by your presence. We all need to give a big hand of applause by welcoming him at this particular moment. I extend a warm welcome to Honorable Vice Chancellor of UAS Raichur, Dr. Hanumantappa, who is also here. Due to some of the pre-commitment, he could not make it yesterday, and he is a very well-known agronomist, and he has really a very high level of teaching, research, extension, particularly in the Kalyan Karnataka area, and his contributions are highly acknowledgeable. So on behalf of everyone, let me wholeheartedly welcome here. Another active, young, dynamic person who is behind this conference on the dais, Dr. Parvez Bantnal, Director, Watershed Development Department. On behalf of all of you, let me wholeheartedly welcome you here for this function. I also extend a warm welcome to our distinguished speakers, delegates from across India and abroad, colleagues from the Watershed Development Department, and technical consortium partners who have contributed immensely to the success of this particular conference. As we gather here for the valedictory function, I take this opportunity to welcome each one of the conference speakers. We have come all the way from different countries and also from different places in India, and chairpersons and rapporteurs, panelists, and participants. Your presence really has made this conference truly meaningful and impactful. I can say memorable too. So with these words, I once again extend a warm welcome to each one of you, and looking forward to the reflections and recommendations that will be shared during this session. So thank you, each one of you.
Thank you once again for extending welcome remarks, sir. I also welcome Dr. N.B. Prakash, Special Officer, Center of Excellence, on behalf of all the organizing departments. So now I request Sri Nitin Khade, IAS Joint Secretary, DOLR, to throw a light on presentation of the conference key outcomes, sir, please. Nitin Khade, sir, please.
How's the Josh? Good. Huh? So Andrew is going to give me company for presenting the outcome or presenting the summary of the conference. So we both are cricket lovers. Would you like to open? Would you like to open the first slide? Would you like to do? Okay. Okay, next one, please. So it's quite a long day, I understand, but still we'll try to capitulate the proceedings in a very fast manner. Next, please. So we had the first session of the conference on global innovations and lessons in watershed management. So there was a case study presented by our international expert. He presented it on Brazil, so it was on pasture development. So we all understand the importance of pasture development, and especially for the population staying in rain-fed areas, in drought-prone areas, it's more important. So it can very well gel with our watershed development concept, and we can have holistic watershed development along with dairy, along with nature-based solution, ecology, and eco-based services. So we can definitely learn from that model, and we'll try to incorporate this in our upcoming WC3 scheme. Next, please.
Okay, so then we went to China. And I think what we saw from China is quite a sophisticated governance of watersheds. And not only with establishment of watershed commissions, but the concept of a river chief, someone who's responsible for bringing all the stakeholders around a water system together. And when they view watersheds, they also cover urban areas as well. So it's very holistic. A lot of good technology applications as well. So I think there's a lot for us to take away from this. We understand that the context is different in China, and what they are able to do in China may be different to what we can achieve in India. But we need to see what we can distill from the Chinese lesson to apply to India. Next.
Yeah, and in case of China, we would be getting more information from our friend there, Mr. Ruta, he's there. So we have asked him for giving us more information on the LRI practices followed in China, and how exactly their land holding pattern is, and how they are able to do the collectivization of their farming practices so effectively. So hopefully we should be able to get it very soon, and we'll then accordingly include it in our inputs. So in this session, we heard from our friend from Nigeria about what can be the global, what can be the innovations in watershed management, how we can connect watershed development with livelihood systems, how we can have smart water technologies. Along with that, we should include the weaker genders, and we should have social inclusion. I think we have all these aspects in our WDC policy. So the mainstream scheme which we are implementing, it has all these components. We also have a component of FPO under reward, and in WDC also we have it, but we have not been able to implement it effectively. I think we have got very good learnings from that presentation, and the last presentation which we had from our friend from Maharashtra, Pokhara. So I think in India, one of the most effective project in the context of climate resilience and collectivization, value addition, value chain services is Pokhara. So they have already completed the project, and we can see the project up and running. So we have learned a lot from these two presentations, and we'll be including these in our NTG, National Technical Guidelines. Definitely, it's a big thumbs up. Thank you.
Next. Okay, so then we went to Ethiopia, where there's also a long history of sustainable land management projects. These are really embedded in the community. So it's very much a community-led model of participatory watershed planning implementation. And of course, this is something which one of the key lessons we get from India, and we've heard it repeatedly. How do we really embed the responsibility, the ownership of watershed in local communities? The other thing which is impressive in Ethiopia, I think, is the clear link between watershed restoration and agriculture growth. And we've heard this again, and I like our friend from Andrew on coffee. I mean, the starting point always has to be, how is the farmer going to benefit from this? And really putting that first, and then that pulls up the action on watersheds. We also heard a little bit about attempts to leverage carbon markets, attempt to bring in a private sector into the Ethiopia context. Thanks. Next.
We also heard from our Ethiopian friend about the watershed village cooperatives which they have formed, and about the PPP model also. So we'll be getting additional input from him. He has shared his PPT with us, but we'll be getting some additional write-up, and we'll be sharing all these PPTs with you all also, so that you can also go back and ponder upon these, and you can also send some suggestions. That will be most welcome. Next. So, yeah.
Back one.
Okay.
We skipped this one.
Yeah, in the digital ecosystem and data-driven session conducted by Mr. Ashok Chawla ji, we heard how he has and his team and Government of India have created agri-stack structure, and it's also operational. That's the most important thing. I have heard from villagers from my own village that they need to have an agri-stack ID to get the crop insurance money into that account, their account. So it's a validation of the success of the layout of the rollout. Common villager knows about agri-stack. That's a very big thing. And we heard from him how they engage around 0.6 million volunteers in villages who will be doing survey of the standing crops, and it will be submitted to government. And they have made it independent of the regular revenue staff in the villages, which is there for quite a long time, from historical times. So they have come up with some very innovative idea. They are paying 15 rupees 15 to such volunteers for every parcel, land parcels entry. So that has ensured that the data which they are getting is very real. He also talked about how we can connect AgriStack with Watershed or with LRI, and we'll be definitely working with Ministry of Agriculture. They have very ambitious digital agriculture project, quite a huge project. So we will be definitely collaborating with them. Next, please.
Okay, so this just summarizes what we're talking about, experiences from around the world which could be brought into the India context, the power of scientific stratification and integrated crop livestock systems, strong institutions, governance, accountability, linking watershed management with livelihoods, embedding in local communities, and the power of a digital backbone and infrastructure which can be leveraged for better watersheds. So that was technical session 1. Next.
So here we heard from Dr. Patil from NBSS how we can scale LRI in India. NBSS LUP is the leading organization conducting digital soil mapping in India. So we are already discussing with them how we can do it on a larger scale in WC3. We want to take up at least 10 to 20% projects on LRI basis implementation in WC3. So we have already collected the high priority areas for watershed development from our states, and we have given that data to NBSS, and we have asked them to check out whether they have already done LRI of those areas. So if it overlaps, then that is the best case scenario. If it doesn't, then Dr. Patil has suggested some other methodologies by which he can help us in getting a lighter LRI version of the higher priority areas which we contemplate to undertake. So we really want to give in the hands of our farmers an app in their mobile so that they can easily access all these services. All the decision support systems, they are to be provided to them, and we have already discussed with Karnataka in the afternoon session that they will definitely look into the possibility of engaging a vendor and how they can monetize it, and the vendor can give these services, and I think that will be a great thing. Right now, we are doing everything on our mobile. We are transferring money on our mobile. We are not going to the bank and filling that slip. We are booking our railway ticket. We are filling our forms, everything. So why not our farmer, our village community, our ground level officials should be able to do the watershed related planning on their mobile, on the click of their finger. So we want to provide these decision support systems to our stakeholders as soon as possible, and we want to change the way watershed development is implemented in India. So that is our goal.
Okay, so this is a continuation of that session and some of the themes we looked at. So one was on how you integrate the hydrology, spring-shared aquifer-based approaches with hydrology-driven planning. A clear emphasis on water budgeting, and that sort of links us again, I think, to the final presentation on Maharashtra, Pokhara. I mean, this is one of the founding principles and why that has been successful. So basically, at the community level, matching your production pattern with available water resources through a water budgeting process. Private sector participation is one of the strong themes. We know there's a lot of capital out there. How do we leverage that for watersheds? And we sort of touched on this at several points during the discussion. I don't know if we've cracked the nut on that. We talked a little bit about CSRs, understanding the CSR ecosystem. We talked about how do you actually bring in a private capital, for instance, into agriculture value chains. Anyway, and to release this, what sort of a policy mechanisms do we need? And then on the technology, data-driven decision making, some fantastic examples we saw, including from Karnataka, on how these applications have been developed, how they're being deployed. There's so much learning, there's so much good examples out there. How do we actually bring this all together? I mean, how do you take it to scale through a national program? I think that's the challenge which is still ahead of us. Okay, next.
So here I'm also very happy to share that we could get a commitment from one of the participants who would speak to Niti Aayog and as well as from CEO Rajasthan that they would conceptualize a project involving a solar power corporate or a project, and we can pilot solar power project or agrivoltaic or pastoral voltaic with watershed development of that area. So that will be a big thing to happen. As I mentioned, we are short of investment funds for taking up such a large area, which is there, which we need to cover. So I think if that comes through, that will be one of the biggest achievements of this conference. Okay. Then the other takeaways were regarding carbon credits. So here I would like to point out that we heard from the gentleman who has developed a coffee plantation in Araku Valley. So it was very informative. We can definitely think about the possibility of providing this carbon credit benefit to the farmers staying in our watershed project areas. One area here when we need to work upon, the point is, as far as we understand, the carbon credit is available only to permanent plants. That means in our case to horticulture. We are growing some seasonal crop, it's there for 3-4 months. Some of them, they do help in carbon sequestration, but as per the international protocols, we don't get any credit for that.
So I think here it's very important that we try to encourage our farmers to bring more and more of their land under horticulture. And I think we all should learn it from Karnataka. Karnataka has reached around 15 to 16% of their project area in case of horticulture coverage. Other states are struggling, someone is at 2%, someone is at 4%. So along with the increased income under horticulture, the farmers will also be able to capitalize on carbon sequestration if they go for horticulture. So other takeaways where we need to have better community-led governance, and we need to maintain these structures. We have to have FPOs, village organizations, to take care of them. We also need to have the village level watershed cadre, motivated cadre, which can take further these works. We are in a way sowing the seed. They should ensure that it becomes a tree in the next 20, 30 years. Or we can say that we have provided them with a nucleus. Now they should build the orbits around that. So I hope that this strategy will definitely ensure the increase in the sphere of influence of watershed projects, which we are not able to see right now. Please.
Okay, a number of areas where we discussed require policy gaps. I mean, we talked a bit about data governance. Is the policy enabling the collection, sharing, and utilization of data? This is really important to protect the farmer ultimately. Is the current policy framework a fit for purpose for supporting a watershed management? I mentioned a little bit yesterday about how there's a sort of tension between different policy goals, which may be different for agriculture, for fertilizer subsidies, and the aims that we want to achieve in soil health. So we need to understand a little bit more about what the framework is, where are the bottlenecks, and how this can be addressed. And finally, you know, the global knowledge exchange is why we're here. We need to do more than this, more than just coming together once in a while. And we need to build, I think someone mentioned like a knowledge hub, a way that we have more seamless a sharing of knowledge, a place where we can all go and share and learn and apply in our own context.
In this session, we learned how we can diversify in dryland agriculture practices, how we can go for climate resilient varieties, how we can make great use of all these technologies regarding soil health. Our friend from Canada, he mentioned about some emerging technologies like use of sensors, like use of some kind of instrument which can go inside the soil, and it will give us these soil characteristics without we actually digging it. So these are all in pipeline. If these come up, I think then doing LRI in future can be very, very fast and easier. Right now it is able to give us only the soil moisture content, I think. But with, I think, more research, it can help us in getting other characteristics information also. So if that comes through, I think that will be a great, great boost.
Okay, so I think one of my takeaways from this session was just how much is out there in terms of data, and we learnt about different systems, and we heard how some of these things are going to be coming online. So the amount of data is already significant. It's only going to increase. We do need standards for the collection of data. We need standards for geotagging of data. And then we need to put in place the institutional mechanisms to firstly share the data, but then support capacity for utilization of data on the ground.
So we have discussed about the public-private partnership, which is possible, how it can be monetized, and how we can promote a collaboration between our sector and solar energy sector.
Okay, when we talked a little bit around, I mentioned it already, the CSR. I mean, how do we get corporations to come into this space? How do we develop the partnerships to accelerate ideas and ensure a follow-up on PPP initiatives? We need to understand, I'm sort of going back to some things we discussed before, about leveraging watersheds as a platform for livelihood development. Because ultimately, I mean, that's what we're here for. And bringing together multiple partners, government, community, and the private sector to create an ecosystem for supporting increased incomes of farmer households.
I think we have discussed all these takeaways. So we will we'll move to another one that is regarding impact assessment. So we heard about an interesting method of impact assessment, and it was reward project against the WDCPM KSY project. So it was quite interesting, but reward project is yet to get completed. So we'll have to wait for some time, and then we'll be able to get the proper picture, and then the evaluation can be fairer. So this methodology is quite interesting. We'll definitely explore this once we have passed 2 years after rewards completion.
Okay, then we had this great example from Araku. I mean, a long journey. I mean, it takes time to work with communities to develop a very holistic approach to livelihoods, a link to the environment. It was actually very inspiring to hear about what can be done and to see, you know, from this relatively small community, tribal community in Andhra Pradesh to a shop in Paris and one coming in New York. I mean, that's absolutely incredible. I guess the challenge is how you make that kind of model, how you can replicate it. We need to celebrate it, and of course, you know, it took a long time and very close engagement from Nandi NGO. Are there elements of it which we can then build in to develop other approaches? And I do like in a way, the cluster approach to thinking about this. You know, other parts of the country, there may be a different commodity, not coffee, where you can really build a value chain, develop returns for the farmer, and build the entire ecosystem right back to the watersheds to be able to deliver on that. So that kind of like, that scale of thinking is what we need. So that was a very useful case study.
And in the end, we had a session from Pokhara representative, and I have already described the takeaways from Pokhara, and I think there was no other session which is missed.
Oh no, we had the science of scaling.
That was very interesting. It was so scientific, and I think that is the real challenge. How do we scale up? So, though we might have done successful pilot, but when it comes to scaling up, that is the real challenge. So, if we are successfully implementing Elaga in Karnataka, I think then it will be a challenge for us to scale it up across the country. So, we have thought over this. For example, in case of LRI, when we had started thinking around a year back, how can we make it simpler? How can we make it lighter? So that the common public understands it easily, so that we don't spend much time on doing the LRI process. So then we got into touch with NBSS, we got into touch with SLUCI, and then we got to know, earlier we were thinking that we'll have to do the LRI of entire country. But then we came to know, no, it's already available around 3-4 crore hectare data, LRI data of 3-4 crore hectares is already available with these two organizations. So we have definitely thought over this aspect, and we have found some solution. If we have to scale it up, we have to do it effectively as well as in a faster way. So I think that session was quite useful for understanding the challenges.
Okay, and then we had Dr. Murthy, of course, talking about community and good practice in terms of supporting communities. With a rather sort of honest assessment, but a lot of what we've done in terms of watershed committees so far has not been successful. And he came to the 3 E's, now testing my memory. Educate, enable, and empower. I hope I got that right.
So a big round of applause for Dr. Murthy. He conducted the session post-lunch. So I think that was a big challenge. Everyone was a little dull after lunch, but he made it interesting. So we have covered this summary of all the sessions. There may be some additional information which we'll be gathering. We are going to get information about LRI practices in countries like US, in France. So if we get hold of that information, we'll definitely try to find out how we can adapt those things in Indian context. So I'm really thankful to all of you and to Team Karnataka, ably led by Sri Upendraji and Parvez and COEs, officers, and very well guided by my good friend, Mr. Andrew. So please give a big round of applause to the organizers. They have organized the conference in a very effective way, excellent arrangements, good content, stimulating thoughts which have been discussed here. So we all are quite enriched at the second day of the conference. Tomorrow we are going to field. We'll be seeing how they have implemented the LRI and other practices in the field, how the farmers have used the LRI card provided by them. So that is going to give us a different kind of feedback. I request all of you to please give your observations on that. It's still midway. Not all farmers have changed the cropping pattern based on the LRI, but some might have changed, or they have now undertaken a LRI Yatra, a special public outreach campaign to encourage farmers to make use of LRI cards which they are giving. So I think we will be able to see the results of LRI card distribution after a year or two. But still we will be able to see the beginning of these results tomorrow in the field. So I request all of you to have fruitful discussions in field when you will be visiting tomorrow. And on the results which we get here, it is dependent how we scale it up in the entire country. If we propose to scale it up in the entire country, obviously the evaluation of the pilot will be very important. So tomorrow is an important day. We'll have a feel of good Bangalore weather in open. 2 days we are sitting in this hall, so it will be a good break also. So we will make most of tomorrow's visit. So thank you all, and जाते जाते मैं इतना ही कहना चाहता हूँ कि हम जो सब लोग काम कर रहे हैं कि the degraded land which we are making fertile and we are making it more productive. So we want our farmers to have such a good produce which is as valuable as gold and diamonds. So there is a famous song in Hindi, मेरे देश की धरती, मेरे देश की धरती सोना उगले उगले हीरे मोती, मेरे देश की धरती. Thank you all.
Vande Mataram, Jai Hind.
Thank you, sir. Thank you, Nitin, sir. Such a wonderful presentation. Thank you, Andrew Goodland, sir, for delivering an excellent presentation on key outcome of the conference. Your clear synthesis of the discussions, insights, and recommendations provided the House with a comprehensive understanding of the collective learning from the event. Thank you both once again for helping us to conclude the event in such a meaningful note. Thank you so much, sir. Now I request our chief guest, Dr. M. Hanmantappa, sir, Vice Chancellor, US Raichur, to address the gathering. Sir, please.
Good evening to everyone. So, our speaker, Sri Nitin Khade, IAS Joint Secretary, and Sri Andrew, they have summarized the yesterday and today's technical sessions. And our President Mr. Upendra Pratap Singh, IFS Commissioner, Watershed Development, and also Mohammad Bantnal, and our friend Dr. Prakash, and all the members, delegates from the different parts of the country as well as international over the sea. And so yesterday, I think you are very much discussed with respect to the watershed is concerned. So we have to manage in watershed approach basis only. In the watershed, we have all type of this one. So agriculture, horticulture, animal component, so village, and all these things we have seen and some of the release, gullies, all these things we can see in the watershed area. How we are going to manage it to be used for this? We have to produce all food, fodder, fuel, fruit, fish, all these things we can get in the watershed basis. So that we have to manage to sustain the farmers' livelihood. That is most important, where we have to take, that is appropriate. So we have to make in the system wise. So we have to not in a single basis. So we have to go with a system, that is a particularly watershed approach. So in that cases, we have to maintain the natural resource, particularly soil as well as water. How we are going to conserve the water to increasing the watershed development and as well as a recharging of our waters in the particular area. So how we are going to collect and safe disposal of water through the pond. All these things we have collected with respect to the reward project and earlier Sujala watershed, all these things we are implemented in different parts of our state as well as a country. And also this year we have received a reward project from the last 5 years. So we have our universities also implemented with respect to the LRI and hydrology. So we have collected the data, very land resource inventories, and also soil moisture. Based on that, we know that even though we have organized the agroclimatic regions, within that there is a change because of the availability of the moisture. So that we can have a change of cropping system as well as a soil moisture availability with respect within the zonal, this is zonal concept. So that we are thinking in that, and our university through JS, Dr. Rajesh is doing well. Now he is in remote sensing, the director, and also Satish Kumar is doing the LRI and hydrology studies, and other Vishwanath and other our university they are doing. Already we have completed almost end of the project. So this international conference definitely helpful for especially we have discussed thoroughly with respect to the best practices with respect to the Brazil, Ethiopia, Nigeria, and other countries, different countries. We have discussed thoroughly, and we have to implement wherever possible with respect to the international collaborations. And also, we have discussed with respect to the how we have going to, especially last session, I attended the Maharashtra. So they have maintained very clearly with respect to the last 5 years. Only thing, further how we are going to maintain that is sustainability is very, very important. So he has first 4-5 years, they have maintained with the project. Once the project over, that who has to look after that, we has to maintain. It is a general public places. So some of the structures we are constructed, that we have to taken care with respect to the, we have to take in the, how we are going to maintain the natural resources by especially animal component, forestry component, so agriculture component, where we have to plan with respect to the different system-wise, we have to plan with respect to the watershed model, either micro watershed, macro watershed. Like that, we have to analyze the situation based on the soil and the structures we have created, and the farm ponds also we have harvested, how we are going to sustain the life and circulate with respect to the natural resources concerned within the system itself. We have to transfer our technology in terms of system management, not in the individual, so that we have to think and maintain the soil health. Ultimately, if the soil health, if it is a eroded soil, we don't have any nutrition, definitely it will have facing a lot of problems with respect to soil management. So that we have to very clearly with respect to the water management and as well as a soil moisture management, and also different crops, we have to harvest and maintain the livelihood of the farmers of country as well as international level, so that we can definitely where we have to grow which type of crops, especially some of the crops are very low fertility as well as moisture requirement, especially millets and grasses, where we have to grow grasses. Those things we have to apply our mind, and we have to sustain in the soil sustainability with respect to the production as well as the soil health. We have to maintain the entire system. Definitely this type of international conferences helpful for the future roadmap for the how we are going to take up the decision. So I think we have discussed thoroughly with respect to today, and tomorrow definitely we are going to see the actual practical adaptability, how it is. Is there any drawbacks, any suggestions? Definitely you can go through the tomorrow's field visit. So that definitely these 3 days it will be helpful for. I congratulate the organizer for giving me the opportunity to share few things. Yesterday I could not join for this workshop because I am in Delhi. So yesterday night only I came, and today definitely I participated after my preoccupied works. Thank you one and all. Thank you Dr. Prakash for giving me the opportunity, and all other commissioner as well as this one. Thank you one and all.
Thank you, Dr. M. Hanumantappa, Vice Chancellor, University of Agricultural Sciences, Raichur, for your experience, reflection, and suggestive perspectives on watershed resilience, development, and also the sustainable agriculture. Ladies and gentlemen, now it's open for feedback from the participants. So we have got only 2 participants who are going to express their views on these 2 days of conferences. Only 2 participants, first come, first serve basis. Each participant has got only 2 minutes time. The participant, yeah, actually we provide you the handpiece over there only. You can express your views and thoughts from there only, sir, please. The participant who is interested can raise the hand, you'll get the handpiece. If no views, probably I think we can wind up this now with presidential remarks. I request Sri Upendra Pratap Singh, IFS, Commissioner, Watershed Development Department, to address the gathering with your beautiful presidential address remarks, sir.
Very good evening to all. I still feel that participants are having some patience. In the outset, I would like to thank all the participants for their patience and interactive listening. And I would also like to thank Government of India, DOLR, World Bank, Center of Excellence for organizing this beautiful conference. And it was a joint effort, and I think all my department officials and under the guidance of World Bank and DOLR. So we took up this conference, to organize this conference, and you people made it a successful. This is my observation because I find so many people are still sitting in the hall. It shows that the conference was a successful. And last 2 days, we have been flooded with the knowledge. And as far as myself is concerned, I am just 4-month-old in the Watershed department. And I was so much enlightened by the views and the ideas which were presented here. And I hope that all of my colleagues must have been enlightened and enriched in their knowledge. Only few things I would like to say because already it is getting late. Whatever I could understand is that the watershed management needs change of approach. The approach which has been followed till now, we have to change it or modify it. Second thing, we have to use the technology, and whatever it may be the name of the technology, but now watershed management needs technology input. Third thing which I could understand, and I am a supporter of that thing, is the community participation, because changing the mode and technology input without the community participation may not be as successful as we are thinking. And the new concept which has come last 2 days is the participation of the other stakeholders, whether it's private or public. And this whole conference, I think, was wonderful, and all our guest speakers who we have invited, they have done the justice with these subjects, topics which were given to them. And I would again give my heartfelt thanks to people who have traveled across the country. They came here, they make the 2 days workshop and seminar successful. So again, I would like to thank the people who have supported us, because there are the people who are behind the screen. They are not in the hall. So I would like to thank those persons also with their dedication and their support to make this international conference successful. So with these words, I would like to stop here because already it's quite late. Again, before I leave the podium, I thank each and every one of you very much. Thank you.
Please give a big round of applause for Upendra ji and his team. I would also like to congratulate the officials from my office, Dr. Reddy, our Senior Additional Commissioner, and his team. They have taken a lot of efforts. Uma Kanje is also here. The team from NARA has also made a lot of efforts, and I also thank Prakash ji from Center of Excellence for giving all the support. Thank you. And thank you, Andrew. Thank you.
Thank you, sir, for the presidential remarks. Now I request Bantnal, sir, for proposing vote of thanks.
Thank you. Thank you very much, sir. I take this opportunity to thank wholeheartedly our Joint Secretary, Nitin Khade, sir, who constantly supported us and made us to organize such a wonderful event conference in Karnataka, that too in Bangalore. Really, sir, I would wholeheartedly thank on behalf of all the participants and all the department staff from Government of Karnataka. Thank you very much. मैंने जब सर को पूछा, sir, we were not knowing that sir is such a good singer. So I thought that he will sing. So yesterday, earlier only I proposed, sir, कुछ गाएंगे आप? हाँ गाऊंगा यार, he told. I thought, अरे कुछ मुकेश या किशोर कुमार का जैसा मेरे सामने वाली खिड़की में, that kind of song he may sing. When he came to stage, he started tar 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 tar. Everybody started jumping, energetic, so energized. Everybody was so energized, so energetic singer he is. So really, sir, we appreciate you and we really thank for motivating us yesterday and today. Because of you, you were so energetic and everybody was sitting. And I think many people are waiting for your karaoke, one more song after this also. It is better if you could do that. We really thank you for your kind support, sir. I would like to thank Hanumantappa sir, Vice Chancellor, for gracing this occasion. I would like to thank Sri Andrew Goodland, Lead Agriculture Specialist, the World Bank, and his team, especially Murthy sir, Natarajan sir. I would like to request World Bank to organize such kind of events outside the country, so that you can give us an opportunity to visit outside the country also. So please bear in mind, please, we have funds, let us move out of this country and let us see the works that have been practically done outside. So that every time we keep on hearing by only through this one, what you call audio visual modes, but practically let us go and see, so that our people will also get motivated by this. We request you kindly arrange for this, since June is the end of this reward program. Before that you could arrange, we have funds, let us move outside, either in China or in European countries somewhere. So I requested ULR for to take up the issue also. I would like to give big applause for our Commissioner Watershed, without whose support this would have been not happened. Because there was a dilemma in organizing this, fixing up the venue of this conference. We were thought of doing it in Hassan, later in Belgaum, but there was a question came, later Preeti Madam came, she also gave some kind of ideas whether there is any connectivities, and that was this, and again we are going to have our this one winter session of our Vidhan Soda in Belgaum. So there were a problem with the booking of the hotels and so. Later on, finally we decided to go with Bangalore only. Again there was fixing of the venue within the Bangalore also. Since finance was the constraint, there was too many headers was there. But still then, our Commissioner sir and Secretary sir especially went all along the way, out of the way, and he went and supported us. Sir, करना चाहिए, करेंगे, जो भी होता आगे देख लेंगे, अरे यार चलो करो. He used to support us all the this one, sir. Really, sir, thank you very much for your support. I would like to thank, especially a big applause for our Center of Excellence, Dasok sir and Nagraj sir. So please raise up your. So they have really tirelessly worked day and night in getting the speakers from across the country and also across the world. So without their effort, we could not have heard such kind of wonderful speakers here. We could not have such kind of wonderful speakers. I also thank Sir Prakash sir, head of the COE, for constantly supporting them in doing all these kind of activities. Thank you very much, sir. I would first and big round of applause for our WDD team. Please raise up Jayaswami, Lakshmikant, Geeta, Renuka and our team. And without who has really, within the short span of time, they have struggled and all they have put effort, lot of effort in arranging the lodges nearby and for transport also, for food, everything they are looked after very nicely. And really a big round of applause for our watershed development team and my officers and also my district officers who supported directly and indirectly in successful completion of this conference. Special thanks to our speakers who are all the way come from different parts of the country and different parts of the world. Your presence made us great, and we are so enthusiastic about to look into your activities that you have done in your country. So we are waiting for your invitation to our government so that we can put a proposal in front of the government so that we can come and visit your country also. Thank you very much, all the speakers. So anchoring is a very toughest job. All the 10 to 12 hours they have to sit here continuously. Participants anytime they can rise up and go and have tea and come. But anchoring is a very tireless job. Mr. Noor Samad and Dr. Shweta, who has done excellent anchoring, and they have maintained very well timing. They have given and they have done very anchoring good work very well with a good time management, and especially Noor Samadhi has to give some kind of shairis in between so that people can motivate out from it. I really thank Noor Samad and Dr. Shweta. I request our joint secretary Saab to honor both of our anchors. Please, Shweta, Noor Samad. A big round of applause for them. Last but not the least, I would like to thank all the participants, all the SLNAs who have come, who have accepted our invitation, and who have all the way came here and made this conference a successful one. Without your presence, this could have been incomplete. I would like to thank one and all DOLR and their team and all our district officials, all our partner institutes who had helped us in organizing such a wonderful conference. Thank you one and all for your gracious presence. Thank you, sir. Thank you, one and all.
Thank you, Sri Mohammad Parvez Bantnal sir, Director, Watershed Development Department, for proposing. Ladies and gentlemen, this is our deep gratitude goes to all the participants for their active involvement, making this conference a grand success. We hope you have gained valuable knowledge and made important connections. We look forward to seeing you at the future events. This is Dr. Noor Samad. We are signing off this International Conference on Watershed Resilience, Integrating Science, Sustainability and Agriculture. Have a wonderful field trip tomorrow. Goodbye.
dinner is arranged at your respective hotels. You can have dinner there. Tomorrow morning at because it is 1.5 to 2 hour journey from here. Tomorrow, whoever is living for here. The bus will leave you at the airport itself, because it will be easy for us from coming from Tumkur directly to airport. It will take 1.5 hour to 2 hours. Instead of that, if you come here and again go here, it may cost you 4 hours journey. So I request you to check out whoever wants to go in the evening. So check out.